I think in the paucity of time, we will start. Good morning, everyone. Welcome to this 136th edition of the Zak World of Façade conference series. My name is Ahmed. I'm part of the organizing team here at Zak. I'll quickly introduce the event to you, and then we can start the program. Can we have the screen switched? Right. So we've been organizing the Zak World of Façade conference series since 2012. We started it as a small, humble event back in India in July 2012. Events now grown across the globe. We are organizing this event in 40 countries around the globe. This is a calendar of events for 2023. So it's spread right from New Zealand up until Canada. Different events in different regions, in different languages. Facades are designed, engineered, installed differently. Different regions have different codes, different outlook towards designing facades. Some regions are advanced, some regions are upcoming. So it's been a great experience for us organizing this differently in different parts of the globe. This is our calendar for 23. We're almost done with it. We've just got 4-5 events left, but we've had a great year. And we're back to Vietnam again. So this is our third event in Vietnam. So we had our first event in Chi Minh City in 2019 in August. Not sure how many of you attended that event. We had an event in Hanoi last year and now back to Chi Minh City. So we've got different set of speakers talking today. Everyone has a different story to tell on the way building envelope facades are designed. So I hope you'll enjoy today's day. But I'd like to start first by thanking our event partners without whom this wouldn't have been possible. Starting with our presenting partner, Souquet. Souquet is the world leader in aluminum door, window, curtain wall systems. They've been a strong supporter of this conference series globally. Our associate partners, starting with AkzoNobel. AkzoNobel is a leading powder coating and liquid coating supplier. Beijing Huan Thiaobo glass, WHTV glass as we call it in English, one of the leading value-added glass processors out of China. Another leading glass processor out of China, value-added solutions, jumbo glass, good coatings, China Southern Glass. Dow is the mother company of formerly what was known as Dow Corning. So they are the global leaders in sealing and bonding solutions. Elvalkala, Greek manufacturer of non-combustible aluminium composite panels, been very strong in this region from years. Equitone, European manufacturer of fiber cement products used for cladding, again a non-combustible solution and a sustainable option. Jotun, again a European manufacturer of powder coating solutions for aluminium doors, windows and facades. Kinlong, a Chinese manufacturer of glass hardware fittings and a lot of other value-added stuff like LED facades, railings and other stuff. Curare is the mother company of the laminated glass interlayers, Peeraphol and Sentry Glass. Again, a global supporter of this conference series. Vector Foil Tech, a German manufacturer, installer, engineer of ETFE solutions. Again, a strong supporter of this conference series. Followed by our technology partner, Orgadata. Those who have the red color lanyard, you'll see a USB stick on your lanyard. That is courtesy Orgadata. The USB stick has all the brochures of all our sponsoring partners in that USB stick. So all our associate partners and above have a booth outside, so please network with them in the breaks. Most of the presentations are in English, so we've got the translation headsets kept on your table. Those who don't have it can collect the translation headsets from the back. But of course, we've got our host, Jolene, who will be bilingual. She'll also be speaking in Vietnamese and bring some local connect to this event. Our next event is our biggest in the series, which is in London on the 8th of November. So this is our largest event in the series, close to 1,000 delegates attending. We've got another one in Frankfurt in Germany. The one in Oslo in Norway, and our final event of the year is in Saudi Arabia at the end of the year. Just a little bit within the region, so we've got our 2 Australian events for next year with Brisbane in February. I know a lot of Vietnamese people export to the Australasian market, and of course our a big one later the year in Australia, in Melbourne. So these are our events in the extended region. We will also have events in Southeast Asia next year, in the Philippines, in Kuala Lumpur, in Malaysia, in Bangkok, in Thailand. So this, we keep going. Every year we have different speakers being invited, talking on their experiences, on the way they design, engineer facades. So today's program is no different. Very interesting set of speakers from within the region and also locally from Vietnam. So you have a mix of people from within the Southeast Asian region as well as locally based here in Vietnam. So I hope you enjoy today's event. We've recorded today's event, so the presentations we've got permission to share with you. They will be sent via a YouTube link a week from now at the event. A week from now after the completion of this event. You will get it along with a feedback form. So once you fill up the feedback form, you'll be able to access the YouTube link. So that's it from me. I'd like to call upon today's event host, Jolene Huynh. She's from Sahvia Façade, one of the leading facade consultants here in the extended region. So she'll be hosting today's event and be taking you through until the end of the day. So that's it from me, and I'll want to call Jolene on stage to take over. Thank you.
Good morning. Thank you very much, Ahmed, for setting the tone for us today. Xin chào tất cả các quý vị khách mời cũng như là các quý đối tác. Tôi là Jolene, là người chủ tọa và cũng là người dẫn dắt chương trình, sẽ đồng hành cùng với quý vị cho đến phiên thảo luận cuối cùng. Thì đây là lần thứ 3 Zak World of Façades đến với Việt Nam và cũng là lần thứ 2 tại thành phố Hồ Chí Minh. Trên phạm vi toàn cầu thì đây là phiên thảo luận thứ 136. Thì xin lưu ý là trong suốt phiên thảo luận vui lòng giữ điện thoại của quý vị ở chế độ im lặng. Và tất cả các câu hỏi sẽ không được đặt trực tiếp đối với diễn giả. Chúng ta sẽ có khu vực networking area ở bên ngoài. Thì đây là một cơ hội rất tốt để mọi người có thể kết nối với các diễn giả. Và xin hãy dành một tràng pháo tay thật lớn cho Mr. Stephen Pimbley from Spark Architect.
Okay, good morning, everybody. It's always a little bit daunting to be the first speaker, but I'm excited to be here, so let's see how we get on. Before I talk about, I suppose, the main subject matter of what I'm going to present to you today, which I've called the regeneration game, I want to give you a little bit of background about what I do and what I've been doing. But before that, I just want to show you a few images. Kodak cameras versus architecture. And for those who are familiar with sort of modern movement architecture, you recognize the building by Mies van der Rohe and a Kodak camera from the 1920s. You could argue at this point in time that the architecture is in advance of the technology of the camera, but both very beautiful things. Later in the 1950s, the sort of ubiquitous box Brownie camera against a wonderful building in New York by SOM. Again, the architecture is better than the camera, I would argue, anyway. And later in the 1970s, the sort of almost disposable Kodak camera against a curtain wall building. I'm not sure where it is, but it doesn't really matter. Cameras taking over. Up to today, the sort of ubiquitous Apple iPhone against a very boring curtain wall facade. And there are architects, particularly in the UK, like Thomas Heatherwick, who is complaining about boring buildings in cities. And it's unfortunate, you've got this great technology of the camera, now far better than the architecture or the technology in building facades. Why is that? Why isn't progress as fast in our industry? I know that construction is this huge leviathan that takes a great deal of time to turn and move in a particular direction, but it's important that we do move forward. But before I started to work in Asia, sort of 23 years ago, I was living and working out of London and France and the Netherlands and a little bit of time in Germany. And the sort of work I was doing, this is in 1990, a building that we designed for the Seville Expo, which is very organic in its form and uses the sort of environment to help naturally ventilate the building. Quite curvaceous, interesting shapes that responding very well to the environment and the environment sort of articulating the architecture. And then we won a competition in the south of France in Marseille to design the government headquarters for the Bouches du Rhône government. And again, we used the ideas of Seville to sort of animate and articulate the architecture, using the wind in the south of France to help naturally ventilate and cool the building. It's quite a complicated building. It was the biggest building being built in Europe at that time, at just over 150,000 square meters. It was the last of François Mitterrand's Grand Projet, as they were called. And parts of the building were very complicated. And this is circa 1990. And we only had 2 computers for 60 architects in the office. And most of the drawings were done by hand. Very few of the building components, building sort of components, were drawn by computer at that time. And we found it very difficult to try and find the form to clad this very interesting shaped building, and worked with our engineers, Arab, to try and form find a typical tile that we could use across the building. And this is a drawing that I did by hand, which sort of describes the detail of that cladding system, which was stove enameled steel panels. And here you can see the building completed. But interesting architecture at that time, and interesting forms. And perhaps things aren't quite as interesting these days. You can see the sort of technology here, the lateral ribs clad with these triangular coated panels. Very beautifully constructed. Very nice project to work on, actually, especially because it was in the Mediterranean. And a little bit later on, I mean, this is not a segue to the guy from Foiltech who's going to be speaking a little bit later on, but this is when I was living in the Netherlands, in Rotterdam, designing an information building for a master plan that I was working on for the city centre. Sort of a very simple steel basket structure, clad ostensibly with 3-layer ETFE foil. Again, nice project. And this is the master plan. It was the center of Rotterdam, a railway station and office spaces and a gallery for ING, Vascode and NS Railways. A very interesting project, which eventually wasn't constructed, but we did build one component of that master plan, which is a mixed-use project called the Calypso, which is apartments, a hotel, and a church, and some incubator units for small businesses. But again, it's quite simple, faceted, tessellated structure, clad with aluminium and copper. So a very iconic building in the center of Rotterdam. So that's where I've come from. That's quite a long time ago. It's almost 20 years ago. But you see this statement quite a lot, that the climate, it's in every newspaper in every country around the world, climate is changing. So it's in the New York Times, The Guardian, Le Figaro. And what are we doing about it? There are lots of architects in Europe saying we build too much. David Chipperfield is saying we should not knock down any buildings. They should all be regenerated. And there should be a carbon tax on new buildings. And if we do build less, what's the point in conferences like this? Very few buildings for us to talk about. So there has to be a sort of balancing act going forward where we work more consistently and reduce carbon levels in the environment. So this conversation I've called the regeneration game. It's a sort of pun on a game show from the UK in the 1970s called the Generation Game, where they gave the contestants very difficult tasks and a very small amount of time in which to complete those tasks. It sounds like the business that we're all in, especially in architecture, where clients expect at the earth don't give you very much, they give you a very short space of time to conclude the task. And this woman, Jane Jacobs, an American urbanist, wrote this, which I think is quite important. Old buildings can sometimes use new ideas. New ideas must come and use old buildings. So we've done a lot of this quite recently, in particular, the last 10, 15 years. But the first project I did, again, it's using ETFE foil. It was the first time foil had been used in Southeast Asia. The only other project that used foil at that time was the Beijing Olympics, very successfully in the water cube. This is Clarke Quay in Singapore, a very sort of run-down area at that time, part of the old lifeblood of the city. And I'll say that a few times during this conversation. The sort of activities that were once at Clarke Quay, which is about goods coming into the city up the river and then being distributed throughout the city had sort of gone and moved away. Technology had taken over. So what to do with this project? And our client, Capital Land, really wanted to regenerate the area, but not in the old business sense of shop houses selling rice and goods to the city, but as a nighttime destination, part of the tourism infrastructure, if you like, of the city. So we were given the task of changing the nature of Clarke Quay, bringing this new sort of plastic language to the place, to change it, the people's mindset of how they viewed Clarke Quay. And it's been terribly successful. I'm sure a lot of you know it. And as I said, it was the first time foil had been used in Southeast Asia, so there are lots of hurdles we had to cross. But it's been very successful, and this is 20 years ago now, and it's just been regenerated. But quite a nice photogenic place, and very, very different to the sort of district as we found it when we first arrived there. So, I'd like to think it's because of the architecture that it was so successful, but it's not just that. It's a combination of the dynamism that our client brought to the project in terms of the way they leased the space. So they've got lots of shops that were new to Singapore, lots of new restaurants and bars that created the sort of wonderful atmosphere that was there. And of course, it's quite theatrical at nighttime as well, which makes a big difference. But when we started the project, and I think this is an important consideration, our client wanted to air condition it. The climate in Singapore is very similar to that in Ho Chi Minh City, where it's humid all the time. And our client's experience was Bugis Junction, Raffles City, these air-conditioned spaces where the temperature is consistent. We persuaded them that this wasn't such a good idea, that we should try and naturally ventilate the space as much as we could. So we ended up building these big umbrellas over the street that keep the sun out, keep the rain out, but allow the sort of ambient temperature to be reduced a little bit by putting a lot of shading into the foil covering. So it's a great place for people. It's transient space, quite dynamic space, lots of things happening, and a very nice sort of fountain at the center that uses the Alhambra effect to cool the space quite naturally by us blowing a sort of riverine breeze through the fans to reduce the ambient conditions. So it's a great fun project to do, actually. Not really architecture, not urban design. It's more like city furniture. So the next project, it's a little bit like Clarke Quay. It was never built, but it uses the same sort of principles. A building that our client bought over after the ringgit crashed in Malaysia, maybe 15 years ago, had been sitting in the city, sort of, I know it's like Indiana Jones and the Temple of Doom. It's a very horrible place inside, lots of rats running around. And again, they wanted to convert the space and transform it. So they asked us to give it a new identity. So what we did, we knocked a big hole in the center of the building to almost make a courtyard visible from the outside. So there's a sort of visual and physical engagement between the inside and the outside. The building on the left was clad with a green facade, and then the part on the right was clad with an electronic digital facade. And again, the sort of central space, a little bit like Clarke Quay, was covered with an ETFE foil roof. So it helped that space be naturally ventilated, naturally cooled. No air conditioning, so it reduced the overall aircon consumption of the building by over 25%. And it created this sort of new square for the city almost, a public space that had shops and restaurants facing into it. And sadly, it wasn't built, but it sort of formed an idea that's used in quite a lot of the projects that we've done since. A project that we've nearly finished in Guangzhou in China, again goes back to that idea, as I said, the sort of former lifeblood of the city being moved away. And this site was the site of a former sugar factory in Guangzhou. Of course, Guangzhou was one of the epicenters of sort of colonial China, where a lot of business was done on the Pearl River. And our site was no different to that. Fantastic site along the river that was bought over by Huawei. But there are a number of buildings on this site that we had to maintain from its sugar factory days. It's not very usual in, I suppose, to be able to build such large projects and be the singular architect designing the landscape, the buildings, the facades, etc. This project is, a combination of about 14 different buildings, including a hotel, and lots of R&D facilities for Huawei. And it's very nearly finished, so it's got about 6 months left to go. This photograph was taken a few months back. But a very rewarding process to be involved in, very lucky to be building in such a prestigious location. So we do a lot of projects like that. This is the Shanghai International Cruise Terminal in Shanghai on the river. And again, in the former Docklands area. And of course, the nature of docks has changed quite a lot. Digitization, containerization, etc., have moved the old activities of the port further out to land that's a lot cheaper. But what to do with this location? So it became the location of a cruise terminal, ferry port for international cruises into and out of Shanghai. And we were given the opportunity to design the buildings that face the waterfront with a new garden in front of them. So this was constructed in the run-up to the Shanghai Expo about 10 years ago. So again, we designed all the architecture and the landscaping, and it's about nearly 200,000 square meters in total. But at the center, there's this gateway that connects the old city of Shanghai on Daming Road with the new waterfront, with the new garden. That's the sort of celebratory threshold and arrival condition for the project. And it's terribly dynamic at nighttime. If you look at the lighting at Clarke Quay, it's sort of a similar sort of idea. You've got this wonderful threshold that embraces the condition of the city, very dynamic, very lively, like the lights and the buildings in Pudong across the river. A very interesting sort of cladding exercise, tessellated geometries of these sort of blob-shaped structures that were designed as restaurants, but were eventually inhabited by Ferrari, not selling cars, but selling Ferrari-branded goods, and suspended from this big arch structure because there's a tunnel below them under the river. So, again, very similar project in Guangzhou, harborfront project, the old international shipyard in Guangzhou, very important location started in the 1890s, a real center of industry for the city. But again, shipbuilding has moved away to other cheaper locations in Asia. So what to do with this wonderful location and the old buildings that sat there? But our client, sort of government quango of CITIC, was set up to reorganize and remaster plan this area, and we were given the project. And it's 1.4 million square meters, which we master planned, finished it about 2 years ago. And the client and the government are now selling it plot by plot to different developers. But interestingly, the sort of scale of the project, a little bit like Canary Wharf in London, if you know it. Huge site, but unlike Canary Wharf, it doesn't have monocultural activities. It has offices, of course it has offices, but it also has a lot of residential areas, cultural facilities, healthcare, schools for children, etc., etc. But importantly, the aspects facing the river have all the cultural facilities and almost stick their nose into the river and use or embrace, if you like, the aesthetic of shipbuilding technology, which I'm quite interested in. The sort of linear ribs and the expression of shipbuilding. So how do you bring that into the architecture? And here you can see one of the buildings that we designed. It's sort of ship-like and uses that old rib idea. And then other projects or other parts of the project retain the dry docks, etc., and transform into public areas. And this area here is where the metro actually comes out of the building. There are 2 new metro lines that service the project. And again, going back to Clarke Quay, a lot of ideas there we've used in subsequent projects. A big canopy, science and technology pavilion that sort of uses a lightweight structure, a foil-clad structure to cover that courtyard space. So fantastic project to be in, and hopefully we'll do some of the architecture at some point in the future. Very different scale of project. This is in Singapore, a project that we've just finished that's won a few awards. Very nice to win a few awards. But again, it's about regeneration of an existing building. Going back to what David Chipperfield was saying about not knocking down buildings, because you can never recover the carbon quantum if you knock down and rebuild. So, that was a consideration of our client, whether to demolish the building and rebuild as new. But the strategy was to, again, try and transform this existing building that didn't really fulfill the objectives of the location and the opportunity afforded by the location. So this is what we've done. Again, completely transformed the sort of language of the building, moved dead GFA that was in the center of the building to the outside to really greet the street, to create this sort of iconic image for the project, and transform it from where it was, you can see here, into something that sort of celebrates its location and really captures the energy of this arts district in Singapore in a very fun way. Because, I say fun, because it's targeted at the sort of youth generation. It's a shopping mall or a club for kids and an education hub for kids. So it has this interesting sort of almost nightclub type language. And of course, it's a great sort of canvas for those who are taking Instagram selfies or WeChat selfies. So again, very different type of project. We do a lot of research or come up with ideas and try and see how we can fit them into the sort of urban language of the places where we're living and working. And of course, it's a topic that's been discussed a lot. Plastic in the ocean, and plastic finding its way into everything from the sort of water that we drink to the food that we eat. So we've done our own experiments, which is quite simple, using plastics, PVF2 plastics, and then getting inspiration from the location. This is the beach hut, the casuarina trees on the beach in Singapore, the nice seeds that you get, and then using the plastic to create a new beach hut. So you're collecting plastic on the beach, recycling it, turning it into shingles almost, and then using those shingles as cladding materials for this beach hut. So the beach hut is elevated above the beach. People camp in Singapore on the beach on the weekends, so this is an opportunity to not have so many tents, but have this new thing that becomes a sort of iconic identity as part of the regeneration of the beaches in Singapore. So here it is. You can see the sort of plastic shingles being translated into cladding panels, reanimating the beach, and a little bit in the spirit of the old initial Apple computers. They come in lots and lots of different colors. But a fun idea and a fun way of explaining the problem with ocean plastics and the importance of Singapore as being an island and its reliance on the sea, and changing people's attitude towards not dumping so much plastic or not using too many unrecyclable plastics. And in the same spirit, we came up with this idea for low-cost housing in Mumbai. And of course, housing in the slum areas is pretty awful and shouldn't be like this these days. And I was reading, I think it was in the Guardian newspaper, about Tetra Paks, this very clever packaging solution, which is very important in places like India and Southeast Asia, where refrigeration is not so common in certain areas. And Tetra Paks are dumped, unfortunately. And millions of these things are dumped every year. So I came up with this idea about why can't we use and recycle Tetra Paks and use them as the cladding material and create this sort of system of housing that can be rebuilt locally. And of course, those of you who know India very well, it's got this wonderful sort of localized recycling systems where things are dismantled and then reassembled. So why can't we, and we've done our own tests about recycling Tetra Paks into sort of modular housing units. So these are built locally and then plonked into one of these towers. So you have a concrete shell, and then the pods are manufactured locally and then craned into place. And then on the roof, there's a foil roof that's clad with thin film photovoltaic cells to help drive some of the lighting maybe at nighttime. So the next project, I know I'm going through these very quickly, but Home Farm is perhaps the most regenerative idea that we've developed as an architect. And it's about aging population in Asia. And there are areas like Japan, Singapore, and other parts of the world where the aging population is almost becoming at crisis level. And in Singapore, well, you can see here, you don't need to read it. I read this article when I was flying somewhere about nappies for adults, or diapers for adults, were outselling diapers for children. It's a horrible idea. But it's the reality of the time that we live in. Very few people in Singapore having the right number of children to maintain the sort of right sort of adult to child cycle. And of course, Singapore's been incredibly successful as an economy that's regenerated and changed the nature of the city. Sort of post-imperialism. It's been very clever about re-urbanizing the city in a very positive green way. But it's meant that there's no food grown in Singapore. And Singapore has this policy of 30% by 2030 that they're going to create lots of new, surfaces for growing food because it's all imported, which provides a level of insecurity to the food system in Singapore. So I came up with this idea about an aging population, a place where you can treat older people seriously and sensitively, but at the same time produce food. So it's not a sort of work camp for old people, but it's a sort of facility that allows them to earn money by doing some part-time jobs, by planting, picking, packaging the food that's grown at home farm. So it's a housing development, it's private housing, with a mixture of unit types from dual keys, 3-generation families, assisted living, all those sorts of things, and the facilities you'd expect to go along with it. But importantly, it's a place where older people live in a community, where there are younger children and other families. So they're not pushed outside in the city, and they're not in elderly homes, in horrible care environments. You know, when I get older, a little bit older, it's a great sort of environment to live in. So again, an idea that's won lots of awards. It's not been built because I suppose it doesn't conform to the standards of housing that people expect these days, but it's an interesting idea. And certain aspects of this project have sort of taken hold with new developments that are happening in certain places in Southeast Asia. But it's also got this 360-degree life cycle idea, sort of cradle-to-cradle ideas where the systems that are grown become waste. The waste then goes into a biomass power station and provides power for the rest of the development or parts of the development. And then the water that's on the roof in the fish farming creates nutrient water that helps assist the growth of plants. So it's this 360-degree system. Very interesting. So other things that we do, a little bit more straightforward, that have, I suppose, a mixture of facade types. Raffles City in Beijing finished maybe 10, 12 years ago. Curtain wall, window wall systems. Again, quite complex geometries. And the systems of drawings that we use now in computers, of course, so mapping and form finding, the right sort of surfaces for these buildings, all built and manufactured in China. I suppose the story here, when we first started to work in China, maybe 19 years ago, most of the facade systems were then imported into China from people like Perma-Stalisa, but of course quickly copied by very clever Chinese companies. And I suppose the state of facade technology in China has changed an awful lot since then, and now it's terribly sophisticated, just like you'd find in Europe or elsewhere in the world. But I suppose the lesson that we learned at this time, that you can design a Rolex watch. It's very easy to produce these, well, maybe not so easy, but quite complex to produce these drawings. But it's easy to articulate the idea, 3D or in 2D, but then the construction is a lot more complex. And we found that the contractors at that time weren't able to sort of create a balance between the technology that was in our drawings and the ideas, and it wasn't particularly sophisticated in the way it was built, sadly. I mean, it looks okay in the photographs, but you look at the quality close up, it's not particularly good. but this is a long time ago. This is, again, using the same language of the sort of tessellated surfaces to clad the roof over the swimming pool of the service department, like the one next door. Ascot is the same brand. And then the curtain wall, window wall systems of the podium and the service departments. And then interesting cladding, silk screened and very beautifully lit at night time. And some things that we've done a little bit more robust, quite well known for this project in Penang. 2 residential towers, one, or actually half of one is a hotel, and one full residential tower, just on the outskirts of Georgetown in the island of Penang. It's become quite an iconic project for the island. Has these interesting sort of pods, which is the clubhouse and the jacuzzi for the residents. It has wonderful views over the straits, of course. It looks very complicated, the geometry, but it's not. Of course, the core stacks right the way through the building, and it's just the elliptical shapes of the floor plan. The sort of concrete slabs rotate slightly at every floor, giving it this very nice curvilinear, sort of organic form. Most recently, we're working on a project with Emaar in Dubai on the creek, a very important sort of one of the last parcels that Emaar has. And we've been commissioned to design. Seems to have disappeared. Maybe because it's secret at the moment, I don't know. Anyway, that's the plan form of the building. I won't dwell on it, but let's bring it back to home. We all know that the market in Vietnam is a little bit depressed at the moment, but we've been lucky enough to work on a few projects here, both of which are on hold at the moment until the market sort of recovers. This started off life as a project by Capital Land. It's now transferred to the landowner, but it's a mixed-use project in the city, right on the river, so it's got a wonderful site in District 2. There's office building, service department, and then residential towers. And the residential towers has this sort of chopped form. That's to embrace the best views of the river that creates and articulates the elevation of this project, and a detail of the podium and the towers. And then a project that we're looking at in District 1, which is an office building. Nice opportunity in the city, but the client said, "Oh, we don't know what to do. Can you give us 3 ideas?" Which is a bit annoying, I suppose, but we embrace the task and try and produce some interesting ideas. And this is one of the ideas, which has this quite interesting form that greets the city, and it has a sort of sister shape that sits on the roof as well. So hopefully, when the market comes back, we'll get to do this project. Doesn't seem to be working at the end, but I think I've sort of come to the end of the presentation. Hope you enjoyed it. I know it was a bit of a rush, but some interesting things to talk about if you'd like to discuss them later. Very exciting times, I think. I suppose a little bit confusing as well for us in the construction issues related to sustainability, low carbon buildings. What do we do? Do we build less? A lot more on regeneration, which I find sort of heartwarming in a way, to try and find new uses and new energies for old buildings, which I think goes back to that statement about that Jane Jacobs made almost 50 years ago. She was well ahead of her time, that woman. But nobody builds Jane Jacobs. Lots of people are trying to do it, but maybe that's the way forward. Thank you very much.
Thank you, Mr. Stephen, for the very exciting insights. And xin dành một tràng pháo tay thật lớn cho diễn giả tiếp theo. Please welcome on stage Mr. Joerg Allouni, Jotun.
Good morning, ladies and gentlemen. Very pleased to be here. So yeah, my name is Zouhir, and I'm here to take you through paint and coating contribution to green buildings. As you all know, buildings are made of different materials, steel, aluminium, concrete, and wood. So if I just focus for a bit on steel, did you know that Steel corrosion costs the world trillions of dollars, so that's a lot of zeros. And steel industry is one of the top 3 biggest contributors to CO2 emissions. It's around 9%. And 40% of the steel used is actually to replace corroded one. We could save 35% could be saved by good corrosion protection. So that translates to 1 billion CO2 emission. So this corrosion protection is done by, a very tiny paint film. So instead of taking you through many slides explaining that, I would rather let my colleague from Central R&D in Norway explain to you the importance of that tiny film.
This is a 0.3 millimeter coating. It can protect a ship from rusting away for decades. It can protect an offshore wind farm, for instance. I don't think that people really think about it, but this makes a really big difference, and it is a huge job behind it. All product development starts in the laboratory. Here in this laboratory, we are looking into new coatings and also some specialized products. I used to say that we are testing from pole to pole and everything in between, basically. You have to wait for the results for a longer time. But it's important that we are always verifying and supplementing with field testing so that we can make sure that we get out the most optimized solution for our customers. But maybe most importantly, the steel production industry is responsible for around 8% of the global CO2 emissions. And the cost of corrosion is massive. Around $3 trillion is basically rusting away every year. Everything that we can do by applying a paint that can reduce the necessity of steel replacement will have a big impact both on the cost for our customers and society, but also the environmental cost in terms of reduced CO2 emissions. For ships, it's a big difference between having a coating or no coating. It's protecting the whole hull, not only corrosion protection, but also fouling protection, so that we can ensure that we have less fuel consumption and an effective, sustainable transport of goods around the world. It also protects internally in ballast tanks that you don't necessarily see, but it's part of the huge structural strength of a ship. But also high-rise buildings need special protection because of their extreme size. It's very hard to do maintenance 800 meters above ground. They really have to endure a long lifetime in harsh conditions without any maintenance at all. As a chemist, of course, I also think about the impact that we have as a chemical supplier of paint. But if we can protect, for instance, an offshore wind farm for 35 years without any maintenance and ensure that that wind farm is actually developed, obviously that will have a huge positive impact on the environment. So we always have to balance it. And that's, of course, something that we work with a lot. But I really think that one of the keys to a sustainable future also is here in Jotun.
So I hope the video made it very clear that long-lasting protection have a very major positive impact on the environment. And I just used the example from steel. So same is relatively true for aluminium and concrete. So before we go further, please allow me to tell you a bit of who we are. So Jotun have been protecting properties throughout the world since 1926, and today we are more than 10,000 employees over 100 countries, and we have 7 R&D centers in the different regions to be close to the market. And we have a long experience in different segments and different industries, and we are protecting different assets. For you, buildings are the main thing. This is not really a computer-generated picture or Photoshop. This is actual picture of a tiny lighthouse in the west coast of Norway. and you see how harsh the environment is there. The waves can reach up to 60 meters height. So this small house is built of wood, so it would have collapsed in a very short time if it wasn't for the tiny paint, which is the white color you see there, and the red, that is protecting it. So just to give you a couple of examples of proven long-lasting protection, we have one product called Balter Flake. This one has been used now for over 30 years, but to be exact, 34 years in offshores in northern sea of Norway, which is again very harsh environment. And it has been protecting this, especially the pillars that are supporting the platform. And for 34 years, it didn't corrode and it didn't need to be repainted. Another example is our powder coating, super durable. You can see for the beautiful Burj Al Arab in Dubai. So after 25 years, it's still as beautiful as intended. Speaking of beauty, yes, long-lasting protection is important, but long-lasting beauty is even more important. And we have different beautiful colors, different finishes, different gloss levels, different textures, so that your building can stand out. And when it comes to sustainability, Jotun have set very clear targets and also very ambitious KPIs. And we have Jotun Green Steps, which is focused on reducing carbon footprint and reducing VOC emissions, sorry, and also energy consumption. And the most is that we are here, our sustainability initiative is here to support your sustainability ambitions. As if you know as well, as like architecture and infrastructure is responsible for 40% of total VOC emissions or CO2 emissions in the globe. That's why now the demand and regulations on green solutions for infrastructure are more and more in focus. And there are many green credentials that govern various standards around the world, but LEED still remain one of the most preferable here in Vietnam and worldwide. And here's one interesting point that I want to stress. You know, if you look at the overall cost of building, the cost of paint and coating is really a fraction of it. It's less than 2%. And yet, it can get you up to 17% of LEED points. You can gain up to 3 points in indoor environment quality category, 2 points in material and resources, and 2 points in sustainable sites. So in total, 7 points. And we have made the green building solutions to make it very easy for you to specify and gain these points. And we have the tools, the products, the documentation, everything to make it very easy for you to get up to those 7 points. So yeah, long-lasting protection and beauty, green building solutions, and also we have more than 380 products with the APD through third party. And to make it even easier, we have a single source solution, so we can protect each and every part of your building. So from protective coating to fire protection, to floor coating, and to powder coating. Since powder coating is part of my responsibility, so allow me to take you through a couple of slides on that. So our R&D is mainly focused on sustainability, durability, and appearance. And when it comes to appearance, we try to get as many finishes as beautiful as they can be, so for your building to stand out. Our 2 main brands is super durable with 25 years product performance warranty and all the certifications needed. And if you want to be a step up, so our Durasol, which is hyper durable, it can give you up to 30 years warranty and also all the certifications needed. And we have been chosen by the leading architects. I'm proud to say that 12 of the top 20 tallest buildings in the world are protected by Jotun, and 4 of the top 5 are protected by our powder coatings. And just to give you a couple of examples of LEED certified or green buildings, the list is very long, but to not take much of your time, so I just take you through a couple of examples. So this is the beautiful Louvre Museum in Dubai. The architect has the ambition or the vision to have this beautiful sunlight rain through the Louvre to come inside. But as you know, this is Dubai, so in the summer it can get more than 50 degrees. So the idea in the beginning seems a little bit, because inside it will be like a sauna. So it was a lot of engineering challenges to tackle this problem, and Jotun was among other stakeholders, and they used cool shades from super durable to reduce the temperature. This is another example. This is G Tower in Bangkok using our Durasol. And this is Meridian in Istanbul using our Durasol and also their decorative paint. And the World Trade Center in Jakarta using our single source solutions with Durasol. And I'm proud that we will be protecting the landmark 81, which will be the highest building in Vietnam, in Ho Chi Minh, and this beautiful diamond crown in Hai Phong in Vietnam. So to not take much of your time to summarize, so yes, my key point today is long-lasting protection have a major impact, positive impact on CO2 emissions, and since infrastructure and architecture contribute up to 40% of global emissions, so there is more and more focus on green buildings. So LEED remain the most preferable and the most adopted over the world. We have green building solutions to support you in this. For a fraction of the price of your building, you can achieve up to 7 points, which is 17%. And we can be one-stop shop for you, protecting each and every part of your building. Last but not least, we are here to empower your vision so that you build beautiful buildings that will last for generations. Wait, sorry. Just the last one. So thank you very much for your attention. Thank you.
Thank you, Joerg, for the useful presentation. And tiếp theo sẽ là diễn giả thứ ba của chúng ta ngày hôm nay. Please welcome on stage Mr. John Stanlake, Inhabit Group.
Okay, I'm John Stanlake from Inhabit Group. Chào các anh chị, tôi tên là John Stanlake của công ty Inhabit. That's the last Vietnamese I speak. So today was sustainable design. So if I did this presentation 10 or 15 years ago, I would have said I recycled the paper, I put the cans in the recycling, and that's about the limit of our knowledge. But the world has changed. The world's changing very, very quickly. So what I'm going to show you is a little bit about sustainable design. So what is sustainable design? How does it relate to facades? Compliance is an important issue, and how do you analyse it? And carbon engineering, which is becoming the biggest topic in the world. So I'm not going to stand and read through these, but to give you some idea, this sustainable design, these are some of the things that you can do. You now have bioclimatic tropical design, you have net zero, you have low energy buildings, all the way through to different analysis, building physics. There's a whole lot of science and engineering that now exists today. But do we use it? That's always a good question. So some parts about sustainable design, it is high science, but it also can be simple. Simple little details, like putting fins on building, can make a massive difference. So during the design phase, you can analyse, you can check, and you can make sure that a little difference will make a big result in the end. So when we talk sustainable design, it goes through all industries. So quite interestingly, you talk of industrial. Industrial is actually leading the way for sustainable design because they're factories, they're built for business, it's all about money. So for them, if they can get a return on their sustainable investment, they will do it. So whether it be a mixed building, whether it be all the sectors we work in, the sustainable design is common throughout. So here we have a whole lot of different versions of, the speaker before was mentioning LEED. We have LEED, we have in Vietnam Lotus, we have a whole lot of green mark, a whole lot of performance specifications. But the thing I would add to these are, I don't think these are totally sustainable design. These are just nice marketing gimmicks. They're not the whole be-all and end-all of a design, but they're important to get your building certified. Okay, so let's talk a little bit about some of the engineering. So building physics. Building physics is how do you analyse it? In the old days, a facade was analysed for wind, maybe a bit of air, sun, etc. But you can go a lot further than that now. You can do condensation analysis, you can do mould analysis. Thermal bridging is important. Thermal bridging started in Europe because it's cold, but actually the same thing applies in most of Asia. So in Europe, cold outside, warm inside. It's exactly the same thing in Ho Chi Minh. It's cooler inside, it's hotter outside. So you're trying to keep your air conditioning in and not let the weather come. So there's a whole lot of engineering tools that are now available to us to design these things. And the great things about these, they don't cost a lot. A lot of people say, waste of money, don't bother. And when something goes wrong, the first thing they do is come back here and then they realise the design was wrong. So it's also important to analyse the environment. So a building in Ho Chi Minh will be different to a building in Hanoi. A building on the river will be different to one in District 10. So it just varies. You've got to analyse the actual environment of where the building is. You need to understand where the sun comes from. You need to understand what the sun does. We are relatively lazy in this industry. We design a curtain wall for the worst case of wind load, worst case of sun, and that's it. But actually, two sides of your building won't have so high wind load. Two sides of your building won't have so much sun. So we need to get beyond the point of lazy is harsh, but we need to look beyond that and say, okay, the sun on this side, we need thicker glass. The sun's not going to hit that side as much, we need thinner glass. But then all our friends, the architects, will say it must look the same. But we need to start designing and optimising. So high performance envelopes. Does it cost a lot of money? Maybe 3 or 4% more, but it is extremely important. And the key thing in all of this is the second line, feasibility study, cost-benefit analysis. It's no good producing the world's greenest building if no one's going to rent it out. Okay? At the end of the day, we all work for money. So it's no good designing, engineering, or building something that's not going to have a use. So the most important thing when you talk green is cost-benefit analysis. Is there a benefit to what I'm doing? Good. If there's no benefit, don't bother doing it. So that's probably the key takeaway from this one. Okay, so, and when I talk, the topic was about facades beyond just glass and aluminium. There's a lot more to be done these days. So high-rise buildings, we need to start looking at a proper design. Like I said, not just lazy design, 4 sides all the same. We need to start doing proper analysis of sun, glare, light, natural light. If you think about it, if you design your facade properly, natural light comes in, you don't need lighting. You don't need lighting, no electricity, or less electricity. Less electricity over 20 to 50 years of a building lifespan is a lot of money. So again, we have the tools, we need to start using the tools. But clients also need to start paying to use these tools and understand that if you design your building to the nth degree, they will get some cost benefit out of it. So that's the important thing. Okay. So carbon engineering. Now this is one of the big topics in the world today. A lot of multinational companies now, the directors, their KPIs are always obviously profit, growth, looking after staff. A lot of the big multinationals now, carbon footprint is one of their KPIs. So Stephen, the speaker earlier, mentioned about recycling and reusing buildings. This is what we need to start doing. Unfortunately, in Asia, we tend to drop buildings and then build a new one rather than recycle buildings. So carbon engineering is interesting. In Singapore, we now have one client that paid to use recycled aluminium to reduce their footprint. So it will take time. He initially said, or they initially said they want 70% recycled material. They saw the cost and they said, no, I don't want 70%, I want 30%. But the point is, the world is starting now to understand about recycling material and understand about carbon. And there's two parts to carbon, embodied carbon and operational carbon. So don't just think you build a building, done and finished. You need to start talking about operational carbon. How much carbon will your building use over the next 20 to 50 years? Okay, so it's always, since we're little children, reduce, recycle, reuse. That's all over the world. But there's a lot more to it in our industry. Building and facade ratios are very important. Dimensional efficiency. So we saw nice architecture. I'm now going to tell you the opposite of that. You need to start building smartly. Okay. So I don't expect people to read this, but what it says is you've got architect, consultants, your designers, facade engineers and manufacturers. The reality is each one of those people have something to do about a building design, okay? So it's not just poor old architect, it's not the facade consultant, it's not just the builder. Everyone in our industry from A to Z needs to contribute to this. This is always a nice slide. So most people will recognise all the buildings on top. Unfortunately, if you want to build an efficient building, it's got to be relatively square and boring. So everyone has, Heatherwick was mentioned before as one of the architects. These rock star architects will come up with designs that are overly complicated, which is fine. I mean, we all love a nice building. But at the end of the day, they're not efficient. At the end of the day, I was in KL yesterday. KL 118 has 30 stories of basically nothing on top of it. That's not smart, efficient design. It looks good, but if you really want to send a message to the world that you are green, it doesn't work. So you'll see the iconic buildings in the world are very inefficient. Then you get down to, sorry for the architects, the boring square buildings, they're very efficient in their design. Likewise with height, there's a point where just building higher and higher is becoming inefficient because the wind loads get higher and higher. The cores obviously take up more and more area as you go higher. So efficiency is extremely important. Cladding is another one. So facades and cladding. So 20 years ago, floor-to-floor heights started to increase, raised floor. My office is 4.2 meters. This is increasing. But actually the world is now going back the other way, and now the floor-to-floor heights in some of the buildings in Australia, for instance, are going down to 3.7, 3.8 metres. That is an extremely cost-effective green solution. You think if you add 200 millimetres to a floor, times 50 stories, that's a lot of extra concrete, a lot of extra facade, a lot of extra lift, etc., etc. So starting to reduce things is very important. Okay. There's a lot of other things that come with it as well. Exposed ceilings. Actually, they look great for food places, but exposed ceilings, why do we put a ceiling in when no one really looks up like that? So the reality is start to reduce what you need in your building, okay? So some of the other things which I mentioned previously, as an industry, we're lazy. We design it for the highest wind load and the worst of this and the worst of that. But actually your building has at least 4 sides to it, hopefully. So you start to look at shadows. So if there's a building adjoining you, can you reduce the glass on that side? Again, cost saving, it's a greener building. So we need to be smarter now how we design things. Fins is a classic. Aluminium fins on a building, everyone loves them. But actually beyond 400 millimetres, they're ineffective. They're only architectural. So one of the jobs we're doing in Singapore, the fins are 2 metres long. It's such a waste of money. Aluminium is carbon. So again, the company, I won't mention the name, but the company tells everyone in the world, we're a green company, and they build 2-metre fins. I don't know why. So design is another one in our industry. So many times we check drawings and they're inefficient. So if you're a contractor, Wouldn't you design it to the absolute limit of what you could? The facade on the top left hand, 10 kilograms a square metre. That's the basic facade. But you get some complicated ones that are 20 or 30 kilograms a square metre. That's a lot of money over the size of a building. So we need to become more efficient and reduce. Okay, so green energy and recycling. As I mentioned before, one of the clients said, I'll pay for 70%, ended up being 30% of recycling. That's very important. So we need to start recycling our material. Well, recycle the building would be the first idea. Recycling materials is the next idea. So we need to start doing that now. Now, cost-effective designs. Again, this is a wing wall that sticks out the side of a building. Looks nice, but it's a lot of extra money. It's not green for the world. So it's important to analyse everything down to the absolute limit. There was a job in Melbourne when I was a young engineer. I'm now very old. Melbourne University actually they got all their engineering students to design a building. So it was designed commercially, and then all the students spent hours and hours doing a reanalysis of the building. And it was frightening how much concrete they reduced, how much aluminium they reduced just by designing things to the limit. Okay, sunshades, as I mentioned, is a classic. So here's a contradiction in going green. You should put sunshades on a building to reduce the heat loading on a building. But if you put sunshades on a building, what are they made of? Aluminium. Aluminium's high carbon content. So it's about designing it efficiently. As I mentioned before, a job with 2 metre sunshades is such a waste of money, but it's what the view is. Okay, so thermally efficient design. A lot of this technology originally came out of Europe. As I said before, cold outside, warm inside. It's exactly what we have in Asia, except the opposite. It's obviously hot outside, and we want to keep the air conditioning inside. So thermally broken facades. I have been working now for 30 years, and do you know how many thermally broken facades I've done in my life? 1. So only 1 thermally broken facade have I done in 30 years of working in facades. So it just goes to show you that the industry is not that interested in saving money. Clients aren't interested in paying a little bit more initially to save their operational costs. But the technology is there, we just don't want to use it. The other important thing is to design your facade efficiently. So 1.2, 1.5 metres for the mullions. A lot of people like 2 metres, but it's, again, inefficient. Now, restrict the glass build-up. So what do we build? Glass boxes. And I love glass boxes. I think they look fantastic. But actually, the reality is glass boxes will eventually will not be able to be built in a lot of places. The U values that the governments are setting, so for Singapore now, it's gone from 50 down to 38 watts per square metre. It's going to become impossible in probably another 10 or 20 years to build a big glass box. You're going to have to change your window wall ratios. Again, reduce materials in spandrel zones. In Indonesia's a classic. They don't actually use spandrels in a lot of, they use spandrels, but they don't actually put any backing material in. So reduce the number of layers. What we do in this industry, maybe because we're not overly smart, is main contractor builds concrete, facade comes in, builds facade, interior guy comes in and does the ceilings, the pelmet boxes, etc. Well, why don't we start getting the curtain wall guy to produce the pelmet boxes so it's one trade instead of 2 trades doing the same thing? Okay, now, carbon embodiment. This is a classic thing. Although aluminium has high carbon content, it's not actually the major driver in a building. It's actually more related to concrete because obviously there's masses of concrete, there's less aluminium. But we need to start looking, when we choose a material, be it glass, be it aluminium, we need to start looking at how much carbon is actually in that element that we choose. And where I come from in Singapore, they've decided to build modular construction for various reasons. But actually, if you remember, Singapore government says going green, and we're doing modular construction. That's a contradiction because modular constructions mean we use concrete off-site, we drive it in a truck over a border, and we install it on site. So we're going green, but we're using more carbon to go green. So the whole journey is a contradiction in itself, which comes back to why I always say you need to do a full cost-benefit analysis of whatever you're doing. Okay, I won't go through carbon in masonry because typically in Vietnam we don't use masonry so much. So, sorry, I'll go through that. So again, this is the life cycle analysis. Don't just assume your facade's cheaper, I save money. You've got to look at the whole life cycle of the process. So it comes from product, all the way to usage, all the way to end of use. Then when the building's demolished or renovated, you need to look at the whole building cost, whole carbon analysis of that cycle. Okay. Some of the other little specific topics relating to facades, shadow boxes. I don't know whether people realise when those glass boxes, but inside the shadow box, it gets to 80 to 100 degrees. So outside's 30, 32. Inside, that's 100 degrees. So you're actually creating something that's 100 degrees inside your building that will eventually thermally transfer inside to where you've got your air conditioning running. So shadow boxes is another thing that they look great, but ultimately you're paying money for them. Okay? I mentioned before duplication. We need to start making our curtain walls. They can be part of the internal lining. They can be part of the internal process. So radiant heat is another thing. It's beyond me why people still build dark buildings. So you look around and people are still building dark. We all know you wear dark clothes, you get hot. You wear white clothes, you don't get hot. Yeah, we're building buildings that are black. It's just beyond belief. So now, people say they go green, so let's put some solar panels on my building. Yes and no. It's also got to be effective. If you live close to the equator, which we're not far off the equator, they're not so efficient because the sun goes over the top of the building. So if you're in the southern hemisphere or the northern hemisphere, the sun goes on the other side of your building, then you get effective use. So a lot of companies will put in solar panels, but they're not overly effective. Okay, packing materials. Material comes to site, what do? Throw it away? We should be recycling. One of my ex-companies, Permasteel, we used to ship 10 containers out and 2 containers would go back with all the pallets. So you can recycle, but we didn't do it for a green reason. We did it because it was actually cheaper. But we need to start recycling a lot of packing materials. Just a couple of case studies to go through. Unilever, this is all about natural light. That's actually a real photo. It's actually natural light coming in the building. There's very little lighting inside that building. So you can design efficiently. Timber's becoming extremely popular, so timber is can be a recyclable material. This is a university where the sunshades are designed in Melbourne, where during summer it's hot, the sun is in a certain path, so it stops the sun coming in, but in winter it's the opposite. It gets as much daylight in as possible. Okay, this is where my mother goes shopping, actually, as it turns out. So this is a double facade. It's a shopping centre, so it has 2 facades on it, one architectural and one for practical reasons. Timber design, as I said now, the University of Chicago builds zero energy buildings all over the world. That's their process. A lot of analysis now goes into these things, such as parks. It's hot, but you should do proper analysis. Stephen mentioned in the first one about wind getting inside of a building. It's important to understand where the wind will come in and keep it cool. This is one just for fun. We actually were paid to do environmental analysis of a penthouse in China. So the reason, although for fun I can say it was so the champagne glasses don't fall over, but it was designed so that the penthouses were in the most efficient place they could be. Okay, and as I said before, industrial buildings, they're leading the way. Okay, airports are another one where they're leading the world in terms of thermal design efficiency. Canopies, so again, we have the tools to design canopies. This was an analysis to make sure things drain. As the worlds get more and more rainfall, we need to understand, is our building working? So this was just an analysis to prove that a very flat canopy would drain. Okay, so I think I'm running out of time. This is the last sort of one I want to show. This is from James Bond. If you remember, James Bond had a heliostat. So this is one where smart people, the building cast a shadow on a playground, so the council would not give them the building height they wanted. So in Sydney, they said, how about I build a heliostat on top of my building? So in winter, the heliostat sends the sunlight down into the park. They got 3 extra floors out of it. So smart design saved money. Okay, and then again, as I said before, it's all about designing your building efficiently. So thank you.
Thank you, Mr. John, for the informative presentation and regarding facade material selection. Really appreciate. And chúng ta sẽ có thêm một diễn giả nữa trước khi bước vào phần networking break đầu tiên. Let me introduce to everyone Mr. Matthew Penrose from Vector Foil Tech.
Good morning, everyone. Just wait for the presentation to come up. Okay, let's jump straight in. What is ETFE? ETFE is an acronym, ethylene tetrafluoroethylene. The important thing to note, it's not a plastic. It's not from the petrochemical industry. It's a fluoropolymer, one of the good guys. So it means its main ingredients is from minerals. So fluoropolymers don't have problems with UV, fire, sustainability, or longevity. And I hope you might recognize that. That's a 12-meter wide ETFE canopy at the Jewel at Changi. Where did ETFE come from? It was developed 80 years ago by DuPont. And it was our founders, just over 40 years ago, that brought the ETFE into the building world and used for roofs, facades, canopies, and building envelopes. So the principle is very straightforward. 2 layers of ETFE, welded at the perimeter, filled with normal air, and it's that air that gives the high thermal performance, high light transmission, the shape, the strength, but also extremely lightweight. So if you look at the underside of an ETFE system, it looks like giant panes of glass. And the only way you normally know it's ETFE is a small inflation pipe in the corner. And again, from the top side, very similar to a curtain wall system. And the ETFE is fixed at the perimeter into an aluminium frame, which is then secured to the building using steel cleats. Now, is it strong? So this is a video from 23 years ago. It's called Tomorrow's World, that some of you might know, and a young Kevin McLeod on the left. And it was showing how when you put load on an ETFE cushion, it distributes. We call it load sharing. Now, you can't do this with glass. If you put a point load, it's going to crack, it's going to break. But with a cushion, the load gets distributed throughout the cushion itself. So what's some of our most famous projects? The Beijing Water Cube, currently the world's largest project, 100,000 square meters. And the ETFE cushions are about 7 meters in diameter on average. And most people don't know it's actually double-lined. So you have the ETFE facade and roof, basically for the look, but of course, Beijing at that time was highly polluting, and ETFE doesn't care about environmental pollutants, acids, it's inert to it. And the same again on the interior, you have a very corrosive environment from the chlorine from the pools. So again, the interior finish is in ETFE. And probably the most famous project from the UK is the Eden project, 23 years old now. 2 biodomes, one is tropical, one is Mediterranean. And because of the low wind load in the UK, and this was an old quarry pit, we can have very large ETFE cushions. Now, when you have a lightweight facade that's flexible, you have even lighter steelwork. So what ETFE is famous for is giving you architectural lightweight steel. And at the moment, when steel has never been more expensive, it's really beneficial. Now, Hudson Yards is the largest project or largest private project in US history, and they have pretty standard towers, so the developer needed something to draw the people, and that included the vessel by Heatherwick, and then you have the shed. Now, the trick of the shed is it's telescopic. It doubles the event space, and you can only do this with ETFE because it's lightweight and it's flexible. But of course, it's about the developer making a show, getting people talking about what his building can do. We don't just work with engineers and architects, we work with people like Disney Imagineering. So this is the Tron ride in Shanghai. That's a 6,000 square meter organic shape. So the alternative would be thousands of pieces of glass and a very, very heavy structure. And what the ETFE's done here is it's not just watertight, it's not just giving thermal protection in the day, but it's also giving a day and nighttime identity. Simple lighting that becomes a beacon of light. And so picture in the day, you've got the silver prints, it's reflecting the heat, keeping you cool in that Shanghai summer. And during the night, simple light, simple LEDs, and suddenly that structure comes alive. Now, just taking this one step further, the most extreme environments in the world at the moment, I think, are in the Middle East. And Kuwait suffers from extreme sandstorms. So we've been fortunate enough to work on 4 phases of the avenues. And the idea is basically cities from the world inside an ETFE building envelope. And the ETFE can help control that temperature inside, still gives you natural light, still keeps, and it critically is unaffected by the sandstorms. And when the sandstorms passes, the sand doesn't sit on the ETFE, it just blows away. So let's talk about projects. We've only done one project here in Vietnam, quite nearby, with Atkins, Hong Kong. It was a pool, so of course we're looking to do a lot more of these projects here in Vietnam. Let's talk about sector. So let's start with facades. A lot of people know ETFE for roofing. This is a project just across the road from what Stephen presented earlier, the grid. It's a 15-story luxury car vending machine full of Bentleys and Porsches, and you push a button and the car comes to you, and the whole thing's cladded in continuous ETFE cushions, 15 stories high. Of course, we do a lot of these beautiful works, like in Bevis Marks, gardens on top of buildings, trying to make quite utilitarian buildings more interesting, like exhibition centers. So again, that daytime and nighttime identity, using the lighting, or maybe just giving an interesting point in a building facade and letting it fill with light, as we've done here in Birmingham. Or maybe you do the whole building. So this is an innovation center, quite a famous building, again, wrapped in ETFE cushions. Now, bridging that, turning from roof to facade, is we've got Seoul City Hall, and these 3 large balloons at the top. It's probably about 6,000 individually made cushions, and inside is a cafeteria, a library, and offices. And it really is a landmark, day and night. So this is looking up through the green gardens to the underside of the ETFE. And on the sides of the building, you can see the ETFE is protruding out, and there's a sort of viewing gallery with it. Now, what happens in high wind loads? We have this lightweight material. So this is a project we just finished in Manila Bay called Parcal. And what you're seeing here is a big part of our job. We design, supply, and install, and often do the steel work now. So again, did the review of all of the wind study models, made sure, because the great thing with, of course, digital printing with plastic, you can change the shape of what you're developing quite simply. And one thing we hate trusses. We hate long span with ugly steel. What we're famous for is lightweight architectural steel, and this is in 300 kilometer per hour typhoon zone on Manila Bay. And again, just through the night, this was recently opened, and you're going to hear more of this from our colleagues from ADAS later, or partners. Simple ETFE LEDs running along the side of the steel, transforming that building. And this is a video by our owner. They had very high storms recently, and our client was very happy not to see even though the ETFE is lightweight, it doesn't bounce around even in typhoon wind loads. We don't just do big buildings, we do small buildings. Must be 10, well, probably 15 years old now, Pacific Place in Hong Kong with Heatherwick. This is called the ink splat, and it's used contoured steel to develop the overall shape. And the cushion is one giant cushion of ETFE. You can see that we had to do the testing in our factory, wrap it all up and send it off to Hong Kong to be installed. Airports. We're doing a lot of airports. The Jewel at Changi, I think most people would know, connecting all three terminals, sort of nature-themed shopping mall right in the heart. And at the heart of it is the Vortex. It's the world's largest indoor waterfall. And right at the heart is this giant ETFE cushion. But also the whole drop-off area is all in ETFE as well. And Sabana Jurong campus, something new, just opened to the public recently. And we were tasked of making skylights sustainable, interesting, and something to inspire to. So this is the first cable-supported ETFE structure in Asia. And what you actually have is, there's no steel here. You've got 20-millimeter cables, which are opposing each other, and then the ETFE is bolted on top. So again, stadiums, very big industry for us. This was one of the first fully enclosed stadiums that had natural grass, because a lot of areas grass will not grow under glazing. ETFE is not a problem. And of course, Singapore Sports Hub, the National Stadium, has a 20,000 square meter moving ETFE roof. It's also Singapore's largest flag, which is one of the key criteria, and the largest dome structure in the world at 310 meters. We also retrofit a lot of buildings. Because the ETFE is lightweight, we're able to often take an old building, and in this case we've added 2,500 square meter facade, and it's changed from concave, obviously shaped, to convex. The building stayed fully open, installed during events, and then this is the largest stadium in Holland, and it basically ended up with a new covered area with a viewing platform of the city. Theme parks, probably the biggest is Resorts World, where Universal Studios is. 25,000 square meters of ETFE in every shape and form you can think of, and it's really there to keep you cool, and it's there to let you move around the development 24/7. And the Universal Studios, we actually reversed the ETFE to become a ceiling, and that's to allow all of the focus to be on the theme facades, and the ETFE just becomes essentially a sky. And Paradise City, just wanted to show this because often we don't show projects in snow, but this was an up close of the cushions coming into the aluminium system. And these wires are anti-bird wires because ETFE is literally non-porous, so birds don't like to stand on it. It just stops any animals on your building. And because the ETFE is lightweight, about 2 kilograms per square meter, with the same thermal performance as double glazing, we don't use scaffolding or craneage. We use safety nets. And those are prefabricated cushions from Germany, and they're just unrolled on the nets and installed into the aluminium frames. Again, just some videos of the final solution. Those cushions are about 15 meters by about 5 meters. Education, this is the world's largest preschool in Singapore. All of the breakout areas are covered in ETFE, and it was done so the parents of the children didn't have to worry if their children were getting UVA or UVB when they were playing outside. Transportation buildings, if you talked about sustainability, this was the first LEED Platinum transportation building covered in ETFE, which helped make the lightest steel structure possible and create a very comfortable environment inside. And again, you have that daytime identity, you have that ETFE keeping the sun away, and at night becoming a beacon of light. This is Stephen's project he was mentioning earlier, and we're very grateful to people like Stephen really pushing the envelope. This is 20 years old now. And all of that ETFE is inflated by that small box. It's only on 20% of the time, uses the same power as one of those light bulbs, 250 watts. And it's a typical German product. Put it on the building, forget about it, it's fault tolerant. ETFE itself is transparent. We put prints on the ETFE to control the thermal performance. And then you can put different densities and different patterns of prints to get the exact solar heat gain coefficient, light transmission, G value that you need. You can add layers to the ETFE. So the top layer is about 2 kilograms per square meter. That's without print, and it's already a sort of double glazing layer. You add another chamber, another layer of ETFE, suddenly you've got triple glazing, you're only at 3 kilograms per square meter. You can add patterns, you can have colors. And longevity, this is our first project here, or first major project, it's now 40 years old. It hasn't changed mechanically or chemically, so the ETFE should last easily 100 years. It's self-cleaning, so under the action of rain, it will clean. It's essentially Teflon on the actual surface. And in a fire, you can look it up. 0 problems, 40 years. What happens to ETFE in a fire? It moves away from the heat source, doesn't drip, doesn't smoke, and opens up a smoke vent. We have all of the testing you could imagine. We also have all the ASTMs, UBCs. We have projects from all over the world. And we are the most sustainable, transparent material in the industry. Full stop. So whether it's the lowest carbon footprint, sustainable, recyclable, it starts with ETFE, and we have all of the certificates, whatever you need to do that. And I want to finish on the shed, the case study. So the shed, as we've discussed, is at Hudson Yards. It's a 16,000 square meter visual arts and performance center. The wraparound show is exposed steel diagrid frame weighing about 3,000 tons, and it's covered with 4,000 square meters of ETFE. The shell can open and close within 5 minutes, and it's used for large-scale performances. They can have every type of combination you imagine. If I just move on, the shell retracts on 8 bogie wheels. They've essentially got a couple of Prius engines in each. As I said, you have 4,000 square meters of 3-layer cushions. They're about 21 meters tall, each of those cushions. Not installed with scaffolding. We're able to use either our safety net system or, in this case, boom lifts, because it's so lightweight. And we're even able to curve from facade to roof in a single cushion. And the results are absolutely amazing. Please come and visit us. We're just outside, and our local partners, Farinda, are here, be able to speak to you about everything you need. Thank you very much.
Thank you very much, Mr. Matthew, for your presentation. Could see many impressive projects you are working on using ETFE materials. And now we will head to a 20 minutes break. Chúng ta sẽ có một phiên nghỉ giữa giờ kéo dài khoảng 20 phút. Thì trong thời gian này quý vị có thể ra khu vực bên ngoài, khu vực tea break và giao lưu cũng như là đến thăm gian hàng của các nhà tài trợ. Sẽ có cơ hội để trò chuyện với những khách mời khác của chúng ta trong ngày hôm nay. Welcome back, ladies and gentlemen. I hope you have had a nice break and had fulfilled your system with a good caffeine. We will head to the session 2 today. And let me introduce our speakers, Mr. Timothy Soebroto from Meninghat Facade Technology. Please give a round of applause to him.
Hi, good morning, everyone. Xin chào. So, before I start the presentation, allow me to take this opportunity to thank the organizer, Zak World of Façades, for having me to be here, especially for Ahmed, Rada, and the team for inviting me. And allow me to introduce myself. My name is Timothy, and I'm from Meninghat Façades, which I have been for the last 18 years. And this morning, we would like to highlight a bit on the high-rise facade, especially the balancing aesthetic, structural integrity, and the functionality. So Meninghat Façade is part of Meninghat Group, and this is some of our portfolio, mainly in the high-rise building and our global footprint, which is shown in the red. And here is our project, Meninghat Façade, and mainly in high-rise building, but we also do numbers of low-rise, something like museum, concert hall, shopping mall, casino, and so on. In Vietnam, we have been actively do the project since 20 years probably, and this is some of our project. Some is have been completed, some is ongoing, not only in Ho Chi Minh, but also in Hanoi, Da Nang, and other part of the city. So, because today we want to highlight about the high-rise, I would like to show you a bit about this skyline in Dubai, and this is in Hong Kong, which is I really enjoy very much. In Singapore, where I have been staying for the last 18 years. And the last is in here. One of the same characteristic here is that the city is full of high-rise. And so high-rise buildings are closely related to the growth of the city, especially in Asia or in Asia Pacific and Middle East. But this one is not happen in Europe. So high-rise has become a very important for the city and play important role in the spatial structure, composition, and image of the city as they are spatial dominant and landmarks. Another thing, what is tall building? According to CTBU, they just finished their conference in Singapore. Tall building is building more than 50 meters, while super high rise is 300 meters and mega tall building is more than 600 meters. So this morning we are going to talk more on this issue. First is facade role in the building, and second is design evolution from the tradition to the innovation. The third and the last is design consideration from the architectural elegance, structural integrity, and user comfort. We start first with the introduction, what facade role in the building. First, I didn't accidentally put this one. We are talking about the human anatomy. In the human anatomy, there are 9 systems, from integumentary system, musculoskeletal system, respiratory, circulatory system, and so on, which is very difficult to pronounce. And for me personally, human anatomy is similar to the building, especially the high-rise. One of the similarity is this one, muscular system, which is more or less same as the building structural system. Provide support to our body, while the building structural provide support to the building. How about this one, circulatory system or cardiovascular system? This one similar to the water supply, wastewater, sewage system, more or less plumbing. So this is a bit comparison between body system, building. One is what happened in the body, what happened in the building. The question, how about the facade? We are going to answer it at the end of the presentation. So, facade is come from Latin word is fascia, and the definition is front of the building. But when we are talking to the architect about the front of the building, normally they told us that all elevation is front of the building. So facade can be defined as any phase of a building given spatial architectural treatment. For instance, is the building. All phases are treated nicely by architect. So facade are the first aesthetic feature of the building that distinguish one building from another, and the most important characteristic that quantify and qualify the performance of the building. This one according to Dr. Leon Jacob. So the second item that we are going to explore is facade evolution from tradition to innovation. We can see clearly in this picture, a very beautiful picture from Yuyuan Garden in Shanghai, that you can see Shanghai Tower from the angle, and we can see 2 different buildings that from tradition to innovation. This is one of the first high-rise building in New York, home insurance building. In here, the facade is combination between structural and architectural. You can see that the column, beam, everything is exposed nicely as part of the facade. But move on to the early 20th century, facade become purely aesthetical issue. In here, you don't see anymore about the building structure. Normally, they will hide the building structure behind the facade. So in here, mainly is the facade, which consists of aluminum panel and glass. Again, another example of the building is this building, UN House, which is one of the most famous building in the world, because this one is a headquarters of United Nations. In here, these 2 examples, or the building shape are rectangular. So this is one of the modern architecture. This is one of the picture that can easily be found in many cities in Ho Chi Minh or in any part of Vietnam. And most of the building is shop houses, consists of 3-story, 4-story, one in the center is 7-story. But the height of the building have been evolved slowly. In the modern city, in part of Ho Chi Minh, we can find not only this kind of building, but high-rise building. And in Ho Chi Minh, you have the 2 very tall buildings, which is Bitexco Financial Tower and Landmark 81 Tower, which is one of the tallest building in Southeast Asia. In here, we can see the height is evolved from less than 10 meters, 10 story, up to more than 50 story. And another thing, the shape. We see that earlier image that I show you is rectangular, but in here, the building is no more rectangular. Normally, rectangular shaped building have a 4 elevation, but here the elevation is more than 4, could be 8, 10, or so on. In here, and the result, the facade is getting more and more difficult, getting more and more complex. The shape also evolved. This project was designed by others, and we're working together with our office in Dubai. And here, in Dubai, they like to have a twist facade. In here, the facade is not flat anymore. The glass has to be forced to follow the facade shape. But at the end, the glass stress becomes very high. That's the reason why the glass have to be carefully engineered, carefully considered to accommodate the building shape. Another example of complex geometry facade, one building in Japan. The glass is no longer rectangular, but the glass is triangular. The material also evolved, and when the earlier slides show that the most of the building is covered by the glass, is get board. But now, a lot in the modern technology, a lot of material can be explored. In here, show terracotta baguette, which can be used for the facade as well, and commonly now used for the facade. Another good example is this one. We just completed this project in Singapore, Eden Residence. The facade consists of GFRC, precast, in addition of glass, aluminum windows, which was supplied by Shuko. On the other side is the facade is consists of RFP, fiber reinforced polymer, which is you can find easily on the bands of bus or metro, and this one is used in the facade as well. You might find this one a lot in Vietnam because this one is traditionally common in the concept of Asian culture, woven rattan. And last time, this one commonly used for the part of furniture. Yesterday, I went to have a dinner, and they use this one to cover the food, which is very commonly can be found in Vietnam. But this material also was used in interior as well, as a ceiling, as a wall, and just recently it's used probably 10 years back. And this one is increasingly used, getting more and more popular. And probably for the last 5 years, this material it's used for facade as well. In this, we have one project in this one, and actually with the supplier, we were working for one project in Dubai, in Red Sea, for the woven rattan. So from the architectural point of view, there are a lot of material that can be explored. Not only glass and aluminum, but also a lot of material that can be explored for the facade. Solar cell. John Stanlake did mention about solar cell a bit. Actually, solar cells become very important because the development of affordable, acceptable, and clean solar energy technology will be having huge longer-term benefit. The question is how we implement this one to the building or to the facade. One very good example is this building in Korea, where they implement solar cell on the facade, which is on the spandrel. And the good thing for this one, they design it so the solar cell can be replaceable when the new technology become available in the market. In here, the solar cell, when we design the solar cell, it have to be designed carefully. We cannot put wherever you want to do. This one, it was designed and they put it on the southwest elevation and southeast elevation to get optimum solar cell. And actually the spandrel was angling 30% to optimize the solar radiation to the solar cell, to the BIPV, while the fission panel was angled 15 degrees and this can actually minimize the direct solar light to the building. Another example is this building in Jakarta, when the client have initiative to have solar cell. We fully agree that having a solar cell in tropical country on the facade is not really efficient, but we have to give a credit to the client because the client really want to have innovative design on the building. They have to pay much more to the building, to the construction cost, while the benefit is not much as what they pay. So again, this one exploration in Jakarta project. And normally we were thinking that solar cell or BIPV is this kind, which is have impact negatively on the aesthetic of the building. But recently, what we can do is on top and the below. Solar cell on top is the BIPV panel, which have the color as close as the fission panel. So from the distance, you cannot see where is a BIPV panel and where is a fission glass. And the BIPV also get innovation, something like this, is you don't see ugly dot anymore, but you can see what different kind of color and we can use in the building as a part of aesthetical element. This one of the building in Netherlands, Shell building, and the solar cell was used in the building on top of that one. There are eight panel, part of signage, and this one actually solar cell can contribute 20.2 kilowatt power. Not much, but it's good enough. In Asia, in Southeast Asia, there is just finished one building in University Kuala Lumpur, Sustainable Energy Living Lab in Kuala Lumpur, and the solar cell, they put it in the signage, in the green, the yellow one, in the purple, and certainly on top of the building. This one is a net zero energy building. The last is design consideration from architectural elegance to structural integrity. The first and the primary is certainly architectural issue. I will not touch this one because Stephen and later on Arrizky will talk about this one. The second one for design consideration is structural issue. I'm sure everyone shocked to see this kind of incident. There are a few numbers of building in Hong Kong. The glass was broken during the Mangkhut tropical typhoon in Hong Kong in 2018. The wind speed reached up to 250 kilometers per hour, which is 70 meters per second. But if you compare the high-rise building and the small building, you see, in the small building, there is no single glass broken. Second example is this one, in John Hancock Tower. was designed or was built on 1971 to 1976. I don't know whether you know this project. This project, the construction cost jumped not only 10%, 20%, but more than double, from 75 mil to 175 mil. The surrounding street need to be closed when the wind reaches 45 miles per hour, which is 72 kilometers per hour. The reason because when the wind reaches that number, the glass fall down, and 10,000, more than 10,000 glass have to be replaced, and this one is cost 5 to 7 mil USD. And during that one, the glass was replaced by plywood. And people cynically mention that this one is plywood trends of plywood place. So the question, do we want to have this kind of building? That's the reason why structural issue is very important. One thing is load on the facade. We have to understand the load on the facade. The one of the most important thing is the wind load, which is derived from the calculation of wind tunnel test. Wind tunnel test will provide very accurate wind load result. And we have to understand that the wind speed in every country is not the same. This one is study from Australian, HB212, and Vietnam fall under the same category in Australia and Philippines, which is have higher wind load than Indonesia, Singapore, or Malaysia. And the wind load in one building is not the same. Certain elevation might have higher wind load. If you can see this one, the red one have higher wind load. So this one have to be taken into design consideration. Again, John did mention rightfully that we should not be lazy, just take the worst condition. We have to consider that one by one actually. Something different probably. Anybody know this one? This one is the world champion 3 times, Red Bull. So wind engineering have been considered carefully in the car design, especially in the Formula One. But how about in the building? Actually, in the building, we should be able to design it as well. We can see the shape will contribute to the drag coefficient. And the shape of the building will have implication on the wind load. RWDI, wind engineering, provide several options how to reduce the wind load. First is soften the corner, tempering, driving cross-section shape, spoiler, porosity, and spiring shape. We can take a look, one of example, this one, Shanghai World Financial Tower. What did they do? They do tapering, spoiler at the corner, and opening at the crown. And the second one is Shanghai Tower. In here, they did more than normal people do. They did spiraling shape. On top of that one, actually, they are considering 5 different rotation angle. And this, they study it one by one, and actually by have extreme rotation angle, the saving is more. But at the end, the architect and the client choose the second best, which can reduce the 5% road reduction, and end out is 10 million US dollar, enough to pay your facade consultant. Another load on the facade is life load. Point load on the facade, surface load, other specialist load, blast load, snow load, which is on the specific region. I'll do it very fast. And building movement, this one another thing that is very important due to life load, wind, seismic, and so on. The building movement can consider inter-story drift on the other direction, slab deflection, thermal expansion, which sometimes people don't consider. So sometimes in the morning you can see the curtain wall is but in the evening you can another also. That's the reason why the design was not considered thermal expansion. Column shortening or structural settlement. This one happened especially on the large cantilever area. That will be having impact on the structural settlement. And this one having impact on the joint between the curtain wall. Some architect ask, is it possible to have highline joint here? The answer is no. If you want to have yes, I mean the building have to be designed very rigid, and this one will be very, very costly. So another calculation, how to do horizontal joint, vertical joint. I will not touch this one because we'll take a lot of time. The point is the curtain wall or the facade have to be able to accommodate the building movement. Comfort issue, also another thing that have to be considered. I'm not going to do, a lot of people talk about this one, achieving the comfort. The point is we stay more and more indoors, so we need more comfort, and this is one of a very nice diagram that human comfort, external comfort, human comfort getting more and more, while external comfort getting worse and worse. So the facade requirements getting more and more challenging. What we do getting more and more thing as a facade engineer. And next one, this one. Do you want you want that kind of building, or you want this kind of building leaking? But I hope this one not happen in Vietnam because you have a very good facade contractor. But this happen many in South Asia, leaking. The building burning because of the facade is one in London. The point is durability and facade quality work. So we have to pay more attention on the correct design, correct material selection, and installation quality. This happened a lot in project, certainly not project under us, but this is a forensic project, so the client asked us to do this one. The installation was not done properly. That's the reason why a lot of tests have to be done. Sometimes the client don't want to pay the test, but actually test is very important to ensure that the facade work is designed properly. So the conclusion, there are few other issues that we need to consider: architectural, structural, user comfort, durability, facade quality, and the last and not least is the cost. And so last time when we are talking about what facade is, I always mention facade is a fashion, which is influenced by time, function, location, and technology. But I think facade is more than that one. Facade is something beautiful like this one, equivalent to integumentary system, which is a physical barrier between external environment and internal environment that to serve, to protect, and maintain. Actually, what is integumentary system? It's our skin, our hair, and that one that provide beauty, something that this lady. So, and this one need to be maintained. So, facade need to be maintained as well. Don't think that facade can durable 50 years without any maintenance. There is no such thing, no maintenance facade. We have to periodically maintain the facade. That's why in Singapore, BCA released that the facade have to be audited to ensure the safety. If we have the wrong facade, the renovation is painful. Pain is plastic surgery. Okay? So that's the reason when we design the facade, have to be designed properly. Okay, thank you very much.
Thank you, Mr. Timothy, for a couple of minutes there. And chúng ta sẽ đến với phần thuyết trình của diễn giả tiếp theo. Please welcome on stage Mr. George from Souquet, Southeast Asia.
Hello, good morning. Good to be here. Thank you, Timothy, for this always entertaining and informative presentation. Really great. Always one of a kind. Thank you, Ahmed and the team, for inviting us and making this event possible. Thank you, Vietnam team, to invite me. My name is Joerg Schleusener. I'm the project director for Souquet in Singapore, also kind of technical director. And we were talking about not so boring buildings this morning, Stephen. Great presentation. So I would like to discuss or present you a few things about our latest on the grid to shell. That's a systemized facade system for parametric facade, vertically, horizontally, which we developed over the last 2 years, mainly from the Middle East office. I would like to jump into the digitalization. We have a tool, we call it IOF, Internet of Facades, I would like to present. And the last thing is about safety measures on the windows, because we realized worldwide, I mean, it's not only a Southeast Asian problem, but also worldwide, windows to secure and make them safe in our, oops, that was the wrong one, in our, rigid conditions in Southeast Asia with the high wind loads and sometimes a little bit of a risk on the workmanship from the fabricator, it becomes an issue, and we need to highlight this and do some measures on the windows. But first of all, of course, we go into the grid to shell. So everybody knows the free structure forms on roofs, on malls, vertically, horizontally. So everybody wants to design whatever the architect's freedom has to do and follow design, follow strategies, intents of everything. So everybody knows these kind of structures on the roof, and you analyze it, the shape, what do you want to have, also what's the interior underneath, also what Matthew said about the living space in areas and everything. So you need to design that in a proper way. So what we had to look at is, and everything, just speed up a little bit, sorry, is every time you have to design it newly. Every time you have to follow the design intent and also the restriction kind of from the installation, how to put this in place and execute this and everything. So we were always thinking about how can you make this more efficient, easier to install, then also saving time, saving costs and everything. So just a few examples about studies, vertically, horizontally, and everything. Hold on, sorry. Just the whole thing. So what if we can systemize this somehow? I mean, we are system suppliers in 70 plus years, and we always, maybe also our German roots makes always, how can we more efficient, more down to the execution for not only designing and the architects covering the architects and support them, but also helping the fabricator and the site construction to make this everything more efficient. So what if we had a system that is parametric, so all three forms are possible, whatever the architect or the client wants, vertically, horizontally, or both, even a combination of vertical facades and horizontal facades, coming from these different kind of things, open areas, so versatile. You have all kinds of forms and shapes you can create, and now with all the computers and softwares, you can easily put this in place. Then, of course, the traditional one is always with heavy steelwork, spanning from one side to the other, so we can use our bread and butter material, aluminium, which is light and recircled at the moment, so we are looking also at recyclable aluminium in all the sustainability discussion. So a full freedom of design from the architect point of view, developer also if they're involved in the design, so you can do every shape you want to do. And then looking at the fabrication and installation, it's really, we want to make this easy and quick to install everything, because everybody wants to have a quick completion of the buildings and everything. So at the end, with all these aspects and looking at all these kind of things, it's also cost effective. That was our target and to do this thing. So from the grid lines of the designers or grid models, you always talk about this, and then we're still talking about structure and spanning a huge space and everything. So we call it grid to shell, G2S, whatever you call it. So mainly, you might heard this presentation already in Hanoi or in Singapore the last years. So this was mainly developed by our Middle East team in Shikoh, and they are quite successful with a lot of projects in there. I would like to present you a little bit again for this one at Ho Chi Minh, and we also had a discussion and the opportunity to talk about being windows even for the Long An airport, but yeah, still ongoing for that. So basically design, I mean, you always want to make a shape, whatever, organic, round, edges and everything, you break it basically down into triangles, regular shaped, irregular shape, whatever. So what we realized is then looking at the design, it's always a kind of repetitive thing. In the transoms, we call them mullions, they're always the same. They are straight, seldomly curved or anything. If you go for the triangular shaped surface, the only thing what is always different kind of is the intersection. We call it knots. This is something we have to individually customize, machine it or anything, but all the rest of the material connections, straight mullions, then the interface with the fill-ins, glass, fabric, whatever you put on the facade, that's always the same, more or less. So we systemized the rest, except the knot, the blue highlighted here one. In our system now, everything is systemized, and you can order it from the shelf, basically, except the knots. This is really something we need to follow the design and show the architect or the developer or also the consultant then whatever is possible in terms of also what John said about the drainage and everything. So we have to look at all the aspects, and our team in Middle East and also in Germany can easily do that with all the current softwares, Revit and Grasshoppers and everything. So they can also design. While they design, they follow up with the structure, dimensions, all the loadings and everything, not only from the system, but also then the loadings into the edge of the building or the opening into the main structure, which helps then also coordinating with the main contractor, main structure companies and everything. So we can share this in an early point. So they can also design the main structure, the foundations and everything. So this is pretty advanced. So looking at the knots, they are really customized and machined to the project needs. We try to rationalize it, of course, but depending on the shape and how much freedom the form of the skylight or the vertical facade is, the more you have more or less of these knots and different knots. So we try to rationalize it and keep it as similar as possible, but they are individually designed and then also machined in our factory or production hall in Middle East in Dubai. So they're really accurate. So the tolerance are less than 1 millimeter, not like steelwork where you always have to deal, whatever, 40, 50 millimeters. So lots of times more problems. And then really to look at the structure below, you have the outside. Oops, no, I pushed something. Sorry. So you have the outside surface, glass most of the time, but also you can use other products. We can combine it. And then below is just like in a normal stick system, what you usually use on a straight vertical facade. You put underneath the rigid and a little bit more structurally performing aluminium mullion, we call it. So comparing to the traditional, what you usually use over the last, 50 years, you have the top one with the glass more or less the same, but then below you have a substructure or first structure where you carry the glass as a carrier, and then below, depending on the span and the area, you have to bridge huge steelworks, different shapes, and then also you have to follow most of the time the steel is really following the surface. So you have to design, customize the steel, welding, a lot of pre-construction in the factory or pre-assembly. So it's a huge effort, which is then, with our new system, really, depending on the span, of course, obsolete. So you don't need this much. I mean, this system can, depending on the surrounding, can span up to 70 meters without additional support. So any skylight on malls or even bigger building stadiums or anything could easily be spanned with this system only. So there's no additional steelwork necessary underneath. Then the primary structure, like I said, oops, sorry, I was mixing here. So the knots is really, how do you say this, a really sophisticated piece of machining. So this is really high level, on a high tolerances, low tolerances and everything. While you have the same thing on steel, you always have to fight with the shape, with the harder material and everything. So a CNC machine or a CNC fabricated aluminium is much easier to design and to manufacture, basically. So it's a little bit exaggerating. So it's not really apple to apple, but it gives you an idea. I know that steel companies are really advanced at the moment, so they can really do a proper job, but we think with aluminium is still a notch higher in terms of quality. You have also the good advantage, you can use most of the coatings, powder coating, PVDF or whatever, so the surface looks really nice, like everything. So really, we have also, by the way, a sample outside, so you can easily look at this one. So just a couple of examples. You can also, the underside of this knot, you can also shape this in a architectural design shape, whatever you want. So this is really very flexible in terms of design and everything. So really nice uniform surface looking on the design. Of course, everything is tested up to 4,500 pascals, so really withstand on any of the wind loads. Even we could go for Hong Kong or Taiwan or Japan, maybe a bit higher, but yeah, all tested vertically, horizontally. So this is already pretty much done. Then some couple of examples about what I said before. So you really have the chance to make a vertical facade, any shape, and then goes into a roof structure, a skylight. So any lobbies or entrance halls or everything you can easily create and everything. So it's really, and also looking light. So it's not only also physical light, but it's also real light. So other structures, so you can really different shapes, and also the interfaces to the normal, traditional vertical facade is very easily done. Both same materials, aluminium to aluminium, so you can interface very easily and very efficient. Some couple of examples in the Middle East. So we had, I was not involved, I'm based in Singapore, but they had the challenge or the inquiry from the client. They want to have this open space on a mall, an atrium, but still kind of shaded. So what they decided now is making a shape, a freeform shape, but then within the triangulars, they put different materials in. Some even they left it open, so they're different fabrics and shading to make the whole thing a little bit, transparent and a bit light. So looking at the fabric, we also have a standard system we call Façade about fabrics within aluminium profiles, which are spanned over different areas as a rain screen or as also renovation facade. If you have a boring old facade, you want to pop this up a little bit, you just put this in front as a rain screen with different colors, different print is very nice. So in this case, they had to combine this because of the free form on the roof, on the skylight, with our grid-to-shell structure system. So you have this facet or fabric system where the fabric is really spanned on the frame, and they had to put this on the grid-to-shell on the structure, which allows these free forms. So they just combine it because it's simply, they're two different, they're not different materials. So you have aluminium below, aluminium on top. You just put it together without any issues. So the end up is really a nice, super shaped system with shading, open space, which really makes the whole thing very light and very, very open, but still has a kind of shading. Is there sound coming? So this is a bit about our team in the Middle East.
At Souquet, we strive to provide our clients with the best possible technical solutions, and our latest innovation system, Grid to Shell, or G2S, is the epitome of aluminium engineering.
I didn't do anything.
Clients and architects' free-form geometrical desires can readily come to life. The complete parametric aluminium skylight or facade is designed and engineered in our 3D software in a fully digital process from concept design through to fabrication.
Yeah, good. Yeah. I didn't do anything. Yeah.
Here at Murdoch Avenue Mall, you can experience firsthand the true beauty of Souquet G2S.
I have to speed up a little bit. My time is running out. Okay. Anyway, so you had a good impression about what's possible. I mean, this is just a small one of many things. So whatever design intent you have, contact us. We can find a way. Still looking at the whole thing and also efficiency and also in terms of cost and everything, we need to not only look at the outer skin, what we are now presenting with this grid to shell. We have to look at the holistically, the whole thing. Where are the advantages compared to the traditional steelwork and the add-on systems and the carrier or the secondary steelwork? What we did is really a rough, a simple comparison is saying, okay, if you have the aluminum, the grid to shell, you don't need any platforms underneath. I mean, the platforms you saw in the video was just accessible for the people walking around. So this was not necessary to support our grid to shell structure at the top. So steel, because of the main steel work, you always have to support them. It's a lot, and if you are in height, it's a huge effort and also cost thing. You have to get the equipment, the scaffolding in there. So there's a lot of things. Also in terms of lifting and hoisting it from the ground, you can prefabricate our light constructions everywhere. I mean, either in the factory and then transport it if you have the transportation on this, or you do it on site because it's really a simple not IKEA style like, but it's really clicked together. So you bolt in, you have the knots in the certain positions, you put the mullions, bolt it together, and then move on to the next one. So you can create these parts of the structure and then move it into the place on the building very easily. You don't need heavy lifting, tower cranes or anything, just simple mobile cranes or simple cranes. You can put it easily in the structure. So you see that it's really super light, and then put the glass in or whatever material you want to put in. It's really, really efficient and saves a lot of time during the construction and on site. So just similar like that. You also have these columns or the structure where the whole thing sits on. They can be easily connected to the knots at the side and everything. So this is really helping a lot of things on the side. Easy fabrication, easy fixing together and everything. So this is really helping a lot. So I'm stopping this now a little bit. So skylight, vertical facades, any shape, recess outside, regular, irregular, you can be as much as possible. You can do, and it's very light, so you don't need additional steel or main structure behind. It's really self-supporting more or less, depending, of course, on the city, on the location of the project and wind loads and other conditions. But it can be really simply designed, as simply as possible. So even link bridges or different shapes, anything is more or less possible with anything. So really fully parametric, freedom of design, but it still has a efficient systemization within to help everyone on the project. So nothing, no boundaries, no nothing. You can really easily design everything. Of course, we also have to look a little bit on the cost, and then also on the CO2. Carbon footprint, everything. So looking at the cost, I mean, we had to look at different parts of the installation. So of course, you look at steel, at the main structure, aluminum materials, steel and aluminum. You look at the glass, which is the same, either use steel or aluminum. That's no difference. But then also fixing materials, installation cost, and everything. Just purely at the cost, not at the time. Of course, on steel, we have, on British shell, we have a little bit of steel, more steel on the traditional one. Aluminium, of course, is then the other way around. We have a lot of aluminium on our system, but less on the steel, on the traditional steel system, and so on. But if you can count this all together, the grid to shell brings more efficient or more savings to the building. This is now a study from UAE. But it was really around 30, 35. But if you look at the whole thing, so you have to invest and pay a little bit more on the system, yes, but after, on the construction and during the installation, everything saves a lot of costs on equipment and time. I mean, time is also money. This also then has to do then not only looking at our supply chain and everything, but really just looking at the system, we have a saving on the CO2 and the carbon footprint. So this is still a work in progress, so this is not really representative or looking at the whole thing and the whole development, but you can say if you compare it to a normal traditional steel structure, free-form structure, we are saving a lot on the green energy and carbon footprint and everything. So I skipped this one just to have a little bit more time. So looking at the trend or the new development in our business about digitalizations, which is also kind of linked to all the carbon footprint and sustainability thing. What we did is now looking at all our bread and butter, anybody has the same windows and doors, how can we monitor, how can we make a tracking device or tracking software on the windows? Because if you install Windows and the end user is using it and there is a defect, it's always a big hustle, would say. The end user is calling the management company is calling, oh, who was the fabricator? I need to call them. Oh, it's just a handle that's broken. Oh, I don't have any spares and everything. So it's always a big hustle. What we did is now the IOF, or what we call it, the Internet of Facade, which is a small QR code on the window installed and gives you all the information about what material to use, what system, what handle, who was the fabricator, who was even, you can put in the installer company or the person who installed this. So really, you have the complete chain about tracking and monitoring things. So a little things. So really comparing on the left side, this is just the window, that's it. But on the right side, if you have the AIF, you get all the information. You can even include all the certifications, test reports. whatever was during the design phase, you have the documents, you put this in the library, in the data, in the files, and you scan it easily with this software and on the QR code, which can really then give you all the information about the used windows and systems. So just a little
Digitalization
animation.
is changing how we build, but the vast majority of building management is still analog. With Shuko, Internet of Facades, and now our IOF ID, we can leave pen and paper behind for good. Windows, doors, and sliding doors will no longer be independent elements, but rather links within a digital network of buildings, turning cities into smart cities. Shuko IOF ID is a small tag with a big impact, giving one access to all the relevant product information and making mountains of specification documents a thing of the past. Storing this info digitally saves time, space, and money, and ensures maximum transparency. With IOF, building maintenance is more efficient and sustainable. Which handle was installed? When was maintenance last carried out? How can old components be recycled? All this information is available in the digital twin. It can be tracked anytime, anywhere. For clients, investors, and facility managers, this means more data, and ultimately, greater control. The future of the digital building envelope starts here with the new Internet of Facades ID from Shuko. For facades that can do more.
Okay, let's bring this up. Okay, sorry, I need to speed up. Already 1 minute. Okay. Give me 2 minutes. Sorry, I was too excited about Gritty Shell, so it's really a great product. But the last but not the least one is really about safety measures on the windows. Because what we realized, what I said before, worldwide, to whatever reason, I don't want to say anything. Sometimes it's also our missing control of the fabricators. We are facing issues on the windows. So installed windows in a high-rise building, especially during the construction phase, they still keep it open because all the interior work, there's a lot of paints and other smells, they need to ventilate and everything. And then a heavy wind is hitting the whole facade. So sometimes we had even cases that a whole window was blown out. Luckily, nobody was injured and everything, just damages. But this has become now really an issue, especially here in our region with the higher wind loads and the rough conditions and everything. So what we were thinking about, this was also driven by the Middle East, saying, okay, you have extreme events or extreme conditions. How can we handle this? How can we test it? And then while we develop this, and how can we prove that it's really working? So basically, we had three loads or three scenarios we want to test it. So it's the impact load, the dynamic load, and then the sustained loading and the creep effect, let's say. So what we did is we thought about how can we test it. So a very simple components within the windows just to help the outer frame, the movable part, to be fixed to the inner frame and not blowing away or falling down. So we have ropes basically as a catching device, which will be then tested on a tensile strength. It's up to tensile load up to 940 kilograms, so almost a ton. The ropes can withstand. And then also we had to drop it down, so the sudden impact load. So we let this specimen just drop after after a few seconds, just to see that the ropes on the top are holding it. So this was really heavy, 380. Then we did a simulation that you have a negative wind sucking on your facade, trying to blow out the window. So we made a negative pressure on the inside and then suddenly release it, boom. And then you see it really kind of exploding the window, but it's still held on the top ones. And then ultimately what we had, okay, once the whole thing is somehow out of the frame and hanging, swinging around, how can we make sure that it's still holding on these two ropes until the people are coming and saving the window, basically. So what we did is we put the window hanging in front and then blow it with a ventilator and a propeller on site just to see how it swings around and with this load and if the whole thing is holding up. So good. Takeaways, grid to shell, great product. We're happy to help you on any design form and efficiency on the building, cost saving, hopefully not so boring buildings. We can develop with that. IOF, digitalization, getting all the information inside the facade and saving a lot of paper. And you can also use this for recycling, what is the material used and whatever for later. And then the safety restraints for open windows, which is really, we need to urge and want to urge everybody to keep this in mind, although it costs a little bit more, but it helps a lot of on the safety. Good, thank you very much.
Thank you, Mr. George, for your speech. And Internet of Facade is a really impressive system, great ideas. So, xin chào mừng diễn giả thứ 7 của chúng ta trong buổi hội thảo ngày hôm nay. Please welcome on stage Mr. Arrizky Magetsari, EDAS.
All right, thank you very much for the opportunity to speak on this very exciting event. I'll try to make my talk a bit faster, so for us to get to lunch faster as well. So today I'll just gonna show you guys about how we are trying to explore facade and identity in Southeast Asia context based on our showcasing our few case studies of our project. All right, just a bit overview of ADAS on who we are and how the Singapore office become the Southeast Asia hub for this region. But what interesting is we believe that great design comes from people who understand the social and cultural aspect of where we are designing on. On the design itself, I mean the facade design, I wouldn't dwell too much on this because Timothy and John has been going through this, but in terms of designing a facade, we need to understand the facade types, the considerations of the environmental and all that. But of course, also limited by material types. And they're also constrained in designing a facade with budget, obviously the number one on the list. But regardless of all that factors in designing a facade, we believe when we as my first slide, that we believe that the great design come from people who understand the social and cultural aspect of the environment and the place that we're designing for. So we put emphasis on designing for our social, cultural, community, and also sustainability. Today, I'll take you to 3 case studies in Southeast Asia with different approach, different types, and different locations. The first one is understanding local context and culture with a project in close to Vietnam, in Vietnam, Sun Cosmo residence in Da Nang. So the project itself is actually in Da Nang, just side of Han River, very close to Da Nang International Airport. It's 3 sites of residential development, very close to the bridge. What we did is actually trying to understand what the city is about. We have Vietnamese colleagues who help us designing the project. And we understand the project itself very close to Han River Bridge. Then there's a lot of bridges in Da Nang itself. And Da Nang, it's a beautiful city, beautiful coast, a lot of nice beaches. And we're trying to delve into what is the cultural aspect of Vietnam and Da Nang in particular. We found out that there's a charm culture, there's a pottery villages, there's a famous agar wood products. Da Nang also very famous for lantern, the Zak mat, and also the stone carving. So we took this into considerations when we're designing the building. We, as an architect, we're trying to doodle and funding form with sketches as our natural instinct to approach a problem. And for the facade itself, we found that the sedge mat actually very, very interesting to be put into the facade of the building itself. So we did a series of how we come out with a facade from the basic massing. We add in the vertical and horizontal grids. We create these ribs that hold the grids together, and we added these colored elements to emphasize the inspirations of the sedge mat inspirations. And in the end, we highlight some of the special features of the building itself into the podium, the sky garden, and also the rooftop experience. And because of the shape of the tower, we come up with different colors, different theme for each block of the tower itself, alternating between horizontal and vertical lines that create this inspired sedge mat facade. And of course, being residential, we want to maximize the window height, looking over to the Han River and the Han River Bridge, making sure all the residents have a very nice living experience. And of course, highlighting some of the key facade elements, the podium, the sky garden, and the rooftop clubhouse is the inspirations of lanterns, how this building can be perceived from afar as a lantern as well. So we designed Huynh lantern-inspired clubhouse on the top of the building with the terracotta materials, with some traditional Vietnamese pattern as well. And of course, to add to that is how we create these multi-level greeneries in facilities on the podium, on the rooftop, on the sky garden, and also in the podium as well. So basically, what we're trying to do here is trying to create a culturally sensitive architecture, which our client Sun Group have a very good receptions of this project that has been launched in a few months back. From Vietnam, I take you to Philippines. One of the projects that actually Matthew has did an introductions in his slides is a Park Hall mixed-use development in Manila Bay. So the project itself, located in Manila Bay, is a thriving new area in Manila. It's a 900 site, just located near the Manila Bay itself. So when for this project, we took inspirations from a Spanish Plaza, and how it become interconnected with a street of fully pedestrian movement. So the park itself comes from the name park and calle. Calle means street in Tagalog. So these become our main concept for the development itself. And how we do that is we extract the urban fabric of surrounding areas. We create a series of urban plaza. We enhance the connectivity with fully pedestrian movement. And we create these civic spaces. And we highlight the key iconic flagship features at the corner of the developments. And then, of course, we work with Factor Foil Tech to create this beautiful park hall canopy that covers the whole pedestrian movement and also serve as weather protections for the visitors. So this is the original envision design, which is 900 meters of retail strips. But we have finishes 650 meters part of the park hall project itself. That has been, we went to the grand opening, I think a few weeks back. Me and Matthew met there on the opening of park hall development itself. And how we create this community plaza, again, this is pictures from the opening, so there are a lot of stages being done in the project itself. And how we come out with the architecture and the facade of this building. We draw inspirations from this Bahay Navato, which is a traditional Filipino architecture that actually fuses Spanish and Chinese architecture in terms of their shapes. And we explore the idea of excavating facade, where actually if you pull out a stone, there's another layer of elements that we translate into a retail shop's experience. And the result is how we can unify, how we can break the formations of the retail strips with a different type of architectures, different types of materials with retail streets and walkway, and also covered by this ETFE roof cover that protects the pedestrian movement and the visitors of this building. We look into different types to create this series of architecture. We look at different types of facade, different types of materials. We develop this into different shops has a different element, different identity with the materiality and also the signage of the shops. That resulting into quite a unique experience that you don't have it in anywhere else in Manila, because this project becomes one of a kind type of developments in Manila as well. Yeah, and again, the idea of the Spanish plaza, that we envisions to become the civic spaces where people can enjoy and people can have some activities, even plaza that translate into the actuality of the building itself. So I think I'm a bit too fast. So I'll take a step back a bit. So this is another project that we're really proud of. Unilever headquarters in Jakarta, Indonesia. It started from a master plan that designed by us as well, where we actually did the Sinarmas Land headquarters. This is in BSD in Jakarta, Indonesia. And we were asked to design the Unilever headquarters with a very particular brief, which is how you design a building that uniquely Indonesian, but without being too literal about it. So again, this project won numbers of awards. So we started with trying to understand what makes this headquarters is uniquely Indonesians. We look at different inspirations and visions, how Indonesia is rich in nature, very big in communities, and because of Indonesia is an archipelago nations, it's a very diverse type of people as well. From here, we design a central space that we call that get inspired by a traditional square in Indonesian called alun-alun. So it's a large central space that is a public space that creating this sense of community and collaborations within that space. So if you can see here how we can translate that ideas of creating this community into a event space that's surrounded by the workspace. And for that is also we trying to encourage diversity on how we look at how people react, how people connect from one place to the other, how people collaborate. So we devised this kind of a series of places that can be used as an ad hoc collaboration space. That space is contained within this atrium, which is the event. They use it as an event space for their branding. They use it for town hall meeting. They have these very extensive triple height volumes that encompasses the whole heart of this development. And this is the skylight for the natural natural lights. I think that was presented from John as well just now, where the building is actually using less lights because of these skylights. And this is the space that we designed in terms of the concept of alun-alun, where actually this is a central square that all functions is surrounding this central space, whether it's on the ground floor is the restaurant, the canteen, the salon, the childcare, the gym, and then the upper floors is meeting spaces. On the above floor is the working spaces, and then in the above is the management facilities. And we're also looking at Indonesia as a very tropical country, a lot of rainforests, a lot of greens. So we have these discussions about how we bring that green concept into the building. So we come up with a series of ideas on how we integrate the greenery into the building, creating pockets of green, creating green fingers. The greenery is going in and out from the building, from inside and out, creating these indoor and outdoor spaces. And that green also becomes part of the atrium that we design. And we actually looking into, this is the greeneries from the outside. As you can see, there's a steps that becomes indoor and outdoor working space. I mean, there's a lot of discussions about what is the future of office post-pandemic and all that, but we actually have looked into this kind of concept, I don't know, five years back in 2017, where we finished this building. So we promote this kind of a working environment, indoor and outdoor, with the greeneries that go inside and outside of the building as well. In terms of facade, we design it in a way that the massing is actually shifting, so it shaded, the plate is shading each other. And for the weather protections, we actually study all the louvers, the horizontal louvers, and we try not to impede into the human visions while they're standing and while they're working. So we study all the dimensions between the horizontal louvers as well. So to making sure where people work and when people walking, they can see clearly into the surrounding area. So again, the idea to understand the east and west and the north facade, we studied in terms of the solar gain and how the sun penetrates. And for some portions, which is like the west side of the building, we use planter to act as additional trees, as additional filter for the lights as well. And understanding how the planter works in terms of how it is attached to the building, in resulting into this very unique indoor and outdoor experience with the planter boxes as well. And in terms of modularity, again, budget is the main concerns from the client as well. So even though the building is filet to a certain extent, we're trying to minimize the curved glass usage in this building. So we design everything in modular. So it's all straight, it's segmented glass panels. So in the end, we very proud of these projects where we actually design for the community, understanding the diversity of the nature of the clients and the community in Indonesia, and also the natural aspect of Indonesia as well. So there it is. I mean, I try to make it very short because I understand there's still a panel after this. So thank you very much for your time.
Thank you very much, Mr. Arrizky, for having shared your experience. And now we will move to a panel discussion, which will be moderated by Mr. Tony Nguyễn. Hiện tại thì chúng ta sẽ đến phần phiên tham luận đầu tiên của hội nghị trong ngày hôm nay. Người điều hành phiên tham luận sẽ là anh Tony Nguyễn, Director Facade Engineering, Van Els Nguyễn and Partner. Please give a big round of applause to our panelists and moderator.
Good morning. Good morning, everyone. So I think I will introduce all the panel to come into the seat. So today we have quite a few topics to share with everyone. So this morning discussion will be about sustainable, mainly for sustainable in facade, and how the design and how we can help and selection of material, others such as sample for helping to give you a better sustainable design for the facade. So I will let every single panel to introduce themselves and where they're from. Which company from? Yes.
Yes, hi everyone. So I'm Regis. I'm from DWP Vietnam. So I'm the studio director. I'm very happy to be here today.
Hi, my name is Antoine Pommier. I'm operation director at Delhomme Acoustic, and we are acoustic consultants.
Hi, my name is Dat Kung. I'm from Bomslage Ebele Architecten. Today I'm so happy to join a conversation with our college. Yeah, thank you, Tony.
I'm Kian from Building Engineering, part of Circle. I think I'm more interested supply on engineering service. We also support for architect, acoustic, and for the project. Yes.
Hi, my name is Tony Nguyen. I'm co-founder of Van Els Nguyen. We are a Belgian and Vietnamese company specialized in architecture and facade. So today I'm going to be the moderator of this panel for discussion. Our topic will be about, sustainable is a hot topic and very important this day. My first question for the panel is what your approach to forward the facade design and sustainability. Maybe you can start with, if you want to start.
Yeah, the facade is always, of course, a big topic. When we start a project, so in the way we design things, one of the first approach on how we are going to design our facade is to, of course, look at the environment, look at the site, look at the surroundings, look at what can be the advantage or the inconvenience of the site that is offered to us. But also is all this integration of the program that we have from the client. And then when we take all these ingredients together, we always also include the other disciplines that we have in a project, because as architect, it's important actually to think about the concept, the shape, the orientation, or the style, but it's also very important to integrate all the other disciplines that will be the structure, the lighting, the HVAC, the acoustic, that will help us to shape actually our building.
Yes, thank you for your sharing. For me, it's facade, including three important features: geometry, materially, and lighting. And we most focus on also the technology behind, because I think the building is not only last long for 20 or 30 years. If the people love the building will last long. So we're thinking about our firm developing the philosophy of no heating, no cooling building, which is the building no need energy for cooling and heating. So the facade is extremely important. Facade is not really facade in a show architecture field, also show the secret of the technology behind. It could be combination of architect and also chip or sensor design behind. Yeah. It's a beauty combination about architect and technology.
Yeah, I think from our side, I think from building engineer point of view, actually we prefer the holistic approach because for every project we always try to apply the trial and handicap methods. Because the first thing we thinking on project and also facade, that what is try to limit the energy use for the project. And then before the facade, I also thinking that on engineering point of view, if we can change the shape of building to the certain direction to limit the solar radiation to the building and put the buffer zone for that. I think that's the way we also to get a proper facade and meanwhile efficiency facade and also the low down the energy for the building use. So that's the thing suggest from my side.
Thank you. Before we go in further for sustainable design into facade, I would like to share a topic that we've been quite overlooked for some time in Vietnam, but recently this become very important. That is the noise pollutions. So as you know, as I don't know you know, Vietnam one of the noisiest country in the world, and it's true, you know. And Hanoi and Ho Chi Minh City, I think we live in the top 10 country in the world. I think top 10 or top 5 now. I think you can correct that later.
Yeah. So the information you can get is that Ho Chi Minh City is the fourth loudest city in the world.
Yeah.
So above Bangkok and New York. First one I think is a city in Bangladesh. It's the amount, in fact, of road traffic, and 90% of the noise induced in this road is due to the motorcycles and their engines. So it really induces a lot of noise, and you have also all these aspects of sound horns, the honking.
Yeah.
That in fact represent mainly 12% of it, but that still have a huge impact, in fact, on the people comfort.
Yeah, so noise is something that we don't look at so much until now, that people don't look at to design or when they build buildings so much until now that we actually look at it, because like everyone have their own, have their own sensitive noise. Myself, I have very, very, very sensitive noise. So I'm the kind of guys that I don't like so much noisy and everything, and everyone different. So, so that's the thing with, as you said, Hanoi, Ho Chi Minh City now, the road is very noisy, and with the including of the mass transit system, the metro light, that's going to be the big issue for our future. So the next question for our partner is, how does the design and the construction of building facade influence the acoustic performance in terms of sound insulation and noise reduction, especially in Vietnam?
So yeah, I would answer on that part. So I think there is first of all, engineering approach. I like the point about the holistic approach, because it starts very at early stage concept design of a project, where like working with architects, you can think about how you can beneficiate from the geometry of the building to maybe like reduce the influence of the road traffic, for example. And then when it comes to, in fact, designing and defining the type of element you need to install, then you need to have a good comprehension also of the site situation. So is it like an existing extremely noisy place? What would be also the future aspects of this road traffic in the future? And then you start to look at the performance of product. And I think, yeah, especially in Vietnam and Hanoi and Ho Chi Minh City, you need to think about this city as a much higher noise pollution influence than other cities. So in fact, the type of product you will look for needs to be much more performing. And so different from the standards the standard product you use. So maybe considering like a asymmetrical glazing, double glazing system with laminated glass. So this kind of approach, and beyond that, then you need to take also into account the framing, because it's not only because you have selected a good glazing that then the installation is going to be proper. So it's a whole process.
Yeah, this is very important because I mean, by experience, because we work with you guys, so we know. So
can I ask?
Yes, sure.
I think especially for the people who the first time come to Vietnam, I think you are a little bit soaking with the horning and the motorbike noise. I think
The karaoke.
for Vietnamese people, I think we are living quite slow on narrow streets and also the small alley. Actually, we also have the noise from the daily activity from the people surrounding. That also impacts the noise. What I foresee and what I see in some certain the house, I mean, I'm talking about acoustic for the house, detached house. I think I saw on some, how to say, the intelligent strategy that they put a solid brick and they make a setback and put something, a small garden, also some setback and some, how to say, some tree, some fencing, and all that kind of thing also defend all the noise and vibration from the vehicle, from surrounding everything. So and after that, it put I think not so fancy glass, just a glass and everything will be fine. That's my thing.
Yeah.
So my question to you is, how about the military construction in here? They have a building code about how to protect the noise in the public? Because in my experience, I'm a team design a project in Winterthur, a city in Switzerland, near the main station. So the Swiss government have a strictly regulation about acoustic. So they require the corner facing to the main station must be by concrete. So our whole concept have to change it. So we have to coming up with this because there's no change. If you don't do it, you're going to get a license on this. So my question is, also we are expert on this. Okay, we have knowledge. So how about the government? How about ministry construction? They build a building code or some specialization about request about the noise protection in a building, some special building.
Yeah, I think this is something that we should emphasize and have the government to develop to have some kind of code requirement. Because right now in Vietnam, we use internationally for hotel, design hotel and office and everything, but we never try to have a concrete the value that we can use in Vietnam for, for actually with the Vietnam's environment, because, you have noise with low high frequency are different with no noise and everything. So that is something as well. We should, hopefully have the government try to have us with the number.
And there's one thing I wanted to jump on the story that you tell where people in the small streets, they like to build a wall and to have a setback and to get some greenery. And I think in the acoustic and the facade and the way we design the facade, we also have to take into consideration that there is a notion of how people also live in the building. And I noticed that in Vietnam, when you don't see the noise source, you tend to forget that there is noise.
Yeah.
So if you are in the building which have a full glazing, for example, and you see the motorbikes all day long, or you see a construction site or these kind of things, and you can hear the sound, and you will be more sensitive. And then if you build a kind of opaque wall, or if you play with how the facade is designed or how you can see outside, and then the noise will still be here, but the way you will live with the noise will be different.
Yeah, true. It's a psychological effect, in fact, that when people tend to not see the source, they feel less bothered by it. And I think it goes well with the way we design facade and building, maybe implementing greenery and element that would hide, in fact, eventual noise pollution sources.
Okay, just a quick question because we kind of run out of time. So the next question, could just put this, what is your challenge for designing acoustic and facade in Vietnam? And also, what is the kind of material that you recommend to use for, just quickly, just everyone knows, like you cover in the past, so we working together, we know that sometimes when you try to design a facade, because we talk about facade, right? We try to make a facade much more acoustic, we have better glazing, we better put, acoustic thing inside the frame and everything, but people forgot that actually your wall is actually leaking the noise, right? Because often we look at our hotel and actually the AC block with leaking the noise, the block with the hole that leaking the noise, actually, then you lost all the noise into the wall instead of your facade. So anyway.
In fact, the main challenge would be really understanding like the situation of the project, like what is the influence of the surroundings. Do we have like a heavy road traffic, what also it's going to look like in the future. It's very important because we were talking about projects where at the moment they were influencing by a lot of noise coming from the truck, but in fact we know that probably in 5 or 10 years they won't have. So it's also about being smart in the way we engineer the facade to avoid further situation, I would say. And then when it comes to material, I mentioned, so it's really like we need to understand that in cities like Hanoi and Ho Chi Minh, so we have this huge influence of motorcycles and engine that affect the facade. And so the type of system that we would consider probably in Europe or elsewhere cannot be applied in such cities. So that is why I was talking about like asymmetrical glazing system, the use of acoustic laminated glass, and then again, beyond that, as soon as you cover like the first point of the performance of the glazing, then you need to ensure that also the system that's gonna fit within the building will not degrade the overall performance. So it's about understanding, I think, the situation and then choosing the right material to make it sustainable.
So what's your challenge when you work in Vietnam for the working clients? Generally, when you design acoustic?
I think it's really like making them aware that the approach has to be sustainable, and sometimes you need to look like beyond the initial reality of the project. Again, we need really to take this holistic approach, and I think one of the challenge would be like often the acoustic part is disregarded, and then our mission will be like we will start at a very late stage. So then it involves like additional work and maybe like more investment when it comes to the performance of the facade.
Okay, can we go to? I think we're out of time, so we can skip to another topic, if you don't mind. So okay, the next one is, okay, as you know, we've been discussing this panel like and the talk before with many technology facades, many technologies. You have a curtain wall, you have double skin facade, you have all this fancy facade now. You have with a lot of thermal performance, very good. But I think, however, the passive design is very important to reduce the heat of building, and we cover that. So I think can you share more experience regarding your approach of the design and of the solution for the passive design?
Maybe I'm first. Yeah. My company is grow up from a small village in Wolkenberg in Austria. So that the people living in wooden housing, the very small wooden housing. So my chairman, Professor Dietmar Eberle, asking by myself that why our old generation living in a small village, small house, no heating, no cooling, why we need it? So he spent about 40 years to invest the knowledge to build the house which is no heating, no cooling. This is a part of how to using, he mentioned something like this, how to use in the most comfortable area, which is the temperature inside the house always 22, 26, but we don't need cooling, we don't need heating. So he coming up with that, and of course we cooperate with engineering like Boyden and some other scientists to find the philosophy. And now we could build in a different climate the house which is no heating, no cooling, the temperature inside always 22, 26, and the humidity is a perfect condition, but 60%, no heating, no cooling. So this is a part of passive design that bring the people more quality of the living and less the energy demand.
I think it has to be from holistic approach. Again, I think that's the story. I think all the environment item always affect the building performance. I think even the earth on the soil and the river surrounding, all the things also affect on the building performance. So if we look into that, I think we will find a chance to deal with all the energy consumption from the building regularly. So that's the thing I would say. We already had the project actually. We approach that kind of method even on the sketching together with the architect. Even the architect start to do the sketching and project, and then we told him that, okay, this building on this direction, you should focus more about to put something to block the sun. And then he started thinking about the way and also the, how to say, the traffic around and also the pattern operation of building. And then he listened to our advice and then he changed. And then the final result submit to client. I think it's quite good. I think at the end we have the good building and all the energy is already low down to the base point, at least about 50 or 70%. So that's the thing I would say.
Yeah. On my side, what I see is what we said on this holistic approach is that a passive design comes with some creative solutions, but comes also with the right selection of the site, of the location for the program that we are going to develop as well. So it lies a lot in the designer and the engineer, but it also lies a lot on the client side or the investor side about what they want to do and where they want to do it. Like you mentioned, there are so many fantastic examples, even if you go around Vietnam or in the small towns, in the small villages, where we can find some like a super sustainable or passive designs that are easy actually to implement on a small scale. And then the next difficulty we would have is how we implement those passive design in the much larger scales, like in the city and super urban place like Chi Minh City, for example.
And I think very important that the government should be support about the policy to support to develop that kind of project. Okay. Antoine, you're from France, from Paris, right? So our Paris office developing the wooden building. So it's very trendy, and also this is a building for futures, reduce carbon dioxide. But how, if in here, if architect mention client that, hey, can you build a wooden building to save the world? No. But in Paris, the government support the developer building the wooden building a lot. So I think it's very important that they have a special policy to support to develop the passive building, how to have the most optimization solution for energy demand too.
Okay, sorry. Yeah, just one on that. When you look at passive building, we have a quite sample, because I think we told you. We have, and Boyden and Dioho were working on this project. And so we have these two projects in Da Nang. There's two hotels. They're 200 meters apart each other. They are same height, they're similar design, they're complete room exactly the same. The only difference is one is facing the west and east directly, and the other one was oriented about 45 degrees, so it's avoiding the sun. And what we found is when we treatment the facade, the performance, one, we have to use the double OE glazing, and the other one we have to go triple, and even triple we still get so much energy because the amount of energy that get into the building from facing west and south, the hours that getting is so much compared to when you're rotating buildings. So it's very important when you design a building, the passive design a building, the orientation of buildings already can save you so much energy. Let's not talk about technology or anything about facade yet. Your orientation can save you so much energy already. Before you put in sun shade, before you put anything, design it right, put it right in the orientation building. Of course, in this project, the client have a very small land, so you cannot orientation building. But if you can just twist the orientation the way of facing the sun, you can save you so much, up to 70%, right? Up to 70%, the heat cooling already. Then you don't have else to get much better facade. It's more expensive than the two facades are the same, and then you can see the price cost between the two facades. And they are 200 meters apart. They're the same location. They have the same environment, outside condition outside. They're just different. Is they're facing the sun different.
That's true. That's true. Yeah.
So anyway, let's go to the next topic. Okay, what is your common challenge? Sorry. One of the key sustainable is maximize the use of local material. I think that's very important right now, the material. So what is, or should I say the local material procurement? What is your challenge facing in Vietnam and how you're addressing this?
Before I always mentioned about the building in Europe, right? So we also try to adapt and research how to make the building in tropical climate like Vietnam less cooling energy. So we start with some FPT University invite my chairman to have a lecture in FPT University. So the principal say, can you do one pavilion in here, no cooling? He say, yes, okay. So we come to see the oldest village in Vietnam. And what we realize the brick in that village have a thema, Very interesting. That thema, because in that village, the temperature in the evening lower than in the morning, more than 10 degrees. So the secret is cool energy come from that one. So in the evening, the thema brick, keep the cool energy inside the brick. And then they produce the waters. And then they reduce the temperature. So we create a pavilion by simple material, that local material. But of course, we design a thema like the ceiling. You can see in here different thema. Of course, were supported by a physics building like Boyden. So we try to arrange the structure of the brick. And we dig down underground to have more cooling energy. And we keep cooling like a basement. And the basement were made by material that to keep cool inside. And in the daylight, we bring the cooling to inside the pavilion. So you see, this could be the good reference that we learn from the local material that exists in the north 1,000 years already. Yeah.
I think one of the problems that we face in Vietnam are the standards. So in Vietnam, you can find a lot of amazing materials available in Vietnam, like the coconut wood or coconut husk, rice husk, bamboo, etc., etc. There is a lot. But when you want to use it in a project on a large scale or even on a mid scale, you need to answer to some standards, like what is the behavior of your material in case of fire, or what is the smoke that it will create, etc. And that is slowing down actually the implementation of locally sourced, locally made materials in projects in Vietnam. So when we need to answer to some specific standards, then what we do, we import products that have proper certificates and proper testing. So I think something to overcome the challenge will be, it lies also with the government and how the things will move forward, but how to put in place a kind of standardization or certificate library or process that could help those materials actually to develop.
I agree. This is one of the challenge we are facing, and the benefit of having engineers part of a project is that most of them, they have the knowledge and they will help to explain like why this product can help reducing sound on my side. But then yes, if you can source the product locally, then the challenge is like how you can prove that this is certified, and in fact you may have like an exact similar product available elsewhere with a certification. And so the challenge is that, okay, how we can make the use of this product available locally without a certification. Sometimes it's the tricky situation.
Yeah, I think for the recycle facade material, I also would like to say some kind of story. I think on my past work together with Van Alex, I think on that project, originally the architect also thinking about recycled material for the facade. And we looking on the Bachan village where we have the terracotta material all the time there. And we try to underline the old roof tiles actually to use that for the facade material. Unfortunately, I think also the same story Mr. Das told that we are lacking of standard. So that tile actually cannot maintain the uniform for entire facade. So maybe this roof, the color is okay, but there's a roof, the color is already bad. So all that, combine all that kind of thing, make it very, very difficult for architect to make a decision to try to recycle, because the material cannot be standardized for the way to be used in recycle way. So that's quite difficult. So I think on the government side, if we have also thinking about the standard to recycle, to extend the lifespan of the product. So is that could be help for recycled material for the facade. So at the end, that project, we also had to use a terracotta bucket, actually import from overseas. That's quite expensive and that's very bad for that. But at the end, we don't have any argument to against with the local authority because we don't have the certification, and also the maintain the uniform and maintain the color characteristic of building is also cannot comply. So that's the sad story. But I would like to say, is this okay?
Yes, it's local material. Outsourced local material is very, very important if you look at this. And so if you want to get your energy certificate, LEED or something, also, but if you can contribute already, because for example, something like aluminum. Aluminum is a material that can be recycled many times. forever. So when you look at, when you procurement your facade, you can talk to your supplier. Most of them now can contribute 30% recycled material. Most material, the material they get from their supplier are already can get 30% recycled material. That's contribute already, because that's also can meet lead requirement. One of the lead requirement is like 20, I don't remember, 20 something, 30%, you know, that. And that's that's already did for the facade alone, you know. Ask when you do a project, ask your supplier, where's your material from? And you can ask them, do you have recycled material in your products? You know? That's something. So our project, when we do at least one, we always ask them. And you remember, on our hotel project, on the same own certified, and they all have facade, they all have material are recycled. So for example, aluminum recycled 30%, up to 30%, I think requirement. So it's something you can do already. It's not just, you know.
Yeah, that also the policy support and standard support. Yeah.
Yes, I mean, because this project we're meeting lead requirement. But if you don't have a lead project or something, you still can ask for it. You still can ask for it because it's valuable. So, you know, ask for it if you want to. Okay. Sorry. The next question, what is your commonly challenge in maintaining business model for architecture? I think for the partner, our architecture partner. What is your commonly challenge to maintain the aesthetic appearance of the building facade while optimize the performance?
Like I mentioned before, you know, the lifespan of the building is about 30 years to 50 years.
20,
yeah.
20,
So
25 years.
I just got a lectures in about, you know, facade maybe last long, maybe 5 to 10 years. Yeah.
25 years from normally.
A facade, if the building serve for public, it will last long. You can see the opera house in here.
Yeah.
You know why the people love opera house in here? Because serve for the public, so it lasts long. So facade is very important feature of the building. If you care about this, if you do optimization building of this, if you follow the best solution for it, the people love the building can be last long. And like I mentioned, facade about 3 features: geometries, materially, and lighting. So I think also we discussed about the local material. So we combine it with this. So I have to say, working in Vietnam as a facade design and architect, we have so many materials, so many challenges, because we are tropical climate. So we have so many challenges and also opportunity to, I have to say, to have a very fantastic journey in a design expert. That I feel luckily that I work as a designer in here about the facade issue.
Yeah, I think the main challenge is to keep it performant.
But you know, the client always say, you know, optimize. I want it cheaper. How we get a balance, you know? Because most of the time you gotta be, you know, go to the client and say, I want it cheaper. You know, facade all the time.
And I think the second challenge is the clients, is because it's not because they want cheaper, but because we can always do cheaper. We can always find some very smart ways, like double skin, natural ventilation, etc. But it's to get the trust from the client that it will work.
we always make a joke with our colleagues that when we have in this season, we say how to create a wow factor in a limited budget.
It's true.
Yeah, because we know there are so many examples that are working but are a little bit unconventional to a lot of clients, actually. So when you come with a very good solution to keep a good aesthetic and a good performance, you have something which is not, let's say, mainstream or widely used. So then you will get the question, but how do you know that it works? So yeah, but if no one is trying it, then we will never know. Or we should all be part of a kind of big experimental process, and that's one of the challenge. It's like we do something beautiful, it will become expensive. We do something cheap, it will become too special.
I think it's really about like creating awareness and ensure as a team that you can prove, in fact, by engineering, architecture, and creative approach that you can achieve like amazing results. And I think like one of the things we've experienced in Asia, in fact, is that as soon as you start to develop probably one project like this, then also it gives you an opportunity to showcase, in fact, this experience and say, okay, look at look at here, like this has worked and we have saved like so much energy, saved probably a lot of cost. And so then you gain trust. But I think, yeah, it starts with like creating awareness. You cannot come and say like, okay, let's do like this. No one will follow you, I guess.
I think I would like to add a little bit on that because we are talking about the maintenance. So my suggestion from engineering point of view, if we making the facade become the modular, so because we cannot ensure that everything is perfect all the time. So by making it modular pieces, so that means we can replace it easily, and also the manufacturing of that kind of pieces also has a high cost efficiency. That also the big benefit for the architect. From my point of view. And also, if we make it modular, I always saw some the other present at the beginning of this event. We also saw that by making the modular, so that means the architecture also can more space to play with the shape of the facade. So that is my suggestion in this case for maintenance. So everything can be win in this case. Yeah.
Thank you. I think one of the key one is for me. It's just I think we have to tell the client just look. It's like you said, the facade. It's like you're wearing a clothes. One you put in a building is 25 years before you take it out. Okay, so 10 years ago when I came back to Vietnam, I tell the people, I said, okay, you need to perform in your glazing, and they said, I just want the appearance. I want it, cheap as possible, so single glaze and everything. But I said, your facade can last 25 years. Soon you're gonna find out it's get hotter, you lose your energy and everything. And look, 10 years later, it's outdated already. Those kind of building outdated already, and it's only 10 years. So, client have to understand, now we start to moving, clients got to understand the performing, you double glazing, then you're understanding the noise level, the problems, and then come to the, not just fancy design and just something look good for a few years, and then appearing losing it. And it's also not just the facade, the quality of the product as well. After a few years, some buildings already degrading. You have to remember, 25 years, you want to look as good as that. Just your clothes wear for 25 years. You want to look as nice, at least for 25 years, right? So, our next question for the panel is, what is the common challenge how is your ensure the facade quality being built by the contractor and meet the architect design and that the system being built is right? This is very challenging in Vietnam.
It's challenging because you have to, when you are the consultant, you have to be on board until the end. So that is the challenging point, because sometimes your client likes to have you only for the design and don't let you continue. But one of the biggest challenges is to be there on the whole process, because when you are there on the whole process, then you have one eye and you can say, look, Mr. Client, or look, Mr. Contractor, you are not following like what was supposed to be in the design or what we agreed before, or to be here to discuss about the potential alternatives or solutions to keep the good aesthetic that we wanted at the beginning, but answering to the problems that are met on site or such.
We're mostly working in a hospitality project, so how we manage this? We mostly do very carefully with a professional supply example like BM Window. So they support a lot about how to build the mock-up. We're testing on the 3D model, and then we decided to do mock-up in the factory, and we go to check it, and then we decide to do the mock-up at the site. But we choose a minimum module to test this, and everything okay, we can go with the mass production. It's controlling about quality and quality finishing. That our method about it. Yeah.
I think we are all aware that in Asia, many times, like during construction stage, sometimes it's like feels like restarting the project because you have so many changes. So having like these engineers, architects, and consultants on board till the very end of the project is the only way to ensure that we can achieve like all these objectives, aesthetic and engineering beyond.
Yeah. That was kind of a trick question. I was thinking you guys say, find a facade consultant, it's his job, Anyway. So the next question is, what are some innovation technology design strategy that can enhance environment and energy performance of facade in a modern architecture? So this one's for our architecture panel.
I think we already discussed from
Yeah,
the
we
beginning
discussed
about
this.
this. I
Yeah,
think
we
so.
discussed this.
We already, you know.
How did you see the near future of the design, especially towards sustainable and generally performance of the facade?
For the energy demand for the facade, I think before, you know, architect and engineering like Boyden, you know, we always cooperate together about physics. We need to clearly precisely how many kilowatt per square meter, but about the energy, not about we want to know specific number. Even my team, sometimes we use different tool research to be sure of the same correct demand number. And based on this, we can do some scenario. We can give you some funny scenario later. We think that the energy come from equipment and from the people, that enough for the heating inside the building. And then how to fit with the sensor of the facade. Because sensor and the chip of the facade is automatically connect like harmony. So we do some funny scenario. Scenario one, laptop, MacBook combining with one Canon printing, and three of us maybe were 60 kilo, and how many heating we can produce. So we need to test time by time to get a perfect result for the specific number of the energy demand, and then we can go with the facade design because it related to chip design. This is also my experience about the energy design for the facade.
Yeah.
I come back on the holistic approach, where all the designers, the consultants, the engineers involved, for me, is one of the key parameters to have a successful, efficient, and optimized building. And also together, coming back to some very old ways of planning. You were mentioning before some very old buildings like the Opera House, etc. Many people like it. If you look at the architecture, we are in a very old style architecture, very thick walls, not so many views to outside, so we come to the aesthetic of the facade. But there are some very interesting principles in how the space is designed there. It's directly linked to the natural lighting, to the heating, and to the cooling. What are the proportion of a room, how many people you put in this room. So if you have an office with 50 people, maybe you want to go with a little bit higher ceiling. Then you can have a better feeling of you enjoy the cooling, I mean, in a better way, because your heat will stay on the high level. But then you are less efficient on the tower if you want to have higher buildings. But all these kind of parameters, for me, are one of the key in order to have a very efficient and sustainable, optimized building.
Yeah, I agree on that. It's really like the engineering approach, and we haven't talked much about it, but in fact, calculation, we have, as engineers, we have simulation tools that allows us, in fact, to predict in advance, and that's the reality and the benefit you can get working with consultants and engineers, because they can really predict what it's going to look like or how it's going to sound, and if you don't do it at early stage, then it's going to add much more cost and much more energy consumption at later stage, because you're going to have to add a solution treatment, and so this induces a lot of pollution and energy, I think.
I think the main question about the future of facades, I think, so on my engineer point of view and on the role of the viewer to the facade, I think that the facade becomes the more dynamic. It's not a fixed element. What I saw that the facade also change, and also on different scenes or different event or different holiday of the year, I think change the color, change the shape, change all the kind of interact with the environment, with the season. In the summer, could be the different color. In the autumn, could be different color. In the winter, so different color. I think that the thing for the future facade, I think could be stronger and stronger. And on another thing, I would like to add that if we have the biodiversity factor on the facade, when we see it can become the more green and more the nature facade, that could be interesting. Yeah.
Okay, I think that's all the question we have for the panel today. Do you have any other additional, information you want to share about the sustainable design for the facade, and any related to sustainable?
Yes, I think also one way we talk a little bit today is the double skin facade. think it's something we didn't explore much or enough in Vietnam, at least. And that can go together with either the passive solution or even the active or technological solutions about how the building is changing and how we approach a double skin buffer to make our facade one more interesting, keep a good aesthetic, but then improve the comfort and the energy consumption of our building. I think there is something to dig in there.
I would add also, we talked about it earlier, like the use of greeneries elements also and vegetation that can bring on the acoustic part also like positive sound and start to in fact mask like some element of noise pollution. So I think there is plenty of benefits also in this kind of approach.
I think from engineer point of view, if the facade also connect with BMS building management system, could be great. Yes.
In tropical climate, my experience in here, I think the facade in Vietnam region, I think first they need how to create a shading, how to protect from the rain season, how to create a nature ventilation. Yeah, this is some of my conclusion about my experience in here for some project in here.
Yes, true. Before you think about your facade and your performance, you think about facade. Yeah. Anyway, that concludes our discussion today. I think we can finish.
Thank you very much, everyone.
Thank you. Thank you for listening. Yeah.
Yes. Thank you. Thank you.
Good afternoon, ladies and gentlemen. Welcome back after lunch break. Now we go straight to the session 3 of the conference today. Let's give a warm welcome to Ms. Virginie De Paeuw from Design Lab.
Good afternoon, everyone. I'm Virginie De Paeuw from Design Lab, and today I'm going to talk about the facade experience. Before we go into the subjects of the day, I wanted to make a brief introduction about who we are and what we do, so you can have a better understanding of what this is about. So at Design Lab, we are hospitality design consultants. We do mostly hotels and resorts, but we do it from master planning to architecture up to interior design. We are quite lucky because we work a lot in Vietnam, but we also have the chance to work overseas, which brings us to meet new cultures, to get to work in different climates, and therefore work on different types of facades. Working with all these operators brings us some challenges. Each one has a different target in terms of guest experience. Each one has a different target of experience of the facade, how you enter the building, what is your connection to the indoor and outdoor. So all of them actually are helping us every day to learn more about this experience. When we start a project, we always have these 3 pillars. The first one is the sense of place. We believe that each project is a unique reaction to its location. So what we do is actually we take the site, we take our site, we don't only study our site and the few buildings around, we also study everything that's happening around or that has happened in the past. We study about the history, we study about the legends. If we go for interior design, we're also going to study about the arts and crafts, the local materials, the local techniques, and of course, the architecture. We want our guests to wake up and know where they are. We want them to wake up and know they are in Vietnam. We want them to have this glimpse of the Vietnamese architecture and arts in the hotel. Attention to detail, I think this is straightforward and understandable. Experience, here we talk about our experience as designers, but we also pay a lot of attention to the guest experience. We want the guests to have something different from what they have home. We want them to have, isn't that why you go on holiday? You want something, you want a break from your day-to-day life and discover something different. Of course, these are the 3 pillars, but the usual questions appear in the process of the design. We also talk about maximizing the comfort of the guests, being sustainable, durable and low on maintenance, have a sense of place, being inspired by local culture, integrate into the natural wonders, etc., etc. So we'll start first with the no facade architecture and how to design a facade to make it disappear. So this is one of our projects. This is one of our current projects, actually, where we are again quite lucky because this project has view to the sea, view to the cliff, view to the nature and this pristine area. So we want our guests to experience that as much as possible. We want to give them this experience. And that's why, in this case, you can see that we try to open the facade as much as possible. Of course, in order to do that, we have to bring in some extra elements to protect from the heat, from the direct sun, from the rain, and all other weather elements. So we bring some big roof eaves that are actually gonna bring some shades and protect in case of rain. We do the same on the lower level. We extend the terraces. We extend them outside. So once you open all these big windows that, of course, we design in order to tuck them away and completely disappear once they are open, you don't know where is the inside, where is the outside. You have this transition space, and actually the facade is disappearing. This is another example. This is another angle where you can see a closer view of the upper area, and you can appreciate this difference. There is no more facade anymore. As this is high-end luxury project, we need to keep the glasses and the windows because we need the guests to be able to enjoy also the views with the AC and in the comfort of a fresh rooms. But the next project, this one is the Four Seasons Ubud in Bali. This is not done by Design Lab, I don't take credit for that. But this project is actually pushing this to the next step. This building that you see here is the arrival reception and lobby lounge. The guests will arrive here at the top, and then they will cross this huge bridge. It looks like we are on the ground, but it's actually quite deep when you walk on the bridge. And you will arrive on top of the reception. So your arrival experience is quite different from what you have in other hotels. You arrive from the fifth facade, from the roof. And then you go down to the reception, which is located here. As you can see here, the guests are in direct contact with the nature. It's completely open. You have the palm tree just next to you. There is not even a balustrade because the architects placed a pond around so they can avoid having a balustrade. So you are completely open and connected to the surrounding. And this is possible because of these big roof eaves that are brought into this project. I don't know the dimension here, but it's really big. When you're there, you can see that it's quite big. And this allows this building to be open the whole year. There isn't even any protection for the rain. There isn't any system for when it's raining because these roof eaves are enough. Of course, all this works well because this is a reception building. It's not a guest room, so it's of course a bit different. But that's why it works well here. But on our side, we also have to think about the comfort of the guest and make sure we can have design and comfort. So this project here is a project that came with quite a few constraints. It's in Africa, in a remote area where it's quite difficult to build, to bring materials, to maintain it, and the client wanted to have as much openings as possible in order to see and appreciate the landscape around. But we are in Africa, so we need to protect from the sun. And at the end, with all these constraints, we decided to take this on our side and make this the signature of the project. So we took these constraints and we decided to create a big roof that would help us to simplify the facades and help us to then keep the facade very open as the client wanted and requested. So by having this big roof, we create, again, this transition space, and we managed to answer all the constraints that we had at the beginning. Another project that we had, this one is in Vietnam on a cliff, and the client wanted us to design a hotel on the cliff, but we couldn't see, he didn't want to see the hotel from the beach. He didn't want to have this big white building on the beach. He wanted this to be integrated with the surrounding. So we decided to follow his instruction, and we went around and checked what makes the cliff different. So we realized the depth of the building, creating depth on the building will help us to create a game of light and darkness. Integrating plants will obviously help us to integrate in this natural environment. Adding lattices, adding lattices here and there will also add one more layer. So with all these layers of greenery, depth, lattices. Sometimes we also added water feature. All this will help to create actually a facade that has some depth. And again, sometimes you don't know if you are inside or outside, but you can still keep the comfort of the guest at all time. We wanted to add this project because this is a very simple and small project, but we liked it because when doing this project, we had to reflect again on what are the Vietnamese ways of building and what was the traditional way of building and the traditional architecture. And it reminds us that actually everything we are applying nowadays with a modern twist or with a different interpretation is actually from the traditional architecture. These big roof eaves just come from the traditional architecture. When you look in Huynh and you have this outside space with the columns, and then you have the transition space, and then you have the pivot doors, and then you have the indoor. Once everything is open, it all feels like one space, and the transition is very difficult to know where you are, inside, outside, in the transition space. And this is what we continue applying today in all our architectural projects. This one is an example of a simple building applying these principles. But of course, what I'm showing you here are most of them resorts, places in warm climates, so all of this is very easy. You don't always need to have air conditioning, you can have the nice cross ventilation, it's enough. But I wanted to show you that this principle can be applied in different countries also. This is a project we did in Australia, and we are applying all the same principle that I just mentioned. I just mentioned you in the previous one on the cliff. You have the greenery, you have the different depth, you have the overhangs, you have the lattices. And what you can see on this view is that the facade actually in this case is quite complex and has lots of details. But at the same time, from the other side, from the guest point of view, when you are inside and using this building, it's very open. But at the same time, you have the comfort and the privacy thanks to the lattices and the depth of the building. Sense of place and building envelope. I was telling you at the beginning that for us it's quite important to wake up and know that you are in Vietnam or in other place, or in Laos or in Thailand. When we design, it's quite important for us. So how to integrate that in our design and how to work in the facades, keeping that in mind. So this project is a project where, well, I think everybody can see the sense of place here. It's quite obvious. But what we wanted to show you is that even if we keep a sense of place here, we have the colonnades all around, and this is a very modern touch. That was the whole concept of the project. We wanted to have contrast of simple contemporary architecture to contrast with Vietnamese architecture and design in order for the Vietnamese architecture and design to shine, actually. So that's why we have this kind of contrast here. But what we wanted to show is that the principles are the same, and they work perfectly in both ways. Again, the transition of the architecture indoor-outdoor, the sense of place. The architecture indoor-outdoor and the sense of place are all together here, although they are represented in very different ways. Again, translating this into contemporary architecture in a city. This is a project we did in a city in Vietnam. And talking with the client, he requested us to bring Vietnamese lifestyle into the tower. He wanted people that have houses to buy apartments. That was his problem at the moment. So we talked to the clients and to a few people of his team, and we realized that actually what people like in their house is the outdoor life. They like to have this little garden at the front of their house or at the back of their house or on top of the rooftop, but they miss that in the apartments, and that was one of the reasons why they didn't want to buy an apartment. So we decided to bring this lifestyle into our tower and bring the Vietnamese gardens and the Vietnamese outdoor space into a facade. So in this case, a facade became alive, actually. People will start coming into these areas and share life and connect and have again the garden back into their apartments. Just one last thing to conclude today. For us, the facade subject is always quite important. When we design our hotels, this is, in terms of architecture, the facade is the first thing that the guests are going to see when they arrive. And as I was telling you, sense of place is very important for us. So we want the guests to be surprised, to be charmed, and to be curious about the facade once they arrive. Thank you very much.
Thank you very much, Ms. Virginie, for the couple of minutes on there. And your team has done many beautiful and functional projects in Vietnam, we can see. And now we will turn to the next speaker in this session. Please welcome on stage Mr. Ahmed Ali Sumair from Sahvia company.
So thanks for Ahmed and Zak team to giving us the opportunity talking on this platform in a second edition. So I was the previously share a couple of experience what we are doing in Vietnam, in Hanoi as well. So today I would like to share about why lighting design needs storytelling. The previous presentation, I want to pick up some line from Ms. Paeuw, sense of place, experience. And the project she has presented, it's related to the modern architecture and also a traditional Vietnamese architecture. The beauty of Vietnam is we can see 1,000-year-old temples and the modern skyscrapers sharing boundaries. Similarly, the resorts with the semi-arches and the old Vietnamese feng shui concept we can see in Vietnam. So why need a storytelling? From day one is integrated into a human civilization. The human started sharing and transferring the information, tradition, and the way of life through cave paintings, through wall paintings, through sculptures, which is a basic understanding where we try to understand our past, ancestor experience, and culture. So let's take a step back in a time, how storytelling gradually adopted by human, like a cave paintings, sculptures form, then it converted into a media, it converted into like in photography form, then the nowadays a social media like Facebook, Instagram, where people always try to share their emotions, keeping a status on the WhatsApp and Instagram and Facebook. And just now, Ahmed also did, after the presentation of Mr. Timothy, the Dr. Timothy, the example he has shared between human anatomy to the building structure, how building works and what are the similarity between these two things. So he posted Dr. Timothy, and my friends texted me and asking that what is the interesting thing he has presented and all. So that's how the stories is spread in an electric form. So I am sure everyone who are here, they always have their past, present, in a future also, bonded with the stories with grandparents, with having a hot pot dinners in Vietnam especially, sharing information between the friends, sharing the past and the current activities with them, and celebrating the victories of local Vietnam and celebrating the events, national days, and we always try to say some stories through. So storytelling we can explain orally, we can share with poetry. The authors, even architects also is a big author who always says some stories with the architecture. Now, how in a global platform, especially in a Burj Khalifa, you can see that Burj Khalifa celebrate all the events and greets, world records, Happy New Year, birthday. So these kind of stories also we can say through the facade and facade lighting. And Vietnam, the beauty, as I mentioned, like Ms. Paeuw, modern architecture with the Vietnamese architecture. So it's a combination of a different era. You can feel and you can experience the sense here. Lighting to enhance the architectural features in the night, lighting, artificial lighting is a require, where you can see the more enhancement and more, like especially projections, especially like a decorative elements on a facade, which can have a more enhancement during the night with the artificial lighting. So these are some examples, like in a daytime and nighttime, how we can have a different experience with the architecture. So today, I would like to discuss a couple of projects we are working in Vietnam. So first one is a Vinhomes Grand Park, King Crown Infinity, Hontre, Dream City. So Vinhomes is a luxury apartments. So we started sketching on a building lines. We started identifying the architectural elements, the horizontal and vertical crown band and vertical louvers on a facade. And then we thought like storytelling or inspiration we took from plumeria flower. The plumeria flower is a symbol of new beginning. The users who's going to accommodate the property, who's going to start the new journey with the new apartment. So we want to have a sense of new beginning to the end users. So we started sketching on a key elements of facade, and the residential, the majority and the main key factor without disturbing the end user, how we can illuminate and how we can enhance the architectural features. So these are some realizations, like some renders we did. So the color palette we adopted from the plumeria flower, the golden and white and pink shade. Then different time, the intensity of light increase and decrease in a tunable form. Like a crown, so in the late night, the crown going to be lit only, the rest part going to be off. And on a weekends, we are going to have a different drama and in a dynamic form. So these are some fixtures we selected, concealed in flooring, and couple of on a crown area with the louvers and solid aluminum sheet. This is an entrance experience, a simple, subtle lighting with the performance, and the horizontal band cladded with the frosted glass. We are grazing with the concealed LED runner. And these are some fixing details, how we have integrated into architectural sections and closely work with the facade sections. So these are the options we have worked for a different time and different days. And also working on a different wattage options, like option 1, option 2, option 3. What is the consumption, electricity consumption going to be happen if we are choosing any option, which is the most important for our annual maintenance and also budget. That is the main topic. So King Crown Infinity, it's a mixed-use development, service apartment and shopping center. The project features are completely very greenery, have a big atrium with a good landscape. The balconies have a planter boxes and some creepers and all. And we started taking inspiration from the local plants and local flowers. And color palette also we have chosen from the same pattern. And these are the inspiration before sketching some ideas. on a facade. So the first concept was here, a flower blooming pattern, how it will start gradually bloom. We started applying lighting intensity in a same manner. So these are basic sketches. The brief what we got from the client, they want something differently. They want to celebrate all the festivals. They want to celebrate and they want to be unique in the market, having with the dynamic and advanced technology of lighting. So we started making a waterfall, like a building assumption, like a mountain, and having a waterfall there, and the podium, MLCP area, and the shopping center integrated with the multi-dimensional GRC and fiber optics integrated into GRC panels, and the glass facade integrated with a sleek, transparent media mesh. And on a special occasion, there were some drone shows. So these are some couple of renders. So the shade, the color palette, you can see, we adopted from the flowers, and intensity of shade and color is completely in a low form, and once it go in a darker, then it start increasing their intensity with the automation. So different areas we highlighted based on the access to the building. And couple of common areas like amenity floor and clubhouse area, where we introduce couple of laser lights to attract the surrounding crowd, and the waterfall from the facade, which is integrated and interactive. We propose some kiosk where the end user can block their schedule, they can play their own design, they can choose the design. So multiple design and patterns programmed. And couple of with the futuristic design apart from the nature. And so these are a couple of details how to integrate with the facade system. So it's a window wall system, and we have an additional clipping profile from inside with a transparent film. And these are some references, examples, how it's going to look after execution. And so this is a 1.52 thin, like a PVB or SGP kind of layer, integrated with a chip technology. On the podium, we have integrated fiber optics in a GRC. So it's a prefab panel integrated with all the drivers, and the drivers is going to be placed on a common areas to replace or any maintenance purpose. Hantre is we did one project with the Wind Group. So it's a tourism project for a maritime. The key features are 4 vertical walls where we do have a dummy facade, and we are highlighting with a very subtle lighting on this 4 vertical one, and we do have a 4 crystal domes also. And the atmosphere for a facade, we took inspiration from ocean. Then we started sketching some ideas on a paper, and for a crystal domes, we took again atmosphere, a subtle intervention on a crown area, because those areas are for waiting to catch the ferry. So sea animals like jellyfish and all, so those colors we adopted. And the inspiration for weekends, such as to do a dynamic kind of effects, like a Greek god myth of Poseidon, who is a lightning god, and we want to have some sort of like a very sharp and a sound effect on the 4 crystal domes. So these are the inspiration we took, and these are preliminary sketches we started to highlighting the crown area, the horizontal bands, then 4 domes, and the view from waterfront. So here you can see very subtle lighting on every third level for a horizontal bands, and the crown area with a very warm light, and it's a RGBW with the drivers. Then the crystal domes with the lightning effect, some with the projector lightings. So these are some, so after completion, this is how we realize it. This is one more view from front side. These are fixture details we have placed, integrated with the facade system, and the power supply, the other arrangement accordingly we did during the execution only. During the shop drawing process, we did all the provisions to have a proper arrangement for fixtures. Dream City is again with the Huynh group we did. This is more into urban and landscape experience. Here, it's not related to completely a facade, so we do have a couple of statues and couple of structures and small shopping kiosk. But why we would like to share here the inspiration we took and the way it has been executed. It's come up very well, and earlier we were discussing with the client, and it's like it's going to be execute or not. Inspiration, storyline is always good on the paper, but when it goes to the execution, it's very difficult to achieve that. Stories are very easy to say and listen, but what is the reality? So we started with the sketching and we completed this project. So there are like 8 axes to the project, and client wants, and we want to give end user to a different and dream experience for every access point. Not only the entrance, who are entering from the other points also, we want to have a different experience. And the inspiration we took from Paris Promenade, because it's a long street with fountains, grand central statues and all. And we started picking some ideas from small alleys, French alleys, and the lighting illumination ideas also we took from there. And when you come to the central part, where is the wow sort of experience or we took for a grand central park. So these are some inspiration we took, and this is our concept. So that one is a grand central area, and from both sides we are having completely a color animation lines. And in the surrounding also is luscious with the trees, greenery, and artificial lamps as well. Then a festive environment, a festive feel for all access points to the central promenade. The main entry from this area, so we install floor concealed lamps to have a starry effect, to start end user to realize and involve in a dream world. The project is a dream city. So we started making a story, and we started making an integration of light and surrounding in such a way a person he start realizing and thinking in that form. So some artificial lights, lamps, we integrated like surmounted banners also for welcoming the end users. So inspiration, we divided these 4 key areas, like one fountain, then garden, then main grand fountain and garden, and then we do have a ocean area. So we started light. Always, I would say light is alive. Without light is completely like a dark. If you want to realize anything, if you want to sense and have an experience, then you should have something to see it. So that is the light. So when light comes, the love comes, the people unite, people mix, people talk, people gel, people share ideas. When they share, then they will reach to some point. Either it's a victory, you can take in any form victory, and they will start diving in the ocean of dream. So this is how we started, and we started placing calling the areas like Ocean area, Victory area, and similarly, the lighting effects, the integration, and thoughts we try to implement on a landscape. So the Ocean area, where you can see a completely like a projector mapping, you can see multiple stars, fishes in a dynamic form, and suspended lamp, decoration lamp, projector lamps, then main lighting artworks in a main promenade area, then Love area where we do have a couple of small sculptures and benches to sit and enjoy. Then the chapter 4, we started demarcating the locations, which area belongs to which element and what type of elements we are going to apply there. So this is after installation. The pictures are not very high resolution. We clicked from mobile. So here you can see the main promenade. We started leading with a very subtle sort of lighting. And we do have a laser shows in a central promenade area. And these areas with a dynamic projection mapping where, and it's an interactive also where kids and families can enjoy and trying to catch fishes and enjoy with the flowers and all. So this is the concept design. Now I would like to share a couple of two projects, how the facade lighting design and facade consultant involvement, and MEP consultant involvement is required to execute these dreams. Which are the key factors we have to take care during the concept design stage. So this is one project we did where we closely work with the facade engineers and ourselves to integrate the fixtures inside the panel. The belly curve, what you see in both sides, so this side area is a spandrel panel integrated with a pixel.RGB mesh, that one. And the power supply, every 15 meter we have to maintain to avoid the voltage droppage and to achieve the exact intent. So these are the fixing details. One more is a SAS iTower. We are working with ADAS. It's a 5.6 million build-up area, G plus 40 story, 3 towers and all. So the main east facade we are having with the complete dynamic lighting, and we have integrated into a vertical fins. The fin sizes are 150 by 600 mm, and we do have a sunshades of 450 mm. And integration into a vertical fin and passing a power supply cable inside the building to supply the power. It's a big task where we are going to puncture the facade system, and the same time you have to conceal those areas to avoid any leakages. So this is as we have done during the shop drawing stage, during the concept stage. We have worked closely with the architectural team, then facade contractor. And these are some fixing details. And now the final statement. See, the design and execution, it has to go together. It has to work very closely. And the consultant appointment, especially for a facade, MEP, and the lighting has to be from a day one to have a proper design execution and proper arrangement. And any modification required in a facade elements also we can do on time. So thank you. Thanks, everyone.
Thank you very much, Mr. Ahmed, for the very exciting insight about facade lighting. And the next speaker today now is Mr. Chengde Huang from CHE. Please give a round of applause to him.
Good afternoon, everybody. I'm Chengde Huang from China Southern Glass. Today I'll talk about the application of high-performance glass to reduce carbon emission. 3 parts. You know, in China, we said to carbon goals, the peak carbon dioxide emission 2030 and the carbon neutrality 2060 in China. According to statistical data, as the year of 2019 in China, the whole cycle carbon emission of buildings accounts for over 50%. Production of building materials accounts for 28%. In the building construction accounts for about 1%. The building operation accounts for about 22%. So the lowering the carbon emission of buildings is extremely important to China to achieve the two carbon goals. So in China, we have already implemented a new code, the building code, called GB 55015 in 2021, called a General Code for Energy Efficiency and Renewable Energy Application in Buildings. In the new codes, besides the recently, energy efficiency code of buildings, also, the stipulated specific requirements on carbon emission. And in 2019, China implemented a national standard for the carbon emission calculation called the Standard for Building Carbon Emission Calculation in 2019. The detailed calculation procedures specified and the necessary basic data is listed in the standard. Obviously, different high-performance low glass products are needed for different climate zones for the most effective reduction of carbon emission of buildings. Because like in Beijing, in northern China, it's hot in the summer. Nowadays in Beijing, in the summer days, get the temperature over 40 degrees, like 42 or 43 in the summer. But in the winter, it could be down to minus 10 or even lower. So in the summer, you need the high-performance glass to prevent the solar heat from coming inside. And in the winter, you need the low U values to prevent this, the warm. The heat from inside to outside. So in the summer, you need a high-performance glass, to like a 777 low E, to prevent the solar heat from coming inside, to lower the energy consumption in air conditioners. And then in the winter, you need the U values to reduce the heat transfer. But in the southern China, in the summer it's hot, but in the winter it's warm. So in the southern China, like Shenzhen, Hong Kong, etc., only 777 glass is good enough. So now in China, CSG are promoting, high-performance glass from north to south in whole China to reduce the reduce the carbon emission of buildings. Here I just list the three sample scale, three glass products. Those used in northern China, like in Beijing or Tianjin. You could see it's two coatings. On the second surface, we use a 777 low E to prevent the solar heat from inside in summertime. And on the interior surface, we applied a lot of coating called BW88 to reduce the U values. So this kind of glass is good enough in the northern China to lower the carbon emission of buildings. When we do projects, we also specify glass by G values or SHGC, but actually it's not precise enough. We define a new term called GIR. You can see the red figures there. Because in the sunlight, it contains 3 parts of energy, about 2% ultraviolet, about 47% visible, about 51% of solar IR. It's the solar IR caused the temperature increase. So the GIR just accounts for the solar IR, how many percentage of the solar IR is coming inside. That's the energy course temperature increase. Like we park a car outside in the summer days, even cloud days. In the car, it could be extremely high temperature because the solar air comes inside the car. The solar air is a short wave energy. After it comes into the car, it becomes a non-wave. The non-wave cannot pass glass, so in the car it's built heat, called heat accumulation. So to save energy, to reduce carbon emission in operation stage, you have to prevent the solar air from coming inside. But when we specify glass by G or SAG values, it's always misleading because G including visible light, but the visible light is what energy we need for the daylight. Like here in the table 3 glass, you can see the GR, all GR is about 3%. So it means any kind of glass of the 3, any amount of 3 you use during the summertime, in the air conditioners cost, energy consumption is almost the same. But the visible light is different. The G values is different. So when you feel we only select glass by G values, you cannot find the best for your projects. Depending on the visible light, how much visible light you need. In this table, we just these 3 triple separate glass for the, like southern China, like Shenzhen or Hong Kong. The only triple separate glass is best. It's good enough to reduce the energy consumption during operation stages. Because in the winter, like in southern China, it's not cold. You can see the GR values, or about 3%. That means only about 3% of the solar air comes inside. It's good enough. The performance is based on the low air glass. In the outer glass is no air glass. If you use like a clear or even use a tinted glass, when do projects, because they just sell, supply glass to projects all over the world. In some of the areas, they prefer tinted glass for outer glass. If you use tinted glass, the G values could be lowered. But actually, GR will be increased because the tinted glass absorbs heat and then comes inside, transfer inside by secondary transfer. So that means if you use tinted glass, the performance is going to worse, not going to better. The G value is lowered. It looks like it's better, but actually the GR will be increased because the tinted glass absorbs the heat and then comes inside by secondary transfer. We calculated in the carbon emission of triple several, double several, and the clear IGU, roughly for different the climate rooms. This is the data we get. If you use double several low E, every square meters of glass, you could reduce the carbon emission by 25 to 35 kilos compared to the clear glass IGU. If we use triple several low E, could reduce by 30 to 40. That means about 5 kilos more than double several low E. So triple several is the best to lower the carbon emission of buildings. And it's just some samples, the pictures of products against the plant trees. You can see the transmission colors is very neutral. The colors sure it's very good. And for the spandrel, we can make a perfect batch because we can use the frit on the number 3 surface and the low E coating on the second surface, the same for the vision and spandrel. So the vision spandrel could achieve a perfect batch. And also we can use the BIPV glass for spandrel or for skylight, and then we can adjust the VRT by laser etching the error to achieve a different VRT, transmission. And this is just a few examples we have done before with BIPV glass. And then because it's a very short time, then I just show you some of the projects we have done in China. This one is 2 coatings, the triple severity on the second surface and the BW88 on the inner surface for north in the colder regions. This is the project in Beijing. This is another one. So we have different colors, different bright, different examples. Next. You can see the spandrel and the Virginie perfect match. The colors are achieved by coating, not the glass. The clear glass with coating is should green, because the customer, they like a green color. But from inside out, it's clear, the colors. Okay. This is a blue, light blue color. The neutral, this gray. Another one, silver gray. And then we have to, jumbo size glass. Here just show our projects we've done before. The width could be about 3 meters and the height over 10 meters, like 12 meters. Actually, we can do over, like 15 meters long. We can do that, depending on some partner glass, height. Here just show examples. The jumbo size glass. This one is in Wuhan. This one in Abu Dhabi, I think, in the UAE. You can see the images. It's very good. It's a high reflectivity glass, blue-gray. So because of a very short time, just show some of this. This is all I'm told to this. Thank you.
Thank you very much, Mr. Chengde, for your knowledgeable presentation about high-performance glass. And please welcome the next speaker today, Mr. Rong Hu from Kurare. Please give a round of applause to him.
All right, my name is Ron Hull. I'm the Global Director for High Performance Products for Kurare. I'm based in the United States, in Florida. So my climate is very similar to here, so I kind of feel like home. I'm going to be talking about 2 products today. So I wanted to pass out some samples, so if you can just pass them to, I guess, to the right and then left, and maybe they'll make it all the way back. But one is called Century Glass, and the other one is called Peeraphol PVB. I'll start here. All right, my agenda for today is first introduction, and then talk about structural and acoustical glass, then talk about security and ballistics glass, and then talk about the Kurare sustainability goals. So with Kurare, we have the world's largest portfolio of laminated glass, and we sell into different applications and markets. So these are all of our markets, but today I'm just going to talk about structural security and sustainability and acoustic. So glass is a fantastic material, as you can see from these 3 buildings. Some of these you may recognize. However, sometimes it breaks. So there's 3 basic types of glass. First is anneal glass. It's also called float glass because it's made on a float glass line. When it breaks into some dangerous shards or sharp splinters. But if you take anneal glass and you temper it, you can have the glass 4 times stronger. So tempered glass, because it's stronger, it breaks into smaller pieces. So it's much safer when it breaks than anneal glass. And the laminated glass, which is the safest of all, when the glass breaks, the glass sticks to the inner layer versus flying around in a car or falling off a building. So what is laminated glass? It's pretty simple. It's either 2 or more pieces of glass with a film or an inner layer in the center. And the 2 most popular films are polyvinylbutyrol, or PVB, and then ionoplast, also known as Century Glass or Century Glass Extra. So what makes Century Glass so special? And so the samples that are going around, the stiff inner layer is Century Glass. So that's what I'm referring to. So it's 100 times stiffer than PVB. It's 5 times more tear resistant. It's ultra clear, very transparent. So if you're doing a low iron glass project, you want to go with the Century Glass. It's very durable. So if edges of the glass are exposed to the environment, we highly recommend using Century Glass because we now have 25 years of weathering data in Florida where the edges still look good. Impact resistance. Century Glass was really invented for the hurricane market, so it's really good for impact and also security. Sometimes the inner layer touches the sealant, so Century Glass is compatible with most commercial sealants. Post-breakage, when the glass breaks, since Century Glass is stiff, it stays in place. And then also if you're a structural engineer, because Century Glass is a structural inner layer, you can really create thinner, lighter glass makeups than with the PVBs. So recently, our company put out a press release because there was a lot of confusion about, what is SGP, what is Century Glass. So Century Glass Plus was invented about 25 years ago for the hurricane market, and people started calling it SGP. But then DuPont invented Century Glass. Now Carrari, we're the ones that are making it and selling it. The Plus was dropped about 12 years ago. So for the last 12 years, Century Glass Plus has been known as Century Glass or SG. So unfortunately, there's some competitors who are out there making a product they're calling it SGP. So SGP really doesn't exist anymore. It's SG. So if there's any confusion, if you're specifying a project, we really recommend that you specify Century Glass Ionoplast by Carrari. That way you'll know you'll get the real product instead of a knockoff. So if you have any other questions, please stop by at our booth. So when Century Glass was invented, some structural engineers started learning they could do a lot of cool glass structures that they could never do before. So this is one of the first in New York City. You may recognize it. The store is actually underground, and so you walk into this nice glass structure. And then one of the first structural glass railings where it's only supported by the shoe or the base, and there's 3 sides that are exposed to the environment. This was in the top of the rock in New York City. So I was up there last summer, and this glass still looks great. So you need no top rail. So the edges weather well. And if this glass did break, it would stay stiff, right? It would stay stiff until you replace the glass. Okay, next, there's probably close to 1,000 skywalks now. If you are afraid of heights, skywalks are no fun, but if you like thrills, you can now walk on glass and be thousands of meters above the ground. But this was one of the first ones. This was the Grand Canyon Skywalk, and it had a glass railing, and the glass floor was all Century Glass. So if you ever go to Las Vegas in the United States, this is like a 1-hour drive from Las Vegas. Okay, another structural engineer decided to do something cool. Let's have fun with structural glass. So someone had the idea, let's take the tallest building in Los Angeles, remove a piece of glass from the top, and let's put a glass slide, all right? So I've done this. The first time you're doing it, it's no fun because you think you're going to die. But this is what it looks like. And what's interesting is just this year, a bigger slide like this opened up in Dubai. So if you're ever in Dubai, there's now, if you want to do a crazy glass slide, you can do it in Dubai as well. Okay, then there's glass bridges. I would guess there's at least 100 of these now. This one is in China. This one makes it a little more scary because it's a suspension bridge. It moves when there's wind. But so you can see the whole glass floor is made with our Century Glass. And so when the project was done, there was an extra piece of glass. So they decided to break the extra piece of glass on top of the bridge, just to show you how strong the glass is. So hopefully if you ever go on this bridge, you'll feel safe if the glass does break. And then not too far from here, over in Bangkok, this is another skywalk. I'd highly recommend, if you're in Bangkok, to try this out. But once again, if you're afraid of heights, I'm not crazy about heights. This may not be fun. And then this is an observation deck in New York City. It just opened up. So this gives you the best views of New York City out of any place. Okay, next is acoustics. So glass does prevent some noise coming through it, but the way you measure acoustics is either sound transmission class or STC or outside-inside transmission class or OITC. And then in Europe, they use what's called RW. But we've done thousands of tests with our inner layers, and this chart kind of summarizes all of our acoustic data. So if you have a 10 millimeter piece of glass and do a test on it, the STC is going to be at 33. If you cut that piece of glass in half and put our normal troceable PVB in the center, the STC goes from 33 to 35. If you cut the same piece of glass in half and put it in our acoustical sound control inner layer, the STC goes to 38. So just by adding an acoustical inner layer, you can really improve the acoustics coming into the building. And that's really important if you're next to a noisy highway or a train or an airport. Okay, next is security and bullet resistance glass. Unfortunately, there's a lot of terrorist attacks in the world. This chart, where it's red, shows some of the attacks since 2000. In my country, the United States, a couple years ago, there was a lot of people damaging storefronts in major cities. So our products are used in all of these applications, but I'm just going to cover these three really quick. So first is force entry. So force entry glass is either trying to keep a bad person from entering the building, or they're trying to keep a person that's in the building from coming out. Bullet-resistant glass, the glass will actually stop the bullet and keep the person safe inside the building. And the bomb blast is another topic. I don't have time to talk about that today, but our products are also used in bomb blast. So for security standards, there are standards in both glass and the window frame systems. So these are the most common standards that I'm aware of. And then for the standards, there's numerous standards, but normally the standards include a series of tools where you'll hit the glass a certain amount of time, and then if the glass is still good, you find a new tool, and then you do that until the glass fails. So this is a series of tests called ASTM 1233. But this is an actual crime occurring in a city. So one person has probably a sledgehammer trying to break in. And then his friends are going to come and try to kick in the glass. It's funny, so what you want is the glass and the frame to keep people from entering the building. So a popular test that's the last couple years in the United States is you actually shoot the glass 5 times with a bullet, AK-47, and then you try to break through the glass. So the bullet goes through the glass, but it makes the glass weaker. So on the left is PVB, 60 mil PVB, and on the right is a Century Glass product. So you see the brick went right through the PVB. So the PVB failed. So this test lasts 15 minutes. They may be like 2 minutes into it. So there's not time to show the whole thing, but if you want to see a sample of this glass, we have it in our booth that you can pick up and touch and feel. Okay, ballistics or bullet-resistant glass is the glass is actually, it stops the bullet from coming into the building. So normally there's many different standards. This is the EN standard. You start with a small bullet going slow, and The toughest standard is a big bullet going fast. So in this case, there's 7 levels. These are the levels in the United States. So this is a typical bullet-resistant glass, what it looked like. It's numerous pieces of glass interlayer, and normally some sort of spa on the outside. But what we found with our interlayers, with the Century Glass and we have a product called Spall Shield CPET, you can actually get thinner, lighter makeups for the same performance. I wanted to show you an actual bullet hitting the glass. So this was the BR6 test. So one angle is a bullet hitting the glass, and then the next angle is on the other side of the glass showing how the glass deflects. So see, so the glass does break, but our Spall Shield product prevents any glass flying into the building and causing harm. All right, so next, sustainability. I think every company now has sustainability goals. Our climate is getting warmer because higher CO2 and methane in the atmosphere. I think everyone knows that. This chart here just shows who are the main emitters of CO2, no surprise. So our company has a baseline of 2019, and we want to reduce our CO2 emissions by 30% in 2030, and then we want to be net zero carbon emissions by 2050. And so far, we're on a good path to easily meet the 2030 goal. So when you're making materials, there's 2 things you need. One is a life cycle analysis, another one is EPD. So for all of our products, we now have these on our website right here. But what we found was, out of all the testing, our PVB, which is really world class in terms of CO2, how low it is, has 4.45 kilograms of CO2 per kilogram of PVB. The Century Glass has about 12% less CO2 per kilogram. And then we do have a product where we bring back material from our customers and recycle it and then resell it. That actually has incredibly low CO2 per kilogram. So I'll skip through this one. So the last thing I want to mention is, so right now we bring back materials that have never been laminated and reuse them. So our goal is to, when a window breaks, whether it's a windshield on a car or something breaks as you're installing it, we like to remove all the glass from our PVB or Century Glass and reuse it. So at the moment, there's still too much glass sticking to the interlayer, but we're getting close. We really think someday soon we're going to be able to reuse the film, the interlayer that was used in a building to be 100% circular economy. So that's all I had. So if you have any questions, please stop by our booth.
Thank you. Sustainability and reduced carbon materials is truly priority concept of us nowadays. And thank you very much, Mr. Ron, for your presentation. Please come to the next speaker today, Mr. Pink from Dow Asia Pacific. Please give a round of applause to him.
Hello. Hi, everyone. Good afternoon again. My name is Ping. Today will be a representative from Dow. Okay. So the information and the topic that I will cover today is about the solution that our Dows provide to the customer. One is the solution that enabling high-performance facade designs. And also the solution that we will provide to the customer is for the sustainable facade designs. So it actually has been almost 70 years from 1960 that we has been invented, and Dow as a leader for the industry line, product line of the silicone sealants, it has been 70 years that we have the technology of the silicone sealant used for the building facade. So we are very proud to say that as of now, 20% of the tallest building in the world, 70% of them, which is 14 buildings of those buildings, using our solutions. Okay? And that is also to be said that it's been proven that our product proven performances, and also we have completed the durability test on our structural glazing sealant for 50 years. That is also another laboratory theoretically proven performance as well. In fact, Dow is not just only providing a solution on the silicone sealant for the facade. We also providing other solutions covering throughout the building envelope, such as not just only the waterproofing, we also have a waterproofing coating and other products, also including the photovoltaic assembly or application module as well. So, and that is actually 70 years ago. And as of now, we as a leaders, we are looking for something more than that, okay? Today, I like to have like 10 minutes to talk about how are we going to commit ourselves and how are we going to contribute to the next level to our industry. The carbon neutral topic has been booming and talking around the world, okay? But in order for us to achieve that, is contribute from everyone here. Developers, consultants, contractors, and also the product suppliers. Dow, as the integrated solution provider, we wanted to share the information that how we serious, we focus, and how we commit to take full action, become a carbon neutrals first in our line. So I believe I can say that everybody here in this room, we are in the same industry, which is a built environment or building environment industry. We are the key players. We are actually a key pusher in order to make this carbon neutral happen. Because if you compare the carbon carbon footprint compared to other industry, right? We are the one which is having the most carbon neutral embodied the most, which is 39%. So that's a big number, very big number compared to the rest of other industry, 39%. So this 39% is actually divided into two groups. One is 28% come from the energy that we consume during the building of use, like air conditions, electric, everything. And in fact, I would say that we are doing quite okay because based on the regulation that we have, we try so much to save the energy during the day, so we are quite doing okay with it. But today, I like to spend time a little bit to talk about that 11%. That 11% is actually not a small number, it's 11%. So that 11% is actually come from during the construction. So it comes from the transportation, come from oil, come from everything, and especially come from the product that you select for your project, including, as you know, every product have the carbon emission, right? Okay, let's take a look on that. Dow, we are, as mentioned, that we have launched first ever. We are the first one in the line who certify for the latest standard, which is PAS 2060. So now we can, we are be able to pass and be able to provide the carbon neutral PAS 2060 certificate to the customer based on the project basis. So if you have a project which requires certificate for PAS 2060, we can provide that in order for you to have more green building credit, right? And also, we also, this is the one that we are proud to say, So the certificate is actually divided into 3 applications as in like our DAO product offer. So there are structural glazing, insulating glass, and the weather seals applications. Okay, so these are the services that we can provide to the customers, and still including the EPD, and definitely our product are the low VOC as well. We can provide all these requirements and certificate to the customer. So let's talk a little bit about carbon embody. So what I have here is actually an example of our silicone sealants. Let's say by the calculation, in order to produce 1 kg of carbon silicone sealant right here, 1 kg is actually take 7 to 10 kilo of carbon in order to produce only 1, right? So, and the way that our company is dealing and try to certify for the PAS 2060 is actually we do two steps. One, we use the renewable energies, and such as like hydropowers, and also we use the audited and certified, like for example, wood chip or cord. And also we have passed PAS 2060 by using our own carbon sink. We have our own plantations. So these are the steps that we are acting now, and we committing, and we passed the 2060 PAS. Okay. So as I mentioned, that the 3 applications that we provide to the customer, right? Structural, insulating, and weather seals. These 3 applications, if you have 1 square meter of curtain wall or unit type, it actually take 20 kg of the carbon in order to produce 1 kg, I would say 1 silicone sealant for 1 square meter. So 20 kg, right? So let's say if you have a project of about 30,000 square meter, it would take about 600 tons of the carbon in order to produce the silicone for 30,000 square meter of the building. That's so much. Okay, 20 kg. So another comparison that I would like to present today is that as you know that there are usually our curtain wall, there's 2 systems. One is captive system, another one is using the silicone for the structural glazing. By comparison, in terms of, as you know that the structural glazing, right, is using silicone, it's safe, it has been proven in terms of performance. And one good thing is that if you compare in terms of the carbon emissions, the captive facade, which is used more aluminum, it will use aluminum more about 15%. And one extrusion of the aluminum, 1 kg, it will take about 15 to 17 kg of aluminum in order to produce only 1, right? Okay, so if you have a project of, again, 30,000 square meter, you will have to use more carbon emission in order to produce aluminum more than about 1,000 tons of carbon emissions. So please allow me to take, because we have short of time, please allow me to provide a recap again. So we are the first in line as a global offer. We can provide the certificate to the customer based on the project basis. We have passed the standard PAS 2060, and also we are providing this certificate for you to have more green building credit. In terms of the performances, we compare between the captive facade system and the structural glazing system. We're using less carbon emissions. If you have more information, we actually have a website that put all the information right here. Or if you have any question, please come and visit us at the booth at the back. All right. So, and I would take about another 2 minutes left to talk about one of the solutions that we wanted to cover is actually the solution that we were enabling for the high performance design freedom. So we always understand that the architectural design trend is one of that is having something transparency, right? And with that, we also have to offer in terms of the structural requirement to that as well. And of course, in terms of the product durability as well. And one of the application is about the glass railing or glass balustrade here. The product that I would like to introduce today is called Dowsill 375. This 375 is for the glass balustrade installation. So basically, if you have the U channels, you fill it up with this 375. This 375 is actually alternative material to replace the cement grout. So, and after that, you seal it with the silicone right there, and then you can have it as a system here. Okay. So with the improvement and better in terms of the security and the structural behavior, the 375 will be providing a much better solution. So I don't know if we have time to play a video here. I don't think we have, but we have more information at the booth if you're interested. Okay, it's a short video about application. It takes about 3 minutes. I don't think we have time. So let me recap very quick. Sorry, I don't think we have time here. So this Dowsill 375 has passed the impact test according to the German standard DIN 18008-4, category B, where we have the top rail on the top here. So we have tested two sides of the glass, about 1 meter height and 1.4 meter height. And we have actually quite a number of case reference, real project. Like for example here, the project that have glass almost like 13 meters high in Romania. Okay, so it's the whole glass cube embedded all around at the bottom using the Dowsill 375. And also a lot of condominium and residentials in Taiwan using these materials rather than the cement grout. And also one of the biggest, one of the tallest glass, Beijing rivalry. This glass is about 16 meters, if I'm not mistaken. We also providing the new application where you can see on the right-hand side there, using this 375 as a strengthen for the glass IGU at the bottom there. Okay. I think I have covered everything on time. Okay, thank you very much again.
Thank you very much, Mr. Pinto, for the informative presentation. And let me introduce to everyone Mr. Lee Olivier from King Long. Let's give a big round of applause to him.
All right, good afternoon, everyone. It's nice to see you in Ho Chi Minh. As the last speaker, first of all, I'd like to give our appreciation to Zak community, and also to give our appreciation to our clients for their constant support. Maybe some of us are familiar with King Long for our door and window hardware, especially in Vietnam market. Actually, we start our business from structured glass. In the last 2 decades, we participated in some projects. And here I'd like to share some of our projects together with our service and the products. Facade, in some degree, facade presents the architectural design. And it can express something and ideas for the building and the city. So we are not just thinking about the function, performance. Sometimes we also need to consider the sustainability and the aesthetics. So new material and ingenious design can make your building, your facade be different. And this is my first part, varied facade. When we talk about a facade, it always comes up to glass, aluminum, metal panel. Actually, the facade can be different. It can be more attractive and colorful. So the first project, this is a cable facade. Normally, the cable facade is suitable for the pouring area because the pouring area has strong main structure to withstand the cable's reaction force. And the pouring area needs the big span facade. So cable is a good solution for it. But this project is a little different. A cable-laid facade is fixed on top of this building. And the main structure is designed to withstand a 100 millimeters diameter cable. As we know, this is the biggest stainless steel cable for facade. The second project is a cable facade as well. This is the Mumbai airport. This is a very old project. The architects just use a single cable to withstand the whole facade. It seems that we can hardly find the support structure on the backside of the glass panel. It makes the facade be so transparent and it looks so clear and simple. Sometimes cable can be used for decorative facade. And this is a project the architects use thousands of small cable, 8 millimeters diameter cable, to simulate the rain because this city is a rainy city. But the challenge is how to keep the tension force to be stable and as small as possible. So we designed a spring device for each 3 cable to keep the cable pretension force stabilized at 5 kilonewton. This kind of design makes the installation and maintenance more convenient. The last project, the facade can simulate the rain. And this project, the facade can reflect the wind. It seems that the wind is visible on this facade. We can just not only can feel the wind, we can see the wind by this facade. Aluminum is a perfect material for the facade, but sometimes maybe we can consider to use steel, stainless steel or mild steel, because of its high strength, because some of our project maybe it needs big span, and this project we use fine process steel. It's not a normal steel. We make this kind of steel profile or steel monument by steel plates, and we weld it into different sections and polish it very well with very small chamfer. So it looks like aluminum, but it has higher strength and suitable for the big span facade. The maximum span is around 25 meters for this project. And there is another project in Doha. We use stainless steel as a facade monument, and it's polished to be 8K mirror. It looks like a real mirror, and the section size is also very big for this project. And total, the maximum span is around 24 meters. And this is the TSMC office building in China. We use 2 pieces of 13.5 meters stainless steel plate to assemble it together to be a stainless steel monument. And fix the glass with a clamp. It makes the facade be so transparent. It's almost the same as structured glass system. And this project is a key development center in Korea. The louver glass is fixed to stainless steel monument and tension rod with glass clamp. And all of the support structure of this facade is made by stainless steel. And all of the 4 elevation of this facade is same design. It makes this building more energy saving and looks unique and fabulous. This project is a Hyundai's showroom. It's the same architects with lots of projects. This kind of design is not so complicated. The architects use 5-layer stainless steel mesh to cover the building. It makes the building look so shiny. For some special shape facade, maybe we can consider to use spider system. This kind of spider is adjustable in 3 directions and rotatable for each spider leg. It's special use for the triangle glass. And for this project, we can say we just use one kind of spider because some place we need 7 legs or 8 legs. Some place we just need 2 legs or 3 legs. We can remove one spider leg from one spider to another spider. Then we can get different spider. This kind of design makes the installation and delivery faster. The second part, facade with mesh. It seems that more and more architects prefer to use mesh on the facade. We are honored to have a project in Ho Chi Minh. And this project is Taken Bank office building. The consultant is Ahmed, and the fabricator is Eurowindow. So this is a double skin facade. The inner skin is glazing, and the outer skin is mesh. It's a mesh panel. The maximum size is around 1.9 meters by 3.9 meters. As a hardware supplier, we give our solution by customization and optimization. We customize so many hardware for this project, like big load capacity hinge and concealed latch, and some accessories for fixing and stretching the mesh to make the mesh be very flat. Sometimes the function just the basic requirements. Architects is not satisfied with our standard latch. They want a concealed latch. So we customize a concealed latch by stainless steel castings with painting. It makes the color is same or is close to aluminum cover plates. After this accessories or hardware is customized, it's essential to do some tests to check if it can meet the function or performance requirement or not. Sometimes we do it in our laboratory. Sometimes we need to send it to a third party, like this big load capacity hinge. It passed 20,000 tons cyclic tests. And also the QC is also very important. We follow our standard QC procedure and do some modification based on this project requirements. And we take the mesh example, the QC including the chemical components, diameter, size, installation torque, and so on. For each part, we have our QC sheet. So for a facade, a wide variety requirements we will get. So we think the best way out is we follow the requirements from the beginning. The procedure including the specification, test report, design, and installation, supply, after-sales service, maintenance, and warranty. We try to understand the concept and make it come true with reasonable price. The third part, transparent LED facade. First, transparent LED has almost the same performance with traditional LED. This is a traditional LED. What happened if we close this LED? It's a blackboard. But transparent LED, it can make maximum 95% transparency, which means if we use it on the facade is always be transparent, even the screen is shut down. And this is an application for this kind of products. NextNova is one of Kingdom's subsidiary. They are a world's leading supplier for transparent LED screen. Their products has been widely used from many countries and many projects. Maybe we have seen this kind of products in interior application for the public or commercial projects. But right now, the latest technology make it possible or suitable for the facade. So what's our solution? We have two solutions. The first one, LED laminated glass. If we see it, this is just a normal glass, but this is a transparent LED glass. How we make it? We put the LED lamp and the circuit on the surface of transparent panel, and we fix it between two glass panels by PVB, SG, or SGP interlayer. So it makes it no difference with traditional laminated glass, but it's a LED glass. Just the thickness is bigger, and use one more layer, SG interlayer. This is a project. It's a perfect combination between transparent LED screen with our structured glass system. So maybe you consider if we can use it with insulated glass or normal unitized facade, and this is our second solution, LED insulated glass. This is a normal unit for facade units. We just put one more layer, transparent LED panel inside of insulation glass with PVB or SG or SGP glass. There's no difference compared with traditional facade units. But we put the control modular inside of the aluminum profile. This is how it works. There's not too much difference. And this is a project. We customized many special size of units. As we see, facade is not so boring. And we have a few kind of this transparent LED mock-up in our new showroom. We have a showroom in Ho Chi Minh. This is a new showroom, so hope you can visit our new showroom. And this is all my presentation. Thank you.
Thank you very much, Mr. Liu. Phần thuyết trình của Mr. Liu vừa rồi cũng đã khép lại phiên 3 của chúng ta và chúng ta sẽ đến với một phần networking tea break trong vòng 20 phút. Welcome back, ladies and gentlemen. Please take your seat and we will move to the session for the last session of the conference today. I would like to introduce the next speaker, Mr. Olivier Dezo Azier. Please give a big round of applause to him.
Hi everyone. I'm chairman of Deso Asia. Deso Asia is a Vietnamese company, and I am working in Vietnam since 15 years. And we do this building, which is a city planning exhibition center. And I have two offices, one in France and one in Vietnam. To introduce quickly the office in France, we do a lot of public building. And the construction is very important for us. Construction gives sense to the architecture. We use the construction, we work with engineers, we work with facade to give sense to the project with a good material at the right place. This is very important. So we do a lot of building on wood, copper, different type of building in France. And today I would like to show you effectively for a specific building, which is Louis Vuitton factory, how we design a facade and what is the story of the facade. This building is building we do in France. Always we try to give sense to melody, rhythm, filter, massive light on a facade with different material. The story I want to tell to you is the story of a Louis Vuitton factory. They redo the new factory in France, 5 factories in fact, and they call Deso to design this factory in a huge place because the market of the bag, as you know, for Louis Vuitton is very huge, especially in Asia, and they need to build this bag in France. So I begin my explanation by this one. Louis Vuitton chose very specific area in France with a beautiful landscape, beautiful area, patrimonial area in a very different country to define new factory where the worker will be in a very nice place. So when we begin to work with Louis Vuitton, we first imagine to have beautiful factories with a huge view to the landscape, to the horizon. This topic will be defined for all the factory with a very, very simple story. All the factory was open to the north to obtain the beautiful light to the north, and after the logistic and the office was on the south. All the factory was done with the same system. And the idea at the beginning, this was the first sketch, we would like to use this north facade as a huge transparent facade open to the landscape. And the idea was to open a maximum inside the factory and to build with wood for different reasons, also for question of sustainability. This was the first sketch. And as very, very quickly, after this first sketch, we decide, and this document show exactly what we do. We try to keep 30 meters without any structural things, and in a system where we can do a factory in 1 year. 1 year studies and construction. So the goal was very important. And we decide to build on wood and structure in metallic structure this huge hall, all completely open after with a facade to the landscape. So the story was at the beginning this one. We try to organize a simple steel structure after a roof made by wood, and the facade, very, very light facade, will be done on steel. As you can see here, the facade was also a structural facade. And it's super important because we see absolutely no column on the facade, and we have the feeling that the building completely floats without any structural column. So this is during the construction, and right after, it was very easy and very quick with this process made by double structure wood and steel to build the factory. I continue. This is the way we build. And the facade, the north facade, was completely on open. We have only on the east and south facade some screen, but the facade was completely on the north, so completely open for the worker. Effectively, it was a challenge to bring the facade on site, but in fact, it was not. It was very easily to do, and the result was this one. When you are inside the factories with a beautiful light for the worker, and you can see here the Louis Vuitton place for the worker, we can admire the landscape, which is a huge French landscape that all the factories were implanted in a very beautiful countryside. So this is the way we proceed. And this is the result that we can achieve just in a very quick time, 1 year later. On the facade, this is the same axonometric. The second target was also for this project to hide the, how can I say, the M&E system on the roof, and to make it very light and very to hide it. So on the first factories we use this system, and the second one we have changed, and we have put on the roof many solar panels, and we changed the location of the M&E system. But the steel structure was always the same, and the factory was in fact the same with the logistic area. And you can imagine that for Louis Vuitton, the bags are so expensive that there is, in terms of security, a lot of protected area. This is the result. Alors for sure, this building is the first one we do, and I would like to show you how slowly, one by one, we have exchanged. Also, when you work for Louis Vuitton, for sure, the question of the pattern was immediately asked from the part of the client. And we, on the south facade, we have used for this first building these strong panels on steel to recall also all the work of Louis Vuitton bags and all the pattern is how can I say is very important for Louis Vuitton. This is the south facade. As you can understand, we are close to the sun. We have sunscreen inside, and the roof a little bit go on the cantilever to protect the facade to the sun. This is inside. And I really like this picture because as an architect, I'm sure there's also many architects and engineers, you can imagine that all the complexity we have in this picture because we don't see the effort of the structure go from the roof to the soil. Alors, the second building we do was this one. It was similar as the first one, nothing specific. This building follows the first requirement of the first one. The facade east and west was similar, use steel, and always the same story. All the building is open to the north, and the south is dedicated to the office. At another moment, so another building, similar, this one. But the client want to ask us to be more sustainable. And we propose in a new generation of this factory to have a ventilation, natural ventilation. So on the new project, we add a new system of ventilation, which is this, how can I say, this pivoting system on glass, who can open on the night, as we discussed this morning. In France, we have a big difference of temperature between the night and the day, and so if we can imagine that on the night we can make a free cooling, we can have inside the fresh air, we close this system of glass during the day, and we win a lot of energy for to refresh the building during the summer. So this is a new generation of building. I continue, the facade. And on this one, also in a beautiful landscape, we decided, and we have two new systems. The system of the natural ventilation, and we used wood burn facade, as the client always required to us to be more sustainable, to use less energy and to use a maximum of wood. Because in France there is many requirements today to use a maximum of wood on building. It's also a link with carbonized approach. This is a building, and this is the latest generation of factories. We have the natural ventilation. We have a mesh behind this system, and during the night this facade is open. And in fact, we win half energy to refresh the building. This is a building on the night with a similar system, which is for, as you can imagine, also for Louis Vuitton, a challenge to have important and patrimonial building located in different parts of France. So this is now, we can see here the latest generation of building. And step by step, at each building we progress. And on this one, this is the latest one. And on this one, we build inside the building some bag, but it makes a lot of noise. And Louis Vuitton ask us to take care about acoustic, and as we discussed also this morning, we have hired some acoustic and engineer, and you can see on the top some absorbing system to absorb the sound in the factory. This is the new generation of building, the same angle. We have the natural ventilation, as you can see. And the big problem of the factories was to control the hygrometric. For sure, we are not in a tropical climate, because to build a bag, you can imagine that it's very sensitive, very complex. But in fact, it works very well, and there is no problem, and we use this natural ventilation. The idea also is to give sense to the beam. The beam support the structure, the light, the acoustic, as you can see in this drawing. And this is a building on the night with a, I have a small film, perhaps I can show you to you if it works. I don't know. I try. As it is explained in French, I will translate in English.
L'histoire du projet démarre en 2018 sur une double proposition. Concevoir un atelier à la campagne et depuis le poste de travail.
The demanding was to support the job of the worker for Louis Vuitton and to offer a maximum of a very nice area.
Un atelier agile de 6000 m², conçu et réalisé en un an.
Each building is 6,000 square meters. We have 5 buildings down.
Par l'idée de renouveler l'aménagement des postes de travail, favorisant un fonctionnement à la fois flexible et collaboratif. et un récit extérieur par son rattachement à un territoire, bassin de ressources, des compétences et environnement paysager.
Also, the building is located in each area in France when the client asks us to emphasize the local and the natural landscape and the vegetation there.
Couse, maroufle, et celui de l'entreprise de construction du bâtiment qui découpe, soude, ajuste,
We can
boulonne,
see the
rabote,
30
assemble.
meter of the beam. The new generation of building is on the right. You can see the solar panel and the M&E system have changed. The first building is on the left.
Par des nécessités du projet, itération rapide,
6 meters high for the facade by 2.5 meters.
Le maître d'ouvrage ne nous a pas confié un programme, mais un objectif à développer. La conduite du projet s'inspire du storytelling pratiqué par la marque pour ses productions.
What is very important is effectively we try to give sense to this building with a sense of construction, sense how we use material, how we assemble the material, how we make that the same material work together.
Bois métal pour les poutres de 30 mètres et pour leur juste expression. Vêture de métal déployée, façade intérieure en bois brut.
All the interior building with the acoustic panel to avoid the problem of noise and to offer to the people the maximum of comfort.
Le projet de Beaulieu-sur-Layon est l'atelier 0, amorçant la réalisation de 4 nouveaux ateliers sur d'autres points du territoire. Le 5e atelier est jumelé au projet originel, bénéficiant des retours d'expérience des autres sites. Il bénéficie notamment d'une ventilation naturelle au service d'un confort amélioré.
You can see here the natural panels for the ventilation, as I explained before. And the first building generation on the left, the second one on the right. Well, thank you very much. I have finished.
Thank you very much, Mr. Olivier, for the very interesting presentation. Và bây giờ chúng ta sẽ đến với phiên tham luận thứ hai trong buổi hội thảo ngày hôm nay và cũng là phiên tham luận cuối cùng với sự điều hành của ông Nghĩa Phạm, founder và cũng là CEO của Studio Age.
Good afternoon, everyone. Xin mời các khách mời có mặt sau đây lên sân khấu để chúng ta tham gia buổi phiên thảo luận. Đầu tiên là xin mời ông Sergio Silva, Founding Manager Partner and Architect S+A on the stage, please. Mr. Kevin Chen from MYD Group, please on the stage. Mr. Trần Ngọc Thái, General Deputy Director, Regal Group. And lastly, Mr. Trần Văn Tiến from BM Window. Xin chào mừng tất cả các khách mời có mặt trên buổi thảo luận ngày hôm nay. Hôm nay thì chúng ta có vai trò của tất cả những thành phần tham gia trong một cái dự án facade, bao gồm có đại diện chủ đầu tư, có kiến trúc sư, có đại diện của quản lý dự án, cũng như là đại diện của nhà thầu. Thì hy vọng là phiên thảo luận này có thể tổng quát được tất cả các vấn đề hiện tại của một cái dự án triển khai thi công về facade. về mặt lựa chọn nhà thầu facade cũng như quá trình triển khai các cái biện pháp để quản lý về thời gian và độ hiệu quả của một cái dự án triển khai về facade, cụ thể là tại Việt Nam. Câu hỏi đầu tiên thì tôi muốn dành cho anh Trần Ngọc Thái với tư cách là một chủ đầu tư và kinh nghiệm của anh với Regal Group thì tiêu chí nào là cái tiêu chí quan trọng nhất để lựa chọn một nhà thầu về facade?
Tôi là Trần Ngọc Thái, đến từ Regal Group. Chúng tôi là doanh nghiệp và nhà đầu tư phát triển bất động sản cao cấp ở tại khu vực miền Trung. Kính thưa quý vị, thì đến hiện nay chúng tôi đã xây dựng xong 11 công trình nhà ở tại khu vực miền Trung, thì cũng là doanh nghiệp mà xây dựng về nhà ở đang với số lượng dự án nhiều nhất ở tại miền Trung Việt Nam. Thì chúng tôi đến từ Đà Nẵng. Hôm nay cũng rất là vui khi mà được mời trong cái sự kiện, thì chúng tôi đánh giá là khá phù hợp với lại cái việc đầu tư các dự án công trình của mình. Thì ở chúng tôi đánh giá dựa trên cái nét văn hóa của người Việt Nam khi mua về cái bất động sản nhà ở, đó là cái ngôi nhà hay là cái công trình nó thể hiện ra cái phong cách của chủ nhà và thể hiện ra cái tính cách của chủ nhà. Nên là cái việc mặt dựng của một cái ngôi nhà nó có ý nghĩa rất quan trọng. Và từ đó thì chúng tôi đánh giá lựa chọn được những cái nhà thầu thiết kế mà nó phù hợp với lại các cái yếu tố mà để đạt được cái mong muốn của chủ đầu tư muốn triển khai cho công trình của mình thì rất quan trọng. Thì thường chúng tôi chọn thầu các nhà thầu về facade nó ở 2 giai đoạn thông qua 3 cái yếu tố chính. Giai đoạn thứ nhất là giai đoạn mà kiểm tra các cái hồ sơ cũng như là để chọn lọc, thì thông qua 2 yếu tố về cái profile hồ sơ năng lực và cái yếu tố về sự phù hợp. Thì với các cái profile ở đây là đơn vị đó đã thực hiện các công trình và với những cái giá trị và ý nghĩa của những công trình đơn vị đó đã thực hiện thì đã được đánh giá. Thứ hai là cái sự phù hợp. Thì sự phù hợp ở đây tức là cái việc là từ thiết kế đến triển khai và ra được công trình. Đó thì nó là phù hợp khi mà cái yếu tố mà triển khai nó đảm bảo. Thì chúng tôi cũng lựa chọn một đơn vị thiết kế thì cũng dựa trên cái 2 cái yếu tố đó thì chúng tôi đã lựa chọn, tức là ngay từ vòng đầu, giai đoạn đầu chúng tôi đã lựa chọn được. Đó là nhà thầu DB Façade thực hiện cho facade của cái công trình chung cư cao cấp Regal Complex ở tại Đà Nẵng của chúng tôi. Thì cũng thể hiện được các cái giá trị về mặt dựng, mang những cái yếu tố khác biệt cũng như là đạt được cái mong muốn cung cấp cái công trình mặt dựng có cái yếu tố kỹ thuật cao nhưng mà tính vận dụng thì là khả thi. Đến giai đoạn thứ hai, khi mà cái yếu tố về những cái lựa chọn sự phù hợp và cái profile được ok rồi thì giai đoạn phỏng vấn là giai đoạn rất quan trọng. Thì lúc này các bên có hiểu nhau hay không để đi được thống nhất với nhau hay không, thì đạt được những cái nhu cầu của chủ đầu tư chúng tôi đưa ra thì cũng khá là đơn giản, đó là thông qua các công trình thì có thể kể được cái câu chuyện, ví dụ như nó có thể là ứng dụng được những cái nét từ cái nét văn hóa của doanh nghiệp, hay là từ những cái đơn giản như là ứng dụng từ cái logo của doanh nghiệp lên các công trình, để từ công trình mà thể hiện ra được cái nội dung mà muốn kể chuyện. Thì đó là cái mong muốn thể hiện, đó là văn hóa của doanh nghiệp thông qua những công trình. Thì đó là những công trình mang cái giá trị về văn hóa thì nó sẽ mang tính trường tồn lâu dài. Thì khi mà những nhà kiến trúc mà hiểu được những cái việc này thì đó là cái sự phù hợp trong cái yếu tố giữa nhà thầu và chủ đầu tư để thống nhất được với nhau.
Vâng, rất cảm ơn anh Thái. Thực ra thì trong một cái công trình, một cái dự án nào cũng vậy thôi đúng không? Thì chúng ta, việc lựa chọn đúng nhà thầu tư vấn là một trong cái tiêu chí tiên quyết để tạo nên thành công của dự án. Và một dự án thì bao giờ cũng bắt đầu với một kiến trúc sư và một công ty kiến trúc. Sau đó sẽ đến các đơn vị thiết kế tiếp theo, ví dụ lighting, facade hoặc là landscape. And the second questions I would like to point to Mr. Kevin and also Mr. Silva. Of course, all the guests here can feel free to add any discussion or comment if you would like to. So the second question is, does architect has a role in appointment of the facade contractor?
Yes, definitely. So, but you cannot do it alone as architects, right? So we can support to make or to appoint the design consultant or the contractor. We can also help to design and coordinate for the designer contractor. Also, we can support the client to do the contract negotiation because we design it, right? So also we can support checking the control and doing authorship monitoring. And also, but always is very important that we cannot do it alone. So all this is a process, a holistic process, to help to appoint the facade contractor.
Yeah. So normally, when you work with client on a particular project, you make your recommendation about the facade contractors that fit into the design, or what would be the normal process?
Ethically, we should not do it. So we can support to provide some reference as a contractor, as an architect for some contractors, but we don't appoint any contractor.
Yeah. Mr. Kevin, you would like to add in something?
Sorry for the design of the facade. I also have some experience for when I'm working with the architectural consultant. I think for the first one, we have to clarify about the budget of the products of the building. It's a very important for we start with the design. That is the key point to do make the success full for the project in the future. So when we clarify everything about the information about the level complete of the building, after that we catching the idea for the facade, and of course we coordinate with the investment to make the FS how can adapt with the cost from the client. That's the point. And the second one, I think, have to cooperation with the contractor who is a professional on the facade design or the facade construction in the Vietnamese market. So I think sometimes we have the problem with the client. They often expect the aesthetic of the products, but the limit of the cost is a gap between the consultant also the contractor. So that's a point. We also have the problem between our. So I think so.
Yeah, I agree. Actually, in Vietnam, you know that very special thing to happen is when the architect designed the buildings, the investor or the client, they expected that the architect will do the facade design, which is not really right? So the architect should have a very good recommendation to the investor that you need to have a facade designer, very professional, because especially for the very complex building, right? So Mr. Tien, I think you understand very clearly about these issues. It's also because the control, the management of the facade construction on the later stages is very important. So another question is about the facade management. Is that should be a team from client to manage the process of the facade constructions, or it should be like independent consultant to have to manage? câu hỏi thứ ba có thể cho anh Thái và thậm chí cho cả anh Tiến là trong một cái quá trình triển khai dự án thì có nên dùng đội ngũ tư vấn hoặc là quản lý dự án của chủ đầu tư để quản lý facade không, hay chúng ta sẽ thuê một đội tư vấn facade bên ngoài?
Trên kinh nghiệm của chúng tôi thì cái việc team của chủ đầu tư hay là thuê ngoài ấy, thì nó dựa trên năng lực của team quản lý. Ví dụ chúng tôi sẽ phân khúc ra là chúng ta đánh giá được cái năng lực của mình đến đâu. Ví dụ như trong các dự án quy mô thấp tầng, quy mô vừa thì đội ngũ năng lực quản lý của chúng tôi đảm bảo thì tự chúng tôi sẽ thực hiện. Tuy nhiên đối với các dự án mà quy mô lớn, ví dụ như hiện nay chúng tôi đang thực hiện dự án Novotel Hotel and Residence ở Quảng Bình, thì đây là cái dự án Novotel có quy mô mấy bằng sàn cũng quy mô chắc lớn nhất Việt Nam. Thì công trình này chúng tôi cần phải thuê team có năng lực. Ví dụ chúng tôi đã thuê là team Turner để quản lý, để nó mới đảm bảo được cái việc công trình với các kiến trúc phức tạp cũng như là cái giá trị đầu tư lớn thì nó sẽ đảm bảo được cái tính xuyên suốt cũng như là cái năng lực của chúng tôi nó phù hợp hơn, chứ thay vì là chúng ta mà nó không có nắm hết thì nó sẽ dự án nó tỷ lệ thành công nó sẽ không cao, cũng như là đau đầu nhất trong cái việc mà quản lý không tốt đó là khắc phục. Tại vì chi phí khắc phục nhiều khi nó sẽ còn lớn hơn rất nhiều đối với cái chi phí mà chúng ta làm nó không đảm bảo từ đầu.
Chắc tôi xin phép trả lời cái câu hỏi của Nghĩa. Nhưng mà lần đầu tiên thì chắc có lẽ là cho tôi gửi lời cảm ơn tất cả các anh chị ở đây. Đến giờ này, một ngày tôi nghĩ là rất là bận rộn và cũng rất là căng thẳng để chúng ta nghe hết những cái kiến thức ngày hôm nay. Thank you very much on everybody now at the city. We are very, very thank you event organized from the also Souquet. Now we have here for the share something. Với vai trò của một nhà thầu như BM Windows trải qua hơn khoảng 500 dự án và rất nhiều dự án khó. Và chúng tôi cho rằng cái facade là một cái chủ đề rất là đầy tính phức tạp và cái độ khó nó càng ngày tôi thấy rằng là cái nội dung này kiến thức rất là cao và rộng. Có thể các anh chị sẽ nói là nhôm kính hay là như thế nào đó, nhưng mà nói về vấn đề facade thì nó là một cái chủ đề mà tôi nghĩ rằng là chúng ta có thể rất nhiều cái buổi tọa đàm mà chúng ta cũng sẽ không tìm ra hết được cái kiến thức của nó. Theo quan điểm của tôi là như vậy. Tuy nhiên trả lời cái câu hỏi của anh Nghĩa thì tôi nghĩ như thế này. Thứ nhất, đầu tiên nói gì nói, nếu cho một công trình mà facade đúng nghĩa thì phải có nhà thầu chuyên nghiệp. Cái thứ hai nữa là nhà thầu đó chuyên nghiệp chưa đủ, phải có sự phối hợp với chủ đầu tư, nhà tư vấn và cả những anh kiến trúc sư để chúng ta có một cái sản phẩm hoàn chỉnh. Vậy thì chủ đầu tư có thể tham gia trong quá trình kiểm soát chẳng được, nhưng mà với điều kiện là chủ đầu tư cũng phải hiểu nghề. Nếu không hiểu nghề chúng ta rất khó. Tại cái này nó giống như anh Thái mà nói thì cái rủi ro nó rất là lớn. Chỉ cần một cái chi tiết nhỏ có thể làm hỏng một dự án lớn, và cái chi phí chúng ta không thể nào chúng ta đánh đổi mà chúng ta không thể thay thế được. Thì vậy thì ai là người chịu trách nhiệm cho cái công việc này? Tôi nghĩ phải có một người có nghề, đủ năng lực, đủ tâm huyết, và hơn ai hết phải tạo được một cái đội nhóm đồng lòng để mà chúng ta đi đến một cái dự án thành công. Và cái người đó không ai khác, đó là những người tư vấn, quản lý dự án chuyên nghiệp, và hơn ai hết là phải có một cái chuyên gia trong cái lĩnh vực đó để mà đồng hành cùng với nhà thầu, cũng như làm sao đưa ra những cái quyết định hợp tình, hợp lý và có hiệu quả cho chủ đầu tư. Đó là cái câu trả lời của tôi. Tôi nghĩ rằng là rất nhiều anh chị em ở đây cũng hiểu được cái vấn đề facade là một cái trong những cái chủ đề mà tôi cho rằng là rất quan trọng trong cái công tác kiến tạo bộ mặt đô thị, và cũng là cái tuổi thọ công trình nó đi theo. Thì tôi chia sẻ như thế để các anh chị có thể, dĩ nhiên mỗi người sẽ có một ý kiến khác, nhưng với kinh nghiệm của tôi hơn 500 dự án, tôi nghĩ đó là một cái câu trả lời rất khó mà để chúng ta thay đổi nó. Xin cảm ơn.
Vâng, thank you very much, Mr. Tiến. And following the discussion and your your answer, I think the role of project management in the facade design and constructions very important, right? So, a question for Mr. Kevin: what would be or when should be the role of the facade management consultant in particular project?
Về vấn đề này thì tôi nghĩ rằng là trong quá khứ của tôi làm việc là cũng có rất nhiều cái bài học về facade giống như là các anh chia sẻ. Đôi khi về cái việc mà chúng ta muốn thành công hay là thất bại của facade thì chúng ta phải đặt vấn đề là cái công trình đó cái hiệu quả nó là cái gì. Ví dụ như nó là một cái icon trong cái tương lai của một cái tập đoàn nào đó, thì mình phải lựa chọn cái nhà tư vấn chuyên về có hiểu biết kiến thức về facade. Tại vì facade ở đây không chỉ là thiết kế thẩm mỹ mà là phải hiểu về kỹ thuật để từ cái thẩm mỹ đó nó ra thực tế. Cho nên có những cái chủ đầu tư họ đi về facade, họ rất là tham, xong rồi cuối cùng thiết kế ra là cái chi phí nó rất là cao, xong rồi là phải bỏ hẳn luôn cả một concept đó và thuê một cái tư vấn khác. Với cái chi phí có khi nó đội lên tới khoảng là 4-50 tỷ cho phần thiết kế không. Ví dụ như là tư vấn mà mời cỡ mà Calatrava của Mỹ thôi, họ thiết kế thôi, là họ rất là tham vọng về cái icon cho một cái building. Nhưng mà cuối cùng thì nếu mà chúng ta đặt để cái vấn đề nó không đúng chỗ thì cuối cùng chúng ta phải có những chủ đầu tư họ phải trả giá và họ phải cancel hết nguyên cái thiết kế đó làm lại. Thì cái đó cũng là một cái thất bại trong cái facade. Quay lại cái vấn đề mà làm sao mà để có thể customize được giữa cái tư vấn với lại nhà thầu thì tôi theo dõi từ sáng đến giờ. Đây là cái thời gian cuối cùng của cái buổi hội nghị này, thì tôi thấy rằng là facade nếu như không hiểu về kỹ thuật, không hiểu về những cái tiến bộ có sẵn để áp dụng vô thiết kế thì rõ ràng là chúng ta vẫn chưa có đáp ứng được đúng cái mong muốn của chủ đầu tư. Tại vì không phải cứ mắc, không phải cứ đắt tiền là được, mà phải phù hợp là được, phải phù hợp mới là thành công. Cái đó mới là đem lại cái lợi ích cho chủ đầu tư. Thì tôi nghĩ rằng là trong facade cũng nên có cái sự áp dụng ở cái tiêu chí đó.
Thực ra thì trong một cái dự án kiến trúc thì cái việc ra quyết định để phê duyệt phương án là cái bước đầu tiên để đảm bảo một cái dự án nó thành hiện thực. Bởi vì thực ra ở Việt Nam thì nhiều chủ tư thì đúng như anh nói là họ rất là hào hứng với những cái rất là duy mỹ với những cái tác phẩm kiến trúc. Tuy nhiên họ không hình dung được là cái mức độ phức tạp và cái chi phí trong quá trình triển khai nó sẽ như nào. Và khi mà bóc ra chi phí thì toàn bộ nó vượt quá cái dự kiến ban đầu và cái dự án không thực hiện được. Vậy thì đối với những các cái dự án mà mình đã được phê duyệt phương án và khả thi thì tại sao những dự án đó vẫn thất bại? Có thể là do quá trình quản lý chưa tốt, hoặc là có thể do quá trình lựa chọn nhà thầu chưa tốt. Thì câu hỏi này tôi muốn dành cho anh Tiến và Mr. Silva to answer the question.
Thank you. Tôi nghĩ rằng một cái dự án facade thành công thì chúng ta cũng đã nói rất là nhiều rồi. Khi thành công thì chúng ta rất là dễ. Chúng ta dễ chấp nhận lắm, dễ ca tụng, dễ nói rất là nhiều thứ. Tuy nhiên khi thất bại thì hầu như không ai nhận ra cái trách nhiệm cho mình. Khi một dự án đây phê duyệt rồi mà kết quả nó không đến thì tôi nghĩ có nhiều vấn đề. Đầu tiên là chúng ta chưa đánh giá đúng cái mức độ quan trọng của cái dự án, đặc biệt là cái facade. Thành ra khi chúng ta đầu tư không đúng, thứ nhất đặc biệt là con người. Cái thứ hai nữa là chúng ta nghĩ rằng là có thiết kế rồi thì ai làm cũng được. Cái đó là một cái cũng là rất là nhức nhối. Mà khi mà thiết kế mà chúng ta không hiểu nó và chúng ta không làm theo đúng cái quy trình trình tự nó thì chúng ta sẽ dễ bị một cái là chúng ta chỉ có đáp ứng được cái thẩm mỹ thôi. Còn kỹ thuật giống như các anh nói sẽ rất là khó nếu chúng ta không có đội ngũ hiểu nghề, biết nghề và làm được theo ý đồ. Và cái thứ ba tôi nghĩ là một dự án thường nó hay, cái vấn đề nó hay bị ở chỗ là trong quá trình làm thì thường các nói tôi thì tôi cũng xin phép nói là thường là các anh chị chủ đầu tư ít khi tin nhà thầu, ít khi tin những cái đơn vị mà đồng hành với chúng ta. Cái đó mới là cái rào cản. Khi chúng ta tin với nhau, chúng ta làm được với nhau thì cái dự án mới thành công. Còn nếu như chúng ta đưa ra những cái quy trình, những cái quyết định mà nó không mang minh tính mà để mà chúng ta cùng nhau chúng ta xây dựng thì thường cái dự án nó nằm ở giữa chừng thôi. Thì tôi nghĩ đó là ai cũng biết. Tuy nhiên là một cái việc gì khó, đặc biệt là cái facade, chúng ta phải có đầu tiên nói chúng ta phải đủ lực đây nó có là đủ cái tài chính và đủ về cái năng lực. Và thứ hai nữa là chúng ta phải quyết tâm để xây dựng một cái team, và ở đó chúng ta phải tin nhau mới làm được. Và thứ ba nữa là cái sự cam kết trong mỗi đội nhóm. Khi với chủ đầu tư thì chúng ta phải có những cái chức năng quyền hạn thế nào, rồi tư vấn là cái vai trò giám sát làm sao, rồi design thiết kế nó thế nào, và cái quan trọng nhất là cái nhà thầu phải có chữ tín. Tôi nghĩ tôi làm trong cái ngành này thì tôi không phải là quá lâu, nhưng mà tôi nghĩ rằng cái facade này là một cái sự biến đổi rất nhiều nếu chúng ta không đặt cái niềm tin đúng chỗ. Một cái giá thành có thể là 10 đồng, cũng có thể làm một cái sản phẩm tương tự như thế, chỉ có 50% giá trị thôi. Và cái kết quả thì chắc anh chị cũng biết rồi. Tôi nghĩ rằng đó là một cái nghề, nó không chỉ là kiến thức mà nó còn cả một cái tâm trong đó để chúng ta xây dựng một cái sản phẩm mà tất cả các chủ đầu tư cũng như là những cái người đồng hành nó để có cái để mà chúng ta tự hào. Xin cảm ơn, đó là chia sẻ của tôi. Thank you.
Also, I think that is also how we understand what is a facade, right? Because facade is part of the project and is like our skin. And the facade brief, the facade need to receive sun, need to be protected by the sun. So start always from the design intent. Start always from what we want to use as a facade. One of the things also is the incorrect specifications of the facade. Design in tropical weather is one thing, design in Europe is a different way. So we cannot use the same standardization. Another thing as well is the lack of supervision. It's very important that when we design with our colleagues from the facade engineering, we need also to make the supervision and following the process in the construction. Also, the last point that I think is the type of material, the material degradation for the site that we want to design. So all these points are all connected, and return back to the beginning when what we want from the facade. So this is the reason.
Yeah, I totally agree. Actually, all the things you mentioned is still about selecting the right contractor and right facade designer. It's very important on this aspect of like selecting the right material and right specification for particular cases of project, right? And also I agree totally with Mr. Tien. The trust is something very important. It's the key thing that if we have the trust, we can like work together smoothly, and the project is easier. It's got more chance to be successful in the end. It's very important. Keep going about management and how to avoid the failure of facade construction and also facade design as well. How can we, what's the solution to minimize the risk of having the wrong thing in design and construction process to avoid all the failure of the project? For this one, I would like you to get free, Mr. Kevin, Mr. Tien, to add on the answer.
Cho cái câu hỏi này thì tôi nghĩ rằng là để mà chúng ta giảm thiểu được những cái rủi ro cho cái phần mà hoàn thiện của cái facade thì cũng giống như những cái gì mà chúng ta đang nói. Đầu tiên là phải chọn được có một cái nhà tư vấn thiết kế có hiểu biết và có kinh nghiệm về facade, về cả kỹ thuật. Và sau khi chúng ta chọn được rồi thì chúng ta phải có một cái đơn vị thứ ba để tính toán cái chi phí, để cho chủ đầu tư hiểu được rằng là với cái thiết kế này chi phí đi theo phải là như vậy. Thì cái chi phí này nó bao gồm nhiều thứ, ngay cả luôn cả cái vấn đề là xây dựng và maintenance về sau nữa. Thì lúc đó thì khi mà chúng ta đi tiếp develop cái thiết kế đó thì nó mới đạt được là cái thành công cuối cùng. Dĩ nhiên là chúng ta phải pass qua được nhà thầu, phải là đúng chuyên môn và cái vật tư ABC các kiểu nó phải đúng, thì chúng ta mới đi được đến cái thành công của cái sản phẩm cuối cùng. Đa số là thường là giống như tôi quay lại câu nói của tôi hồi nãy, đa số là chúng ta thất bại khi mà chúng ta chọn approve được cái concept mà chúng ta không có tính chi phí, không có tại vì thường là chủ đầu tư họ bỏ qua cái bước tính chi phí ngay từ đầu, thì đâm ra là đến những cái bước cuối cùng thì họ cảm thấy là quá hấp so với lại cái chi phí đầu tư, là họ phải cancel. Thì chúng ta là trong quá khứ thường hay có cái chuyện đó. Nhưng mà khi mà chúng ta có tính chi phí và những cái kỹ thuật, bất cứ cái nhà thầu ở Việt Nam mà những nhà thầu nổi tiếng và những cái nhà thầu nước ngoài đều có thể thi công được, thì tôi nghĩ rằng là một cái công trình mà đã đặt để cái trọng tâm vào cái sự thành công của dự án thì chắc chắn là cái đội ngũ đi theo nó phải rất là chuyên nghiệp, kể cả về phần quản lý dự án, kể cả về phần thiết kế, thì nó cũng khó thất bại. Ở đây tôi xin là cũng không nhất thiết là phải đem là quá rõ là cái tâm ở trong công việc. Dĩ nhiên đi làm là phải có cái tâm, nhưng mà nếu mà chúng ta đã chuyên nghiệp hết rồi thì mọi thứ nó sẽ thành công nếu chúng ta chọn đúng cái cách làm. Thì cái điều đó nó đặt cái vai trò của quản lý dự án rất là quan trọng. Quản lý dự án phải nhìn thấy được tất cả những cái risk từ cái giai đoạn bắt đầu của concept cho đến cái develop với lại cái xây dựng. Thì tôi nghĩ rằng quản lý dự án rất là quan trọng trong cái trường hợp này.
Tiếp theo lời của anh Kevin thì tôi chia sẻ với đứng góc độ của một cái nhà thầu. Về mặt chiến lược, về cách chọn nhà thầu, cách chọn tư vấn thì anh đã nói rồi. Nhưng mà đứng vai nhà thầu thì tôi có 3 cái ý mà tôi nghĩ rằng là để giảm thiểu cái rủi ro cho cái dự án facade. Cái đầu tiên là về nhà thầu là phải rất là rõ ràng, mở hết tất cả những cái gì mà chúng ta có thể làm để cho tất cả các bên đều có thể giám sát. Cái đầu tiên là cái tính minh bạch rõ ràng. Cái thứ hai nữa là cái việc chúng ta bằng cái kinh nghiệm của mình, bằng kiến thức của mình, bằng những cái trải nghiệm mình phải tạo ra được những cái giảm thiểu cái rủi ro bằng cách là gì? Thực sự là cái nhà thầu thì anh em biết rồi, nhà thầu có cái nhà máy. Tất cả cái sản phẩm đó mình phải chuyển hóa làm sao hạn chế tối đa trong việc lắp ráp ở dự án, đưa hết về cho cái việc khâu sản xuất, và chúng ta phải module hóa nó đi để chúng ta giảm thiểu cái việc mà chúng ta phải đưa ra rất nhiều chi tiết để chúng ta không kiểm soát được, là cái thứ hai. Nhưng cái thứ ba nữa thì chắc anh chị đây nghề anh chị cũng biết rồi, chúng ta phải có được cái công tác sau khi làm cái mock-up PMU, chúng ta phải test, chúng ta phải kiểm tra. Hầu như các dự án của mình là không có dự án nào giống dự án nào. Nếu chúng ta bỏ qua cái giai đoạn này thì tôi nghĩ rằng là cái rủi ro chắc chắn rất là lớn. Đứng vai trò nhà thầu thì tôi nghĩ rằng là 3 cái nội dung đó thì nếu đứng vai trò của nhà thầu cần phải quan tâm. Xin cảm ơn.
Với câu hỏi này thì tôi muốn hỏi thêm Mr. Silva là vai trò của kiến trúc sư trong quá trình triển khai sẽ là như thế nào để giảm thiểu cái rủi ro như chúng ta vừa trao đổi. Ví dụ như trong quá trình nhà thầu thì có bên nhà thầu, có bên quản lý dự án, thì vai trò của nhà thiết kế, của kiến trúc sư sẽ là gì?
So the way to mitigate the risk also, I think we need to share the same points, that is the transparency. That is something that you might mention. We need to be very clear with the investor or with the client if we can do it or not. And also, you need to understand if the technology is available in the place that we are going to build. And it's very important we be close with the contractor. Very, 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 very important to share and invite all the stakeholders of the project to stay with us from the beginning. They cannot receive the project after. They need to be part of the team in the very beginning of I would say the concept stage, because this give transparency to the process, give also some confidence to the investor that the whole team, contractor, engineering, for facade, all they are running for the same target. So I'm completely very well with your points as well.
Yeah, I agree. I actually have like my experience of more than 15 years designing the buildings. The facade is the skin, like you said, the skin of the building, and that's one of the most complicated aspects of the building. And the architect should have a very good consultant for the investor from very beginning. Indeed. And support them during the process to select the right consultant, designers, and also the contractor of the facade. So make sure it minimize the risk for the client. Otherwise, it's very easy to get to be failure. I think we not have too much of time left. So the last question is for all the panelists here. Is about the timing control and quality control. How can we control the project to be delivered on time and to make sure the quality is expected from beginning, from the client point of view, from the contractor point of view, from the designer point of view. I think that's the key thing, the most important outcome for all the parties participated in the whole process. Mr. Tien, I think it's very important, right? Because only depending on the contractor. It's very true.
Thank you. But yes, I will say you can say something. Tôi nghĩ là cái việc mà để kiểm soát cái kế hoạch, cái công việc, nói gì nói cái công việc là chúng ta đầu tiên là chúng ta phải có kinh nghiệm cái việc triển khai. Tuy nhiên cái việc kinh nghiệm nó chưa đủ, chúng ta phải lập ra một kế hoạch rất cụ thể và chi tiết. Nếu cái việc này mà chúng ta lập ra không làm được cái kế hoạch này thì rất khó chúng ta để kiểm soát được cái thời gian, tiến độ dự án. Nhưng mà với mỗi cái mốc thời gian chúng ta cũng phải làm ra chừng cái chi tiết của đầu việc. Ở đó chúng ta từ cái khâu mà thiết kế chi tiết cộng với lại khâu mà nhập hàng, thời gian nhập hàng, rồi thời gian chúng ta làm mẫu, chúng ta test, rồi tất cả thời gian chúng ta sản xuất và gia công chúng ta phải làm rất là kỹ. Và trong suốt quá trình đó chúng ta phải đưa nó ra cho tất cả các những ai tham gia để cùng đồng hành và giám sát cái việc đó. Thứ hai nữa là để mà đạt được cái việc này thì tôi nghĩ rằng là cái về kiểm soát cái thời gian nữa thì cái đầu tiên là cái năng lực của cái đơn vị. Tất cả chúng ta đều nghĩ rằng là chúng ta lập lên được, nhưng mà khi mà chúng ta tham gia vô thì một là cái phần mà ra những quyết định để mà chúng ta đi tiếp cho những cái cột mốc thì thông thường thì chúng ta phải đi đúng cái vai trò của cái người giống như là chủ đầu tư ra quyết định, cái người tư vấn phải approve về bản vẽ và cái nhà thầu phải đủ lực để làm cho kịp đúng cái tiến độ mình đưa ra. Nhưng cái thứ ba, cái cuối cùng, chúng ta làm hết tất cả mọi thứ xong xuôi hết nhưng mà chúng ta quên mất một cái khâu là chúng ta cần cái thời gian để mà chúng ta kiểm soát lại toàn bộ dự án, tức là tôi nói là test toàn bộ dự án, kiểm tra toàn bộ dự án. Thì cái khâu này thì tôi nghĩ rằng cũng rất cần thiết khi chúng ta làm đến cuối cái dự án rồi nhưng chúng ta không có chuẩn bị một cái khoảng thời gian chúng ta kiểm tra cái sản phẩm của mình thì nó cũng sẽ chưa phải là kết quả hoàn chỉnh. Thì ba cái yếu tố đó tôi nghĩ rằng là theo cái cá nhân của nhà thầu chúng tôi thì chúng tôi có 3 cái điểm như vậy. Còn dĩ nhiên các anh cũng sẽ có những cái ý kiến.
So Mr. Thai, Mr. Kevin and Mr. Silva, you want to add on something?
Yes, let me, because we are the first ones, right, in the project. So let me share how we do in our office. For us, it's very important to be clear in terms of the time schedule, to be very realistic. So even the investor wants to shorten us every time the time. We need to be very frankly with our investor and to say, to process this type of project, we need this time to do it. This is one thing, because after everything is in the blockchain, right? So after it will affect the other stakeholders. The other thing that we use it to do is to break down all the tasks and small milestones. In this way, we can achieve faster or a little bit faster all the process. And the last recommendation that we do is to have a very effective communication. It's very important to communicate, to explain, and to be present. This is the way we use it to work in our office.
That's right. Yeah, I think one of the things is the architect role is very important because normally everywhere around the world, right, the client they want something very the best quality but very short time. So the role of architect is
And
the
cheaper.
first person to participate from very beginning. It's very important to consult the client. That's this is the proper timeline to make sure the quality control, right? It's
Correct.
very important.
Even the same with the contractor, because they
Yeah, the same. Yeah, the
cannot
same.
overpass some tasks because it's impossible, right? So this is need to be very clear to the investor.
Okay, so anybody else you want to add on something on this one? Thái có muốn thêm cô?
Tôi xin chia sẻ thêm về cái việc các cái khó khăn trong cái việc mà để hoàn thành các cái dự án mà có những facade phức tạp. Thì đối với các dự án mà xây để các chủ tư làm tài sản của các chủ tư thì người ta rất là chịu chơi để mà có những cái facade phức tạp hay là có các cái công trình gọi là để đời. Nhưng mà riêng đối với chúng tôi thì xây nhà để bán, nhưng mà chúng tôi cũng rất chịu chơi, tại vì chúng tôi là muốn xây những ngôi nhà cho khách và như là cái nhà để cho mình ở vậy, nên là cái việc đầu tư facade của chúng tôi cũng rất là chịu chơi. Và đặc biệt nhất để cho cái sự phối hợp giữa từ kiến trúc sư đến nhà thầu và chủ tư phối hợp ba bên nhịp nhàng được thì cái anh chủ đầu tư gần như là anh cũng khá là quan trọng khi mà cái mong muốn của anh đưa ra và cái mà xuyên suốt của anh ấy để anh thực hiện từ cái mong muốn đó, anh thể hiện ra cho các bên đều phải hiểu được và thực hiện được nó. Cộng với việc là cái độ chịu chơi ở đây là khi mà muốn facade đẹp đương nhiên là cái giá trị nó phải cao. Thì cái này thường là cái cản trở khi mà các chủ đầu tư nó tùy vào tình hình thị trường bất động sản lên và xuống. Nên là lúc đang lên thì rất là máu, nhưng mà lúc thị trường xuống cái này nó lại bị tắt. Thành ra là nó ảnh hưởng rất lớn đến cuộc chơi, cũng như ảnh hưởng lớn đến cái hoàn thành của công trình. Đó thì đó nó cũng là một cái yếu tố mà khách quan ảnh hưởng khó khăn đến từ thị trường. Và cái quan trọng nhất thôi thì nó là cái là phải phối hợp nhịp nhàng và hiểu được nhau, cũng như là tin tưởng. Thứ nhất là kiến trúc vẽ đẹp rồi, nhưng mà nhà thầu để triển khai gần như nhà thầu là lúc đó là gần như là vắt óc suy nghĩ, cũng như là phải đổ chất xám lớn nhất khi mà đưa ra cái giải pháp với chi phí tối ưu, thời gian nhanh chóng và đẹp mắt, đó đến giống như kiến trúc. Đó thì cái đó là cái khó khăn nhất để mà hoàn thành được của cái công trình, đó là đến từ cái giải pháp của nhà thầu cũng như là cái độ tin tưởng và độ chịu chơi của chủ đầu tư. Đó, tôi xin chia sẻ thêm về cái góc nhìn của chủ đầu tư đối với việc là để cái giải pháp của dự án cũng như để công trình nó hoàn thành được.
Vậy thì tóm tắt lại thì chúng ta khi mà có một cái dự án từ đơn giản đến phức tạp thì một trong những cái tiêu chí quan trọng nhất hoặc là những các cái tiêu chí quan trọng nhất để có thể là giảm thiểu cái rủi ro cũng như là đảm bảo cái độ thành công của dự án. Thứ nhất đó là chúng ta có chủ tư có một cái mong muốn một công trình tốt. Thứ hai là đưa ra cái quyết định lựa chọn về thiết kế cũng như nhà thầu chính xác. Và thứ ba, đặc biệt rất quan trọng, tôi hoàn toàn đồng ý với anh Tiến, đấy là niềm tin. Niềm tin là cái gì mà chúng ta phải nên có ngay từ đầu. Các bên tin tưởng nhau thì sẽ cùng nhau tạo nên một tác phẩm tốt. Và tôi cũng rất hy vọng là trong cái thời gian rất là ngắn của cái buổi tọa đàm ngày hôm nay thì cũng có thể chia sẻ đến quý vị những các cái ý kiến, các cái góc nhìn khác nhau từ nhiều các khách mời với nhiều vai trò khác nhau để chúng ta có thể có một cái nhìn tổng quát về triển khai một cái dự án facade. Thực ra ở Việt Nam thì facade là một cái gì đó khá là mới mẻ. Tuy nhiên thì tôi có thể nhìn thấy là trong những năm gần đây chủ tư đã quan tâm nhiều hơn và cũng đã chịu khó đầu tư hơn, và các nhà thầu cũng trở nên chuyên nghiệp hơn để tạo nên các công trình, đặc biệt là Hà Nội, Thành phố Hồ Chí Minh. Hiện tại thì rất nhiều công trình có những cái facade tốt được thực hiện bởi những tư vấn tốt và nhà thầu tốt. Thì cũng rất hy vọng là trong tương lai chúng ta sẽ có nhiều công trình để có thể gặp lại nhau và nói chuyện trong một cái buổi tương tự như này. Thì rất cảm ơn tất cả khách mời đã tham gia buổi trao đổi ngày hôm nay. Chúc sức khỏe tất cả mọi người.
Thank you. Thank you. Thank you.
Cảm ơn phiên tham luận rất bổ ích vừa rồi. Tôi xin phép mời các diễn giả chúng ta nán lại trên sân khấu trong một ít phút để nhận kỷ niệm chương từ nhà tài trợ. I would like to invite the speaker to stage back on the stage to receive the mementos from the sponsor, Mr. Kugle, Sucor Vietnam.
So Joerg, can you come on stage, or your team, whoever is giving that? While Shuko is giving the mementos out, I'd like to thank all of you for attending today's event. I hope you enjoyed it. As I mentioned this morning, we've recorded the event. We share a YouTube link of all the presentations we've got permission to share with you. And you can review today's day in case you missed anything. Thank you so much for attending today's event. We look forward to hosting you next time when we return to Vietnam. Also, we have a cocktail networking session by Shuko. It's on level 7, so we are on level 5. On level 7, we've got the cocktail session by Shuko. Those who would like to join us can join us on level 7. So thank you all for attending today's event. We look forward to hosting you next time soon. Thank you. Thank you. Also, before I forgot, sorry, a round of applause for our event host, Jolene, for doing a great job. So thank you so much, Jolene. Thank you all. We look forward to seeing you on top on level 7 for the cocktail session. Thank you.